Agricultural Research and Environment, chaired by the gentleman from New York, Mr. Scheuer, and the Subcommittee on Energy and Environment of the Interior Committee, which I have the honor to chair. Our purpose today is to discuss nuclear winter. This is a matter of such importance that Mr. Scheuer and I decided to hold a joint hearing since we had scheduled separate hearings, and this seemed a more efficient and effective way to go. I hope that today's testimony will result in a better understanding of questions that nuclear winter immediately calls to mind. What is it? What are its effects? How does it change our thinking about nuclear war? What should nuclear winter cause us to do that we had not done before we knew about it? Another question. Some of today's witnesses will describe the nuclear winter phenomena. Others will tell us how they believe our strategic posture should be modified in the light of it. Before we begin, I want to say that it troubles me that we were nearly into the 5th decade of the nuclear era before our military planners explicitly accepted the potential destructiveness of the climatic effects of nuclear war. Such effect, it is now believed, could rival the damage resulting from more familiar effects of blast, fire, and fallout. It's worth reflecting upon the consequences of an attack by our Strategic Air Command on the Soviet Union had it occurred in the late 50s or early 60s. At that time, by all appearances, we possessed an overwhelming superiority. Our military leaders had reason to assure the President that the United States could attack the Soviet Union and expect little or no retaliation. If, on the basis of such advice, the President had decided in such a crisis to launch an attack, our targeting doctrine, I've been told, would have led to the detonation of thousands of megatons over Russian cities. The result would have extended far beyond destruction of the Soviet society. Some scientists now believe that such an attack would very likely have created catastrophic climatic changes in the Northern Hemisphere. Had this happened, our own society might have been destroyed even if the Soviets had not been able to launch a single weapon. If nuclear winter could creep up on us this way, what other surprises might be in store? The discovery of nuclear winter is an anticipated development that means nuclear war would be even worse than we had feared. By the nature of things, the unexpected is more likely to fall on the negative side of the ledger. Nuclear winter was found on ground that had already been well plowed by strategic theorists and planners. The failure of analysis is the sort of event that should lead us to question confident assertions that security might lie in the next technological breakthrough. We should, for example, be skeptical of promises that a Star Wars defense will allow a move away from a strategy of mutual deterrence based on fear of annihilation. Star Wars, we are told, could make possible a strategy based on defensive systems, and as desirable as this might be in principle, it is unlikely to work out in practice. In fact, by its nature, Star Wars would probably do more to create tensions than to reduce them. Finally, I hope we will not be distracted by snake oil. The belated discovery of nuclear winter should help us to realize at long last that the path to peace may be through arms control rather than through a never-ending succession of weapon systems disguised as bargaining chips. The gentleman from New York, Mr. Scheuer.
Thank you very much, Mr. Chairman. I want to express my appreciation to you and your staff for the wonderful cooperation you've extended our staff in working out this joint hearing. It's appropriate today that we have this joint hearing inasmuch as today is the first day of serious discussions of nuclear countdown, nuclear strategy that will be taking place in Geneva. Under the nuclear winter theory that we're discussing, the fierce aftermath of a nuclear attack would send plumes of smoke, soot, and dust from burning cities, industrial sites, and forests lofting high into the atmosphere. And within weeks, these particles would cover the northern hemisphere and slowly drift into the southern hemisphere, blocking out most of the light and drastically reducing land temperatures. Under such conditions, survivors of a nuclear holocaust would face extended darkness and freezing temperatures. Rivers and lakes would freeze over, plant life would wither, and food production would be virtually eliminated in the ghoulish season of nuclear winter. The so-called victors of such a terminal battle would have little in the way of the spoils of victory as the effects of nuclear winter spilled over the far corners of the remnants of our Earth. It's apparent that the implications of nuclear winter impose new realities of nuclear arms control strategy and nuclear deterrence. At the very least, the nuclear winter theory raises profound implications for the U.S. and presumably for our Soviet colleagues too, imposing on all of us the necessity of new thinking, creative thinking, on issues such as nuclear weapons planning, procurement, deployment, targeting, and command, as well as for arms control and civil defense. Much of today's hearings will focus on the recent Department of Defense report, The Potential Effects of Nuclear War on Climate, which was requested by our distinguished colleague from Colorado, Tim Wirth, who is here with us today. In my view, it's difficult to square the 17-page DoD report with a mere 5 or 6 pages devoted to the policy implications of nuclear winter with the statutory mandate imposed by our Congress on the Secretary of Defense to conduct a detailed review of the current scientific studies, and I quote, a thorough evaluation of the implications of the theory, and a discussion of the manner in which the results will be incorporated into nuclear weapons, arms control, and civil defense policies. Nor are we assured by the level of resources committed by the Department of Defense to the study of this policy. Despite an overall weapons research and development budget of over $39 billion, the DoD requested a meager $2.5 million, less than half of the amount that the President's own science advisor, George Keyworth, requested for this study. Public debate on this issue must proceed from a careful scientific base and be guided by the best evidence available. Our intent is to air this evidence as openly as we can today. The issue of nuclear arms strategy and tactics and the impact that the theory of nuclear winter would have on that strategy is an issue which transcends all others in importance. Indeed, the fate of mankind rests in the balance, rests on our ability to cope with these incredible forces which man's ingenuity has unleashed.
Do you want to introduce the others, or do you want me to, or what?
Are there further opening statements? Mrs. Schneider?
I would like to commend my 2 colleagues and the 2 chairmen of the joint committees here for convening such a hearing. I think that there is very little question that the hearings that we're holding today are of profound importance. I recognize also that in the public's minds there is a feeling that we are facing disaster at every turn and that calamity lurks behind every bush. This is very unfortunate because far from crying wolf, the information that we are going to be receiving today is from scientists who represent a variety of disciplines on a topic that is as important as any that we are ever likely to face, the ecological consequences of nuclear war. The report that has been released by the Pentagon on March 1, called The Potential Effects of Nuclear War on the Climate, is an important addition to the awareness on the atmospheric side effects of nuclear war. But unfortunately, this report does not add much to our understanding of those effects, nor to the development of a mechanism to further investigate this problem. I find it unfortunate that the report carried a tone of defending current policies. To state that it is not our policy to target population centers is of very little solace when the destruction of the world's ecosystem is a possibility. Also, the strategic defense system would, in fact, discourage the Soviets from increasing their nuclear arsenals is the result of the report, and I think also a result of delusional thinking. To suggest, as the report does, that fire effects could be reduced by detonating the bombs closer to the Earth, and then as a postscript adding that such a tactic would be an increase in fallout, points out the critical need for understanding that a nuclear war would be totally unlike anything we've ever experienced on Earth. Uncertainty is the hallmark of our understanding of the possible side effects of a nuclear war. In the last 40 years, we've certainly had the opportunity to experience much with nuclear weapons. We've learned that we are capable of totally destroying cities, causing burning, mutilations of various victims, and when exploded in the atmosphere that they produce radioactive fallout, can cause illnesses, large amounts of dangerous byproducts, including strontium-90, could enter our food chain. But I guess the worst news about the nuclear weapons that we are currently developing is what we don't know. We don't know how many explosions the planet can absorb before it is permanently altered. We also don't know how the ozone layer might be affected by high-level bursts. We also don't know what it means to win a nuclear war. This examination of the potential for a nuclear winter needs to be expanded so that we can understand the lowest limits of irreversible damage to the ecosystem. It needs to be developed by a group that is independent, that has total and complete access to required information, and that is led by individuals who are courageous enough to follow the data wherever that may lead. We have a responsibility as members of Congress to ensure that every policymaker in the world is aware of these findings. Albert Einstein had said that the nuclear age would change everything. Well, everything except the way we think. Certainly, we have a continuation of the view of warfare that is as ancient as the practice itself. The more weapons, the better. Unfortunately, it will be exceedingly difficult to change that kind of thinking. Congress is constantly faced with the demands for additions to our nuclear arsenals, and the fact that we respond so readily is evidence of our failure to recognize that we have crossed an important threshold, one that demands a fundamental rethinking of the manner in which we provide for our defense. Thank you, Mr. Chairman.
Distinguished gentleman, New Mexico is ranking Republican on our subcommittee. Is recognized for an opening statement.
Thank you, Mr. Chairman. We in this country believe that the nuclear winter issue is of serious concern and should be studied. The Soviet Union is not taking the nuclear winter issue as seriously as the U.S. does. There are some major questions about the nuclear winter scenario. It hypothesizes that half the world's arsenal of nuclear weapons would be detonated. Frankly, many people do not consider that to be a credible scenario. Has an analysis been done of other scenarios where less weapons are detonated? Do the results of such an analysis also produce a nuclear winter? Likewise, the nuclear winter scenario depends on the release of large amounts of smoke and dust into the atmosphere as a result of massive fires started by nuclear weapons effects. There's a wide range of variation on how much smoke and dust would be produced. Clearly, a key research need is to better refine the estimates of how much smoke and dust will actually be produced. This committee's jurisdiction is civilian R&D. We should look into whether the existing research efforts in climatic effects and fire, etc., are useful in analyzing the nuclear winter scenario. We should also consider whether the research efforts in studying the nuclear winter possibility will provide helpful insights into understanding natural phenomena of peacetime interests. The nuclear winter issue should be taken seriously. We should ask, what are the policy implications of the possibility of nuclear war? The most obvious one is that we should avoid a nuclear war. Since the possibility of nuclear war is being viewed with universal horror, it is hard to imagine that we need to have our resolve to avoid a nuclear war strengthened. The second policy implication is that we should work towards arms reduction. Right now, the U.S. is meeting with the Russians in Geneva for that very purpose. Clearly, we're proceeding along the proper lines. If indeed we reach agreement on arms reduction, it will only be meaningful to the extent that all parties comply with the agreement. The U.S., being an honorable country, will clearly comply with any treaty on arms control. We need to verify that the Soviets would also comply. Therefore, we should ask whether or not the present technologies of verification are adequate. And also, we should consider what additional research and verification technologies should be studied. Finally, the nuclear winter scenario tells us that we need to think about other possibilities for defending our country that do not rely on nuclear weapons. Is the President's Strategic Defense Initiative the answer? Mr. Chairman, I will look forward to the answers to these and other questions during the hearings of the various witnesses. Thank you.
Gentleman from Colorado who's been a leader among those of us concerned on this issue.
Thank you, Mr. Chairman. I want to thank you, Mr. Schroyer, for such prompt response to the report that came from the Pentagon and having this hearing, I think, now just 12 days later. I would also like to associate myself in particular with the remarks of the gentlewoman from Rhode Island, who I thought was very, very clear and careful on the subject. Here we have the Pentagon effectively agreeing that the concept of nuclear winter is a valid concept, but the next step, what are the implications of that, appear to be ignored. What are the implications for the notion of first strike? What are the implications for the question of survivability? The Pentagon seems to say to us, even though we recognize that nuclear winter is a valid concept, the implications are that we should continue to do more of the same. It just doesn't seem to me to be a logical conclusion from the evidence that's available. That's why we're having this hearing today, is to see if that logic holds up or if there are further implications for the Pentagon that they should be pursuing in response to the law passed by the Congress requiring them to look at this in great detail. Look forward to this hearing, and I, again, gentlemen, thank you very much for putting this together.
Further opening statements? If not, we'll proceed with our first witness today, who is Dr. Carl Sagan of Cornell University, who's been in the forefront of the discussion on this important subject. Dr. Sagan, you're kind to be with us today, and we'd be glad to hear from you.
Thank you, Representative Udall. I'm very pleased to be here. Can somebody turn my microphone on? Thank you. I can do it myself, I see. Some years ago, when the first results of our study, the so-called TAPS study on nuclear winter, were becoming clear to those of us working on it, long before it was publicly released, it became clear to me that there were serious policy implications on the issue, not only the consequences in the Northern Hemisphere, but the consequences elsewhere in the world, the possibility which emerged clearly from our calculations that something much smaller, Representative Lujan, than a full exchange would still lead to almost the same effect as the full exchange, provided cities were targeted. In fact, on that, one of our cases was a case where less than 1% of the world's strategic arsenals were employed, but artificially constrained to be targeted on cities only. And there we got temperature declines of tens of degrees for months. So being a novitiate in this strange subject, I felt the need to talk to more experienced people, and we were able to put together a private discussion, in fact, here in the Capitol, with a range of senior workers in this field in previous administrations and other masters of dark arts. And the distribution was very good. The most senior member of the group who was there was Averil Harriman, in fact. And at the end, I presented what the scientific results were, presented some hint of what seemed to me the policy implications. And one response by a senior practitioner was the following. He said, "Look, if you think that the mere prospect of the end of the world is enough to change thinking in Washington and Moscow, you clearly have not spent much time in those places." And so by these standards, perhaps the Department of Defense report represents slight progress. I see in the charge given by the Congress to the Department of Defense requests for, quote, comprehensive study, requests for, quote, detailed review, requests for, quote, thorough evaluation. And I must say, I do not see this report as coming within light years of that requirement. If this were a paper assigned in a graduate seminar at Cornell University, I think I would give it a D, maybe C minus, if I was in a friendly mood. For 40 years, the Department of Defense has in effect assured us that there are no long-term climatic consequences of nuclear war, that the climate is not endangered. There are reports by the government through the years saying nothing to worry about. Then some scientists stumble upon a possible global climatic catastrophe, attendant, as I said, even to a relatively small nuclear war. At first, we hear that this is liberal propaganda or distortions invented by proponents of a nuclear freeze. Then there are other studies. They tend to confirm the general picture. then the National Academy of Sciences, the Royal Society of Canada, the Pontifical Academy of Sciences, the President of the United States, and eventually even the Department of Defense acknowledges that there might be something to worry about here. Nuclear winter, if it were brought about, would be a disaster unparalleled in the history of the human species. And what is the Department of Defense's response? It's that while nuclear winter might happen, there are significant uncertainties, of course, nothing has changed. That the correct answer to nuclear winter is to continue to build many more weapon systems in aid of reducing weapon systems at some future unspecified time. Peculiarly, nuclear winter turns out to justify all the policies that the administration has just embarked on. Remarkable coincidence. There are no agonizing reappraisals. There are no changes in doctrine or policy. From their point of view, the discovery of a doomsday machine hiding in the arsenals of the United States and the Soviet Union hardly matters at all. It doesn't change anything. And by comparison, let's compare this with the study released just 2 months earlier by the Royal Society of Canada, the equivalent to the National Academy of Sciences of our northern neighbor, which says, "We conclude that the nuclear winter hypothesis does indeed modify the global strategic position," and then they go on to indicate in what way. And I'll mention a couple of things about that report in a moment. Mr. Weinberger's 70-page report talks about the possibility that dangers from nuclear winter will be comparable to the other horrors of nuclear war. Well, how bad are those other horrors? According to a study by the World Health Organization, chaired by Nobel laureate in medicine Sune Bergström of Sweden, as many as 1.1 billion people might be killed outright in a central exchange involving not just the United States and the Soviet Union, but Europe, China, and Japan. And another 1.1 billion people would die subsequently from the prompt effects if they did not receive immediate medical attention, which of course would be unavailable because the doctors and hospitals are by and large concentrated in the target zones. Well, 1.1 plus 1.1 equals 2.2. 2.2 billion people, according to this estimate. It obviously nobody knows for sure. It might be more, might be less. Well, that's roughly half the people on the planet, just a little less. If, as the Department of Defense now acknowledges, the long-term effects, radioactive fallout, nuclear winter, and so on, might be comparable or even larger, then the Department of Defense now acknowledges that nuclear war might mean the extinction of the human species. And in that sense, this represents an interesting departure for the Department of Defense. Certainly, I would say nuclear war means the destruction of our global civilization, and a not incidental aspect of which would be the destruction of the United States as a functioning political entity. Nuclear war is bad for government, bad for labor, bad for business, bad for people on a scale that remains unreflected, as far as I can see, in this administration's policies. Now, one significant consequence of nuclear winter is that nations far removed from the conflict, nations, if there are any, that have no part of the quarrel between the United States and the Soviet Union, nations in the Southern Hemisphere, might be utterly destroyed without a single nuclear weapon falling on their territories. It's a possibility. You will hear later from Dr. Schneider and others on recent work on involvement of equatorial and southern latitude regions. The Royal Society of Canada says, quote, "Nuclear winter globalizes the environmental impact of nuclear war," close quote. There is no hint of this in Mr. Weinberger's report. There is no reference to the Royal Society of Canada report. There is also no reference to a report done by a branch of the Air Force, a branch with what I think is the best acronym in the business, CADRE, C-A-D-R-E, the Center for Aerospace Doctrine Research and Education at Maxwell Air Force Base in Alabama. This report was prudently commissioned by the Office of the Department of Defense something like a year ago. Mr. Wagner will doubtless be able to tell us more details about that. I visited with them in the early days of their work. This is a bunch of majors and lieutenant colonels and some faculty members from University of Alabama, Georgia Tech. Seemed to me very good, very broad, very conservative. Well, they've produced a report. Nobody seems to know where it is or what's in it. I understand it was published in January. What is in it? It'd be most interesting to know what this branch of the Air Force designated to study the policy implications of nuclear winter has to say about it. Also be interesting to know, why is it that that report has not been released? The military implications of nuclear winter seem to me to be very broad. For example, consider the question of battle management and damage assessment. There is a nuclear war. You have launched some warheads. You wish to see whether they have done what they're supposed to do. How do you find that out if the target zone is socked in with smoke and dust and fine debris? That is a narrow military consequence of nuclear winter. There's no hint in the Department of Defense's report that anything like that might be of interest to them, although doubtless it is. And then there are additional ranges of questions from how well do tanks function at -10 or -20 degrees centigrade? How well do air-breathing engines do in soot? All the way to major strategic questions, for example, the credibility of the policy of extended deterrence against a Soviet conventional attack in Europe in the face of nuclear winter. Put baldly, would the United States risk nuclear winter at home in order to defend West Germany? That seems to me an issue worth thinking about. Are there implications for protracted wars? Do we have to envision submarines that sit in the abyssal depths for 6 or 9 months until the soot from the first minor exchange, if we could imagine nuclear war so limited, settles out so that we can then have the second round? It seems to me that even from the narrowest of perspectives of the Department of Defense, this report is inadequate. The report does worry about what is generally called an asymmetry of perception. What if the United States is worried about nuclear winter and the Soviet Union is not worried about nuclear winter? Might there then be some strategic advantage that redounds to the Soviet Union because they are, in this hypothesis, too foolish to see what the consequences of nuclear war are? Should we also be too foolish to see what the consequences of nuclear war are? It's a very curious question, and it has lots of good answers. For example, a major high-level joint study between the United States and the Soviet Union of the policy implications of nuclear winter. If the administration is worried about what the Soviets know and believe, there are means to find out. There are means to enlighten the Soviet Union on this issue if there are some deficiencies felt. Now, asymmetry of perception is one thing. Asymmetry of vulnerability is another. Is there a difference in the consequences for the United States and the Soviet Union if there were a global or even northern mid-latitude nuclear winter? Let me read 3 sentences from the Royal Society of Canada's report. The Soviet Union's sensitivity to small climatic fluctuations is well known. Since 1972-73, they have endured repeated drought-induced or frost-triggered crop losses on a staggering scale, mostly in the new lands opened up in the last 2 decades. The nuclear winter hypothesis predicts much larger stresses for the interior of Eurasia. A nation hard-pressed to cope effectively with current natural climatic variability will face a vastly greater threat. There is no hint of asymmetry of vulnerability in the Department of Defense report. There is nothing on implications for agriculture at all. Nothing on biological implications, except that they probably would be bad. Nothing on the functioning of society after a nuclear war as a consequence of nuclear winter. Let me again just pull out the Royal Society of Canada's report. Royal Society of Canada is a very small organization, very limited resources compared to those of the Department of Defense. Here, for example, Mr. Chairman, is a graph of how the area of Canada capable of growing mature wheat declines as there are temperature declines. So with a 1-degree decline, it's all down there. With a 2-degree decline, there's hardly any place left in Canada where wheat can still grow. Be very interesting to see this graph extended into the United States. What temperature declines are necessary to wipe out agriculture in the American Midwest? This is surely within the ability of the Department of Defense to do. No hint of any such study is shown here, and incidentally in the greatly attenuated national plan for studying nuclear winter, there is no money at all allocated for biological, agricultural, social, or other implications. It's all, and strategic implications. Everything is in the physics. Now, it is, to me, remarkable that there is virtually nothing in this report about the implications of nuclear winter for the relations of the United States with other nations. And there have been, within the last year, some dozen prime ministers, other national leaders of various nations, most of whom are allied with or friendly to the United States, expressing grave concerns about whether nuclear winter has implications for those nations and their relations with the United States and the Soviet Union. And these proposed implications go all over the lot. Some nations concerned that nuclear winter makes them much more vulnerable. But other remarks, for example, one which, if I read it right in the New York Times, attributed to Prime Minister Papandreou of Greece, says if there's nuclear winter, then Greece will be destroyed anyway, never mind whether Soviet nuclear weapons fall on Greece. So what the heck, we might as well have American military bases here. At least that's what it seemed to me the New York Times was saying. I may have misread it. An unexpected consequence. Now, on the question of funding for further research, I've indicated, first of all, the grave omissions in the plan that was encouraged by the President's science advisor, George Keyworth, and as far as I can tell, Mr. Keyworth did a very good job in recognizing the seriousness of the problem. Originally, this was supposed to be $50 million over 5 years. It now has been reduced to something like half of that. And there's an interesting question about how much of that is really new money and how much of that is simply relabeling money that has been already programmed to study areas of this sort. Also, an important part of the administration's funding plan is how little money is given to the National Science Foundation, which is, as far as I can tell, the sole source of support for university scientists, independent scientists, scientists not already working for the Department of Defense or the Department of Energy, to study this. I'm sure the administration does not wish to have its funding plan be misinterpreted, that the administration is afraid to sponsor further research on the subject by those who are not directly under their thumbs, university scientists especially. It is now subject to such a misinterpretation. For 40 years, this administration, most of the principals in it, have been implacable foes of arms control. Now, we are told, and this seems to be one of the principal conclusions of the Department of Defense's report, they say, in effect, give us $1 trillion more or less for Star Wars, and another $1 trillion more or less for new offensive weapon systems, and trust us. We are dedicated to arms control. The Department of Defense is full of people, I know from first-hand discussions, with grave misgivings about current strategic policies, current arms buildups, and Star Wars. I find it remarkable that the DoD does not consider it its duty to present both sides of the argument. Congress does not hear from experts within the government who have grave doubts on these issues. Loyalty to the official doctrines of the moment is the paramount consideration. Whereas a free debate in which both sides are confident that under those circumstances the truth will out, that seems to me the prudent approach to issues of this magnitude and this difficulty and this seriousness. Mr. Chairman, I have just a couple of concluding remarks, and they are on Star Wars and the connection between Star Wars and nuclear winter. And I do this only because Star Wars seems to be the leitmotif of the report by Mr. Weinberger on nuclear winter. First of all, everybody acknowledges that fully impermeable strategic defense systems are not in the cards, certainly not for the next few decades. I point out that a system which is between 90% and 99% impermeable, far in excess of what most even sympathetic critics believe can be done, that such a system would permit enough Soviet warheads through an essential exchange to destroy the United States. So even after $1 trillion, there is a very serious question of whether the United States could survive a nuclear war. I also point out that if it is true that the destruction of 100 cities, something like that, is enough to trigger nuclear winter, even a full-up Star Wars system might not be able to stop it. And if there were an exchange and the Soviets did not have their own strategic defense system, then American attacks on the Soviet Union alone would be sufficient to trigger nuclear winter, at least possibly. Second point is that one of the major Soviet responses, they've already publicly announced that they would be driven in this direction if the United States appeared ready to go ahead with a serious strategic defense initiative, is for the Soviets to build more offensive nuclear weapon systems, to saturate, to overwhelm the defense system. But that is the worst possible case for nuclear winter. What nuclear winter says is that there are too many nuclear warheads in the world. And for the response to nuclear winter to be a sequence of events which leads to the Soviet to greatly increase their arsenals seems to me profoundly foolish. Star Wars is a kind of Maginot Line in the sky, and it has all of the deficiencies of the standard Maginot Line, except that it's vastly more expensive and that it can lead to much graver consequences even than the Maginot Line mentality did. Now, the actual situation to bear in mind in a full exchange some decades from now with a Star Wars system is to imagine something like 10,000 nuclear warheads in the air from the United States towards the Soviet Union in near space, surrounded by a cloud of something like 1 million decoys and penetration aids. Your job, should you choose to accept this assignment, is to pick out every one of the 10,000 warheads, ignore every one of the 1 million penetration aids and decoys, and you have 10 minutes or less to shoot down all the warheads. If you miss a few percent, everybody is dead. That's your problem. You're willing to bet your life on a battle management computer where the program is too difficult to be written by human beings. It has to be written by other computers. The program is too difficult to be debugged by human beings. It can only be debugged by other computers. The system cannot be tested at all, short of a nuclear war. And now, the system can only be operated by a computer. No humans involved, except for the consequences. And if the system fails, the world is destroyed. Now, I submit to you that you have to be really Looney Tunes to bet the human race on this one. The only way to be really sure is for major, dramatic, bilateral, verifiable cuts in the strategic arsenals. Congresswoman Schneider quoted Albert Einstein, who said in 1945 that the advent of nuclear weapons had, quote, changed everything except our way of thinking, and thus, he said, we drift towards unparalleled catastrophe, close quote. That's what's most missing from this report, even a hint of a change in our way of thinking. Thank you very much.
Thank you, Dr. Sagan, for a provocative and interesting introduction to this important subject today. We apparently have good attendance from both subcommittees. I suppose we ought to operate under the 5-minute rule in fairness to everyone.
Yes, indeed.
All right. I'll defer to my colleagues and begin with the co-chair of these hearings, the gentleman from New York, Mr. Schroyer, recognized for 5 minutes.
Thank you, Mr. Chairman. Dr. Sagan, you've given us a great deal to chew over. And the question is, where do we intervene? Where do we crank in this new factor of nuclear winter into existing arms control strategy of all kinds? The Defense Department does have some ameliorating limits on nuclear hits, for example. They have, under the COP, the Single Integrated Operational Plan, they do have a criteria known as restraints on collateral damage. And that means that they will normally use the smallest weapon to take out whatever the target is. They won't engage in overkill on any one target. Now, that seems to indicate at least a move in the right direction, that they are thinking of minimizing damage above and beyond what is necessary to take out a particular target. Can you conceive of another criteria that would involve perhaps an urban fire critical mass, which is what produces nuclear winter, that would take into account number of weapons, kilotonnage of weapons, number of cities hit, the spread, the distance between cities, prevailing winds, temperature, time of year, and so forth, that would give the Defense Department some kind of maximum number of nuclear weapons, total kilotonnage, distribution, and so forth, that would provide a further limiting criteria, as they've already established one, but this would be a further limiting criteria addressed to the concept of nuclear winter and addressed to the concept of avoiding whatever the threshold is, assuming there is a threshold, and that we don't just move gradually by incremental steps into a darker and darker and darker period. Can you think of some way that under this overall master plan that they call COP, such a factor could be introduced?
Well, first of all, the United States is not the only power that can trigger nuclear winter. So even if we were 100% convinced that the latest PSYOP makes every effort under firm controls not to target populated areas, not to do all the things that would maximize nuclear winter, there is the question of the strategies of the Soviet Union, Britain, France, and China, all of whom, as far as we can tell, might have arsenals large enough to trigger nuclear winter, and the last three mentioned, because of the nature of their arsenals, are primarily targeted on cities, entirely Soviet cities. So that's the first concern that I would raise about this issue. Any solution to this problem that involves targeting raises questions of verification. How will the Soviets be able to believe us that we don't target Soviet cities? How will we be able to believe the Soviets that they don't target American cities? Will we have American military officers looking into the innards of the guidance system program of Soviet missiles? Will we allow Soviet officers to do the same for American missiles? It seems extremely unlikely. And therefore, bland assurances on the nature of the PSYOP or the RISOP, the Soviet equivalent, simply don't carry much weight, it seems to me. On the question of whether U.S. PSYOP does or does not maximize nuclear winter, there are a diversity of points of view. For example, Admiral Noel Geiler, the former deputy director of the Joint Strategic Target Planning Staff, the guys who do the targeting, said in testimony before the Joint Economic Committee, can't remember, some months ago, that the co-location of strategic targets and cities and strategic targets and forests was so great that even an exchange which was designed only to hit strategic targets would burn cities. And along those lines, the report by Mr. Weinberger that we heard talking about has a very curious phrase. It says, "Our strategy consciously does not target population." Now, maybe consciously means intentionally, or maybe consciously is intended to be counterpoised to unconsciously. It's very hard to understand how you could imagine a central exchange in which submarine ports are not targeted, they're in cities, in which secondary airfields distributed over a country are not targeted, they tend to be in cities, in which command and control facilities are not targeted, they tend to be in cities. Any thought of decapitation involves targeting cities, and it would be very interesting to hear a presentation on precisely how it is imagined that there would be a nuclear war at various levels in which cities are not targeted. Maybe there is such an explanation.
Well, isn't that a sort of a semantical problem? It seems to me a little disingenuous for either our country or the Russians to say they don't target cities.
I agree
with
you
you. What they
entirely.
do is target strategic targets,
That's
industrial targets, government targets, and so forth, and they are generally located in cities.
By accident.
By accident.
Everybody's highly moral. Nobody intends to kill people. It just turns out that strategic targets kill people. That attacks on strategic targets kill people. One final thing on that, Congressman Scheuer. I'm not sure to what extent Congress has oversight on PSYOP. But it seems to me it's clearly and properly a highly classified area. But it seems to me that because the details of the targeting are now of general concern, that it would be useful for some selected members of Congress under some properly secure circumstances to look into PSYOP and see if what is alleged is in fact true.
I couldn't agree with you more on that. There seems to be an urgent need for congressional oversight. We all have a top security clearance, but it seems to me that at a minimum, the members of the Armed Services Committee, the Foreign Relations Committee, and the Intelligence Committee should be briefed and should be involved, not only in briefings, but in input on just the kind of value judgments that we have been talking about. How do we factor in the concept of nuclear winter in our COP plan? Thank you, Mr. Chairman.
Gentlewoman from Rhode Island.
Thank you, Mr. Chairman. Dr. Sagan, I'm curious about which of the many uncertainties we ought to attack first. The Department of Defense recognizes the importance of improving our understanding of some of the technical underpinnings of the convincing hypothesis of a nuclear winter. And I'm just wondering, to what degree is there some variation on the actual quantitative impact of a nuclear winter? The Lawrence Livermore National Laboratory has suggested that this concept may include, the whole concept of a nuclear winter could include a whole range of possibilities and not just an extended period of sub-freezing weather. The fact that there would be firestorms and the heat would rise, thereby minimizing the freezing temperatures. How quantitative can we get in the predicting of this information, and should we seek further research into this area on the part of the Department of Defense or other federal agencies?
Nuclear winter is not a problem amenable to experimental verification, at least not more than once, and few of us wish to perform the experiment. It is therefore restricted necessarily to the best theoretical physics, the best computing programs, and the best small simulations that can be managed. every one of those, of course, should be vigorously pursued. And I'm concerned that the level of funding that the administration, under restricted budgetary circumstances to be sure, has proposed is inadequate. But at the same time, and by the way, other witnesses will provide their opinion on the degrees of uncertainty, Dr. Carrier, for example, who chaired the National Academy study. But at the same time, it seems to me it would be a grave error to say that we should not look into the biological, the societal, the strategic implications of nuclear winter until all the facts are in, because all the facts may never be in. Here is a sentence from the Royal Society of Canada report on this very question. At some point, the strategists have to accept the probability of the predicted consequences and incorporate that judgment into their thinking. Scientists tend to cloak their predictions in a shroud of ifs and buts. The Royal Society of Canada is not criticizing scientists. That's the nature of scientific work. But every aspect of the nuclear strategic issue is surrounded by uncertainties. And there are uncertainties. We just talked about one. What are the Soviet psyops? What are the American psyops? What is the uncertainty of the Strategic Defense Initiative? What is the uncertainty of the gaps, the famous window of vulnerability? How uncertain was that? It drove the arms buildup partly that we are now in. I would like to see an even-handed concern about the reliability and verifiability of every aspect of this problem.
Okay, let me also ask you, the Department of Defense report reviews some of the Soviet perceptions, and the conclusion that they reach is that the Soviets have really done very little work on this subject. Are you in agreement with that?
The Soviets, in my view, have not done nearly as much as they should, and I hope will. It is, however, fair to say that the first three-dimensional general circulation model applied to this problem that gave results, or at least one of the first two, was a Soviet program, admittedly run on a computer with roughly the capability of an IBM PC, and with a program that ultimately comes from Oregon State University. But they at least did the study. The Vice President of the Soviet Academy of Sciences, Yevgeny Velikhov, told me that he has a budget of 2 million rubles for the next few years to work on this problem. It'll be very interesting to see what the money is used for, if it is. But if we are to believe his statement at face value, the Soviet program is roughly of the same order of magnitude as the present U.S. program. But I think it is absolutely proper to raise public concerns about the level of the Soviet research effort in this area.
Have you been involved or had the opportunity to review some of the data that's being put together by other federal agencies, such as, for example, NOAA, who is reviewing the climactic alterations and to some degree the biological impacts of a nuclear winter?
I was a consultant to the National Climate Office at NOAA that put together a plan to study nuclear winter. I was one of the reviewers of it. I thought it was by and large a very good plan, and I testified, I believe, before Mr. Shory's committee to that effect. But it is greatly compromised by being restricted only to the physical effects. Nothing about biology, nothing about society, nothing about policy, strategy, and doctrine.
I think in the federal government could best supply us with a societal analysis of the impact of the nuclear winter?
Good question, and I had correspondence with Mr. Keyworth on just this issue. I believe that this, as many other aspects of the nuclear winter implications question, ought to be farmed out to universities, research institutes, and so on, and not restricted to the federal government.
Thank you very much.
Gentleman from Colorado.
Thank you very much, Mr. Chairman. Dr. Sagan, again, thank you for your help. When Congressman Leach and I initially proposed this amendment and it was passed by the Congress, it was our belief that this was an enormously important discovery, nuclear winter, and that the Pentagon should do two things. First, the Pentagon should come back to us and tell us if they believe that the concept of nuclear winter was valid. And second, if it was valid, what then were the implications? On the first, they have come back to us and said, yes, it is valid. On the second, from your testimony, and I would suggest from my own reading, they have not come back to us and really told us what the implications of this might be. Now, you said that if this were a graduate paper at Cornell, you might generously give it a D. Other actions that you have would be either to throw the graduate student out of school.
Hard to do in this case.
We can't do that with the Department of Defense. We can't throw them out, but we can. The other thing that you do is to say to them, go back and redo the paper.
Right, you give them an incomplete.
Okay, now, it seems to me that we have the opportunity of giving them an incomplete, and one of the obligations that we have, if in fact the concept of nuclear winter does have very broad implications for our targeting, for our arms control initiatives, for how we are developing our whole strategy toward the Soviet Union, then we should go back to them with a series of further questions, which we in the Congress clearly are capable of doing. What would be the first three questions that you would go back to the Pentagon with, saying, assuming that they have agreed that nuclear winter is valid, they have done so, what then are the next three most important questions to face the Pentagon with?
First short-term question I would raise is, please provide immediately the report by Cadre on the policy and doctrinal implications of nuclear winter. I think that would not involve going back and doing any more work. It's just the Department of Defense left home part of the assignment. Then beyond that, I would, my understanding is that that report exists. It's locked up somewhere. And so there isn't any rewriting necessary. It just someone has to reach into the drawer and hand it to the Congress. That ought to be done, it seems to me, if Congress requested, in 24 hours after the request. That should surely be a significant first step.
Okay. All right, our next witness is Dr. Carl Sagan of Cornell University, a man who needs no introduction. He comes to us today from the Center for Radiophysics and Space Sciences. We welcome you, and we're very pleased that you would take the time out of your schedule to come to a place like Washington, where everything seems to be living in today and not in tomorrow, to share with us your particular view of how our past and our present may well affect our future. Carl, thank you very much.
Thanks very much, Senator Durenberger, Senator Gore, Senator Burdick. I'm glad to be here. As I understand my function, it is to give some sense of what the greenhouse effect is, to try to say something about greenhouse effect on other planets, to again underscore that this is a real phenomenon, and then perhaps I can take liberty to say a few remarks about what to do about it. The power of human beings to affect and control and change the environment is growing as our technology grows. And at present time, we clearly have reached the stage where we are capable, both intentionally and inadvertently, to make significant changes in the global climate and in the global ecosystem. And we've probably been doing, on a smaller scale, things like that for a very long period of time. For example, slash and burn agriculture, which has been with us for tens of thousands of years probably, changes the climate to some extent by changing the albedo, the reflectivity of the Earth. That massive changes have occurred is clear from the historical record. For example, Egypt was once the breadbasket of the Roman Empire. It may be the same role as the American Midwest plays today. That is certainly no longer the case. It's not a greenhouse effect issue. It may be an overgrazing issue, but is an example of how humans are perfectly capable of making these unexpected and inadvertent changes. Because the effects occupy more than a human generation, there is a tendency to say that they are not our problem. Of course, then they are nobody's problem. Not on my tour of duty, not on my term of office. It's something for the next century. Let the next century worry about it. But the problem is that there are effects, and the greenhouse effect is one of them, which have long time constants. If you don't worry about it now, it's too late later on. And so in this issue, as in so many other issues, we are passing on extremely grave problems for our children when the time to solve the problems, if they can be solved at all, is now. If you ask what determines the Earth's climate, clearly the main thing that determines it is sunlight. Sunlight is what heats the Earth. Not all the light that arrives at the Earth from the sun goes to heating the Earth. Some of it is reflected back. It's just the part that is absorbed. And what happens is there's a certain rate at which sunlight is absorbed by the Earth's surface, and there's a certain rate at which the Earth's surface radiates to space. What comes from the sun is in the ordinary visible part of the spectrum that our eyes are sensitive to. What the Earth radiates into space is in the infrared part of the spectrum, longer waves than red, that our eyes are not sensitive to, but it's as legitimate, excuse me, a form of light as the kind that we're used to. Now, if you calculate what the temperature of the Earth ought to be from how much sunlight is being absorbed, equaling how much infrared radiation would be radiated to space, you find that the Earth's temperature, by this simple calculation, is too low. It's about 30 centigrade degrees too low. And why is it too low? It's too low because something was left out of the calculation. What was left out of the calculation? The greenhouse effect. The air between us is transparent, except in Los Angeles and places of that sort, in the ordinary visible part of the spectrum. We can see each other. But if our eyes were sensitive at, say, 15 microns in the infrared, we could not see each other. The air would be black between us, and that's because, in this case, carbon dioxide. Carbon dioxide is very strongly absorbing at 15 microns and other wavelengths in the infrared. Likewise, there are parts of the infrared spectrum where water vapor absorbs, where we could not see each other if we were only as far apart as we are in this room. If you add these infrared absorbing gases to a planet, then what happens is the sunlight comes in as before, but when the surface tries to radiate to space in the infrared, it is blocked, it is impeded by the absorbing gases. And so the surface temperature has to rise so that there is an equilibrium between what comes in and what goes out. So this is the greenhouse effect. It is a misnomer for more reasons than one. It's a misnomer in particular because that's not how the florist greenhouse works, but that's a very minor point. There are other gases which absorb in the infrared, many of which have been mentioned already: nitrous oxide, methane, the halocarbons, and these are products partly of agriculture. It's fertilizers, refrigeration, aerosol spray cans, and so on, all products of our technology. We don't generate much water into the atmosphere, but we certainly do generate a great deal of carbon dioxide through the burning of wood and fossil fuels, an apparently benign activity. Who could object to humans burning oil and coal, gas, and wood? I'd like to stress that the greenhouse effect makes life on Earth possible. If there were not a greenhouse effect, the temperature would, as I say, be 30 centigrade degrees or so colder, and that's well below the freezing point of water everywhere on the planet. The oceans would be solid after a while, a little greenhouse effect is a good thing. But there is a delicate balance of these invisible gases, and too much or too little greenhouse effect can mean too high or too low a temperature. And here we are pouring enormous quantities of CO2 and these other gases into the atmosphere every year with hardly any concern about its long-term and global consequences. Now, certainly not all aspects of how increased CO2 and other gases into the atmosphere affect the climate are known. There are still many uncertainties, although the overall picture is, I think, quite clear and quite widely understood and accepted. But there are questions about aerosols, about clouds. You heat up the Earth, how much increase or decrease in cloudiness is there? How does that change the albedo or reflectivity of the Earth? There's questions about the ocean and its response time to an increase in CO2. There are feedback effects, and therefore it is certainly worthwhile to spend some additional money on further research on the subject. Another point is that the significant temperature changes on the Earth between ice ages and out of ice ages, glacial and interglacial time periods, seems to be connected with quite small changes in the amount of sunlight that reaches the Earth due to changes in the Earth's orbital properties. And that is a suggestion that the Earth's climate system may be very delicately dependent on the sorts of factors that we're talking about here. And that's why it makes sense to study past climatic change on the Earth as an attempt to obtain some calibration. Another source of calibration is the other planets. Every planet with an atmosphere has some degree of a greenhouse effect. The most spectacular case by far is the greenhouse effect of Venus. It's the nearest planet. It's a planet about the same mass, radius, density as the Earth, but it is spectacularly different in several respects, one of which is that the surface temperature is about 470 degrees centigrade, 900 Fahrenheit, and that enormous temperature is not due to its being closer to the sun, because Venus is surrounded with bright clouds, and in fact, because it reflects so much light back to space, if that's all that was happening, it would be cooler, not warmer, than the Earth. The reason for this absurdly high temperature on the surface of Venus, which is well understood. I mean, Soviet spacecraft have landed on Venus and, in effect, stuck out a thermometer. There's no doubt that the surface temperature is very high, and later U.S. spacecraft have as well. The reason is a massive greenhouse effect in which carbon dioxide plays the major role. Now, the amount of CO2 in the Venus atmosphere is much larger than here. The atmosphere is almost entirely carbon dioxide, and there's 90 times more of it there than here. But it is an indication of what can happen in an extreme case. You look at Mars or Jupiter or Titan, the big moon of Saturn, and you have additional examples of greenhouse effects, different gases, different amounts of sunlight reaching the surface, different planetary albedos and cloudiness, and in all those cases there is also a greenhouse effect. In addition, it has been possible to calculate those greenhouse effects fairly accurately, so that the kind of theoretical armamentarium which is used to calculate the greenhouse effect changes on the Earth, is also used for other planets and therefore can be calibrated to some extent against those other planets. If we keep coming out with the right answer in all those different cases, then probably we understand fairly well how greenhouse effects work. It would, however, be worthwhile, along the lines that Senator Gore was talking about, to have an increased program through NASA to understand the greenhouse effects on other planets. This might be a very practical application of planetary exploration. As you've heard, the best estimates, they certainly have some uncertainty attached to them, are that at the present rate of burning of fossil fuels, the present rate of increase of minor infrared absorbing gases in the Earth's atmosphere, that there will be a several centigrade degree temperature increase on the Earth, global average, by the middle to the end of the next century, and that has a variety of consequences, including redistribution of local climates and through the melting of glaciers, an increase in global sea level. There is concern on a somewhat longer time scale about the collapse of the West Antarctic ice sheet and a general rise of many, many meters in sea level. So we have a kind of handwriting on the wall. Certainly there's more research to be done, but as I say, there is a consensus. What can be done about it? The idea that we should immediately stop burning fossil fuel has such severe economic consequences that no one, of course, will take it seriously. But there are many other things that can be done. One has to do with subsidies for fossil fuels. More efficient use could be encouraged by fewer government subsidies. Secondly, there are alternative energy sources, some of which are useful, at least locally. Solar power is certainly one that might be of more general use. Safe fission power plants, which are in principle possible. And then on a longer time scale, the prospect of fusion power. Fission and fusion power plants, in principle, vent no infrared active gases, and therefore, whatever other problems they may provide, they do not provide a greenhouse problem. I'd like to close by just saying a few words on the kind of perspective that this problem, as related problems, pose to us. Here is a problem which transcends our particular generation. It is an intergenerational problem. If we don't do the right thing now, there are very serious problems that our children and grandchildren will have to face. It is also a global problem. It is no good if just one or two major industrial nations take major steps to prevent a major increase still further in CO2 and other greenhouse gases, because other nations may, through their industrial development, cause the problem by themselves. And not to say that this is inevitable, but just to give an example. The largest coal reserves on the planet are the United States, the Soviet Union, and China. China is undergoing a very major industrial development. And the burning of coal is certainly something that must be very attractive for the Chinese looking into the future. I would say that there is no way to solve this problem, even if the United States and the Soviet Union were to come to a perfectly good accord on this issue without involving China and many other nations that will be developing rapidly in the time period we're talking about. So here is a sense in which the nations, to deal with this problem, have to make a change from their traditional concern about themselves and not about the planet and the species, a change from the traditional short-term objectives to longer-term objectives. And we have to bear in mind that in problems like this, the initial stages of global temperature increase, one region of the planet might benefit while another region of the planet suffers. And there has to be a kind of trading off of benefits and suffering. And that requires a degree of international amity which certainly doesn't exist today. I think that what is essential for this problem is a global consciousness, a view that transcends our exclusive identifications with the generational and political groupings into which by accident we have been born. The solution to these problems requires a perspective that embraces the planet and the future, because we are all in this greenhouse together. Thank you, Mr. Chairman.
Well, thank you very much. Just a frustration on international amity. some of us made a brief trip in August through Sweden, Switzerland, Germany, and then I went into Poland, and concerned about what we call acid rain and some of those consequences. And as I went, the urge in me for some forum for international amity, it kept crying out, particularly when I got to Poland, which is the home place of my mother's side of my family, and to see the self-destructiveness of that economy and on the people of that country, and the lack of amity on the part of the Czechs and on the part of the East Germans. And it's just a frustrating experience. All of you must experience it every day of your lives. And I hope there is an answer in something other than legislation. But it is your concerns and those of many of us, people who are familiar with some parts of this problem and related problems, I guess have to somehow take this place beyond an amendment to require the United States contribution to the United Nations to be no greater than the contribution of the Soviet Union, and to somehow lift the people that claim a right to a place in the United States Senate beyond that kind of a view of the world, and lift it up somewhere closer to the real issues that affect people. And I had to say that. I was listening to your comments. Let me ask you, and I intend to ask the other witnesses this, and that is whether the following is an accurate summary of the current state of our knowledge on this subject. Now, for the first time, there is international scientific consensus that global warming can and will occur. While there are still uncertainties surrounding these predictions, it runs in both directions. That is, while global warming could be less than expected, it is at least as likely that it will be much worse. Third, all predictions are based on the assumption that a new man-made atmosphere will behave in the same way that natural atmospheres have in the past. Fourth, global warming, much like fever in a human being, is serious in itself, but is also a symptom of massive perturbation of the natural, physical, and chemical processes. And fifth, relatively painless actions can be taken which would slow the warming trend. For example, the use of CFCs and spray cans could be banned throughout the world. Maybe. Cars and trucks could be required to meet stringent carbon monoxide standards, such as those in the United States. Again, maybe, depending on our international amity. And forests can be reseeded. Is that a fairly accurate summary of the current state of our knowledge?
The only statement in there that I would have some quibble with is the one which goes that scientists are assuming that the atmosphere with the increased infrared absorbing gases in it will act the same as the present atmosphere. I don't believe there's any such assumption. There are calculations from first principles, but apart from that, what you read seems. Yeah.
You were invited to testify because you're something of a scientific generalist, and one of your best qualities is the ability to explain complex scientific issues in a way the layman can understand, and you have also worked on a variety of these issues. One scientist who works in this field was recently asked why he was devoting so much time and attention to it when there seemed to be more urgent problems, and his response was that in his judgment, climate alteration was the most serious threat to humanity and global peace short of nuclear war. Those seem like strong words, even from a person who's committed his entire life to the problem. You are more of a generalist than the person I'm quoting, and you have spent time considering the implications of other threats, including nuclear winter, in the context of potentially cataclysmic events. How would you score climate alteration?
I recognize the need for a rank order of catastrophes, so we know which one to devote our attention to first. But I would hope that we could concentrate on several potential catastrophes at the same time.
Which two or three?
I certainly agree with your anonymous informant that nuclear war is far and away, heads and shoulders, the most dangerous threat to the nation and the world and possibly the human species. I also agree that the sorts of climatic effects that we're talking about today are very serious because they have global purview and because they are so intimately tied to something which we are so reluctant to give up for clear economic and other reasons, namely the burning of fossil fuels. In 1945, after the first nuclear explosions, Einstein said that everything had changed except our way of thinking, a remark that certainly is still applicable today, and I think is applicable to this particular issue. And that's what I was trying to stress in my testimony, that there is a kind of global and intergenerational thinking that is essential for dealing with these problems, the nuclear war issue as well, and other candidate catastrophes like AIDS and other new epidemic diseases, all of which cannot be resolved except on an international global basis. The eradication of smallpox, for example, to take a successful example, was done at the expenditure of a few tens of millions of dollars by a planetary effort by the medical community, and is an example of a problem that certainly was considered very difficult some 1,000 years ago, that is now it's completely gone. There are no more cases of smallpox on the planet. So it's a reminder to us that these problems can be solved, but not if we persist in keeping to our narrow frames of interest in space and in time.
Thank you. Mac?
Dr. Sagan, a lot has been written about, a lot of people have spoken about some of the adverse effects of increased carbon dioxide and other gases. Are there any benefits? That is, one can argue that in some of the colder climates of our country, warmer temperatures would help.
Well, having just come from upstate New York, I know what you mean, Senator Baucus. The distinguished scientists who will follow me on this panel would be better qualified than I to answer that question, but it is clear that increased carbon dioxide for many plant species produces a more luxuriant growth. That's true both of crops and of weeds, but that might be considered a benefit. Also, the one that you just talked about, there are places that are cold which will be happy to be warmer. There are places that have a moderate climate that will be unhappy about being warmer, and that's that balancing out of pluses and minuses I was talking about before. But I don't think anybody will be happy about the inundation of all the coastal cities on the planet, except, I suppose, the people who live on the new coastlines, who will be delighted to have boat traffic.
Yeah. Is there any difference of opinion at all within the scientific community over this trend? That is, with increased carbon dioxide and other gases building up, that by sometime next century, say year 2075, year 2080, that the overall temperature will have increased X number of degrees Fahrenheit.
Defer to Drs. Manabe and others on this, but if you look at the 1982 National Academy report, I forgot the exact title, but climatic effects of CO2, a reassessment, something like that, they talk about a few dissenting scientific papers, and that is a few scientists who say the effect is not nearly as severe as has been widely advertised, and the Academy's report gives a very succinct explanation about why these studies are inadequate.
So in your judgment, the vast preponderance of the thinking of the community is in accordance with what you're saying?
Yes.
Okay. What's the best international arena within which to address some of these problems? I mean, do we have to create a new forum, organization? Should we work within some existing organizations? Do we deal with this on an ad hoc basis? What guidance can you give us, at least in your thinking, as to how to get other countries to A, think about this, including this country, and B, how to work on some cooperative, constructive basis?
Well, it seems to me that that the situation has to be arranged that everyone benefits. And a developing country that is being asked to forego readily available supplies of fossil fuels has to be given something of value in exchange. And if we develop fusion power plants that are effective, for example, then it seems to me that has to be a...
But I wonder if you've given any thought as to process. I mean, in addition to the information and substance on the process.
I think...
Carl, before you go into that, I'm going to have to break and get over to vote, and so I want to express my appreciation to you for being here today on behalf of all of us and those who aren't here. Okay. Just finish.
I've got to leave too. I mean,
Okay, well, I didn't have a good answer anyway. So.
well, you have about 15 minutes to think of one.
We'll recess the hearing. Thank you very much for coming. Did you want Carl to stay to ask more questions?
Oh, well, I have more questions, and we can, if he's busy, I can put him the record. I'll write questions to you. Okay, thank you.
Afternoon. Welcome to the National Press Club. My name is Mary Kay Quinlan. I work for Gannett News Service, and I am president of the club this year. I'd like to welcome my fellow club members and their guests in the audience today, as well as those of you who are listening to this program over one of the 303 national public radio stations or watching on one of the 2,300 cable systems affiliated with C-SPAN, the Cable Satellite Public Affairs Network. Before going any further, I would like to remind our members of some coming events. On Wednesday, October 8th, public television personality Alistair Cook will speak about changes in America since his arrival here in 1932. And on Tuesday, October 14th, our luncheon speaker will be Violeta Chamorro, the owner and publisher of La Prensa, the last independent newspaper in Managua, Nicaragua that was closed in June by the Sandinista government. Dr. Robert Gale of the USC School of Medicine will speak to us in early October. Please watch for the date to be announced. His topic will be the short and long-term implications of the Chernobyl incident. I'd like to remind those of you in the audience that if you have any questions for our speaker today, and I trust that you will, please write them on the cards that have been furnished at your tables and pass them up to me. I will ask as many as time allows. I'd like now to introduce our guests at the head table. And I would ask our guests to please stand briefly when their names are read, and I would ask you in the audience to withhold your applause until I have read all the names. First, seated at my far left is Mitch Waldrop with Science Magazine. Next to him is Bob Garfield with Crane Syndicate. On his right is Craig Kowalt with Aviation Week and Space Technology. Next to him is Stephen G. Kelman of the San Antonio Light. I would like to offer congratulations publicly to Mr. Kelman. He is this year's recipient of the Baltimore Sun's H.L. Mencken Award, which was presented just before this program started. Next to him is Gil Klein with Media General Newspapers and a member of our Speakers Committee who helped organize today's luncheon. Next to Gil is Ann Drian, novelist, television writer, and producer who co-wrote the Cosmos television series, and she is also the wife of our speaker. I will skip our speaker for the moment. Seated to his right is Randy Allen, the Vice President of Pyramid Video and Chairman of the National Press Club Speakers Committee. Next to Randy is James I. Houck, the Managing Editor of the Baltimore Sun. On his right is Jan Ziegler with United Press International. Next to her is Don Kirkman with Scripps Howard News Service. On his right is Bill Rubery with the Richmond Times-Dispatch, and at the far end is Chris Joyce with New Scientist magazine. Billions and billions. Our guest speaker is probably one of the few people in public life who can be immediately and universally identified by a number. On one level, Dr. Carl Sagan has become the Mr. Rogers of astronomy. With his clear-speaking style, he has made complex theories of the universe so understandable for the average public television viewer that he has become a cult hero. Instead of football, workers gathered around the water cooler have actually been heard discussing Uranus and black holes on mornings after his show. On another level, Dr. Sagan is a serious astronomer. He is the David Duncan Professor of Astronomy and Space Sciences and the Director for Planetary Studies at Cornell University. He has played a leading role in the Mariner, Viking, and Voyager expeditions to the planets, for which he received the NASA Medal for Exceptional Scientific Achievement, among the many other national and international awards he has received. His scientific research has enhanced our understanding of the greenhouse effect on Venus, dust storms on Mars, the organic haze on Titan, the origin of life on Earth, and the search for life elsewhere. Contrary to popular stereotypes about physicists and mathematicians, Dr. Sagan is a man of words as well as of numbers. He has written more than 600 published scientific papers and popular articles, and is the author, co-author, or editor of more than 20 books, one of which, The Dragons of Eden, won for him the Pulitzer Prize. And on still a third level, Dr. Sagan is a public advocate. In the early 1960s, his concern about transmitting Earth germs to the moon in unsterilized rockets led to the United States and the Soviet Union setting up standards for sterilizing space vehicles to prevent biological contamination. More recently, research that he and his colleagues have done on the long-term effects of nuclear war have made nuclear winter a household word and have put a crack into international defense planning. He is president of the 100,000-member Planetary Society, the largest space interest group in the world, and he is now, as he will tell us today, a major advocate of a joint U.S.-Soviet expedition to Mars. At the same time, he is publicly battling the concept of Star Wars and its huge drain on national research spending. Dr. Sagan, our audience here in this room, listening on National Public Radio and watching on C-SPAN, may not reach billions and billions, but certainly the thousands and thousands of us are waiting to hear what you have to say. Dr. Carl Sagan.
Thank you for that generous introduction. I'm delighted to be here with you. I have 20 minutes in which I want to talk about 2 or 3 very serious questions, and then I'll be delighted to answer questions on them or anything else on your mind in the question period. In the last few thousand years, human beings have devised an extraordinary set of technological advances which have enhanced our lives, have helped to diminish disease and increase well-being, although there's a great deal more work to be done. But at the same time, that technology has developed weapons of increasing sophistication and power to such an extent that we have now reached the extraordinary moment where our global civilization, and perhaps the human species itself, is in peril because of the possible misuse of this technology. For me, the dual content of technology is very clear, because the same technology that I am involved with in the spacecraft exploration of the planets, rocket technology, nuclear technology, electronics, computer technology, is also the very same technology that is used to devise and produce weapons of horrendous, grotesque, destructive power, of which we have amassed we humans, some 60,000. 60,000 nuclear weapons, almost 30,000 so-called strategic weapons waiting for the orders to be launched halfway across the planet. Even a tiny fraction of these weapons could produce a catastrophe absolutely unparalleled in the history of human beings. For example, how many cities do you think there are on the planet Earth? If we define a city as having 100,000 people or more, there are only 2,300 cities on the Earth. That means that the United States and the Soviet Union, if they so wished, could, targeting 2 nuclear weapons per city, destroy every city on Earth and have almost 20,000 strategic nuclear weapons left over, to say nothing of almost 40,000 so-called tactical nuclear weapons. This is clearly madness. There is no need for these weapons. They serve no conceivable military purpose. If the function of a nuclear weapon is to discourage a potential adversary from using his nuclear weapons, a tiny fraction of the existing arsenals would suffice. We live in the year of Chernobyl and Challenger. These are high technology, high visibility projects of the Soviet Union and the United States, in which enormous amounts of national prestige have been invested. They are the last things you would imagine would go wrong in those societies, because they have so much to lose if something does go wrong. And there were confident estimates, some only a year before the catastrophes, about how improbable such catastrophes would be. An article in Soviet Life quoted authoritatively a Soviet deputy minister talking specifically about the Chernobyl reactor. It's a curious coincidence, saying that the average time you would have to wait for a catastrophic accident at Chernobyl was tens of thousands of years. The next year, boom. NASA officials were widely quoted as saying that at the then current launch rate of the space shuttle, you would have to wait 10,000 years or more before there was an explosion on launch. Boom. The lesson is that despite our best intentions, we can make serious technological mistakes. We also know many examples, consider the KAL 007 incident, that there are serious human mistakes that happen. This is also the century of Hitler and Stalin, and we realize that madmen can achieve high office in modern industrial states, or people can go mad while in office. If you put those together, the likelihood that the technology will go wrong if you wait long enough, the capacity of humans, it's part of our being human, to make errors, and the possibility of madness in high office. And you combine that with a world littered with 60,000 nuclear weapons, and you have a prescription for the most serious disaster that we have ever faced. And at the same time, almost everybody, at least in this country, goes on as if it's business as usual. No crisis, nothing to worry about. Occasionally, there are concerns. At the time the Reagan administration took office, there got to be a great deal of concern about the consequences of nuclear war, partly because of the activities of physicians' organizations indicating how inadequate American medical care, the best in the world to be sure, would be in case of even a small nuclear war. In fact, the estimates of the number of people who would be killed outright in a major exchange between the United States and the Soviet Union range from hundreds of millions to a few billion people killed. And that's just from the direct consequences. And from the longer-term consequences, including radioactive fallout and climatic change, such as nuclear winter, the estimates are that another few billion people might be killed. Well, a few billion plus a few billion is getting very close to the total number of people on the planet. Now, it seems to me there are only two conceivable solutions to this problem. One is to reduce the arsenals so that in the worst case, the worst concatenation of technological failure, misunderstood orders, madness in high office, you could not destroy the global civilization. Massive, bilateral, verifiable divestment of nuclear weapons. And this is, of course, the proclaimed, stated policy of the United States and the Soviet Union. The only trouble is every year those two countries add to their strategic arsenals enough weapons to destroy, once again, every city on the planet. They talk a good game. The other possibility is a defense, something that would protect you with high reliability, protect the civilian population of your country in case of the worst happening. And this is Star Wars. And Star Wars has, it must be acknowledged, a major political objective, that is to calm people's justifiable fears about nuclear war. There are many things that can be said about Star Wars. For example, I had a debate with General Abramson at the State Department in late July on this issue, but I would like to, there's so many things wrong with it, you can talk for hours just listing the dangerousness and foolishness of Star Wars. But let me give a few examples. One has to do with porosity. In the best case, if we spend $1 trillion or $2 trillion, if we have decades of technological development, how many Soviet warheads would get through? And the answer, according to advocates of Star Wars, in the Department of Defense, for example, that technologically competent people will give you some number of, oh, maybe 80%, maybe 90%, something like that. Suppose it's 90%. 90% of Soviet warheads can be shot down reliably. That means, of course, that 10% don't get shot down. The Soviet Union right now has well over 10,000 strategic warheads. If you let 10% of them get through, that's 1,000 warheads. 1,000 warheads is enough to destroy the United States utterly. So by the testimony of the program's advocates, it cannot protect the civilian population of the United States, which was, you remember, the objective in the president's speech where he talked about making nuclear weapons impotent and obsolete. But since then, there's been a change, what Senator Gore of Tennessee calls bait and switch. And now it's justified, well, it'll defend missile silos or it'll confuse the Soviets. That's a very different story. The Soviets can, of course, add to their strategic offensive forces to overwhelm whatever the United States, at great expense, manages to do in the way of defense. The Soviets can outfox by decoys and penetration aids. They can underfly the system because it does nothing for a low altitude or a speedboat delivery system or a cruise missile delivery system or nuclear weapons in small airplanes. I remind you that small airplanes filled with bales of marijuana penetrate the United States every day ad libitum. And it is ruinously expensive. $1 trillion is half the national debt. $1 trillion is twice the total indebtedness of all third world nations to all Western banks. $1 trillion is too much to take casually. You have to get your money's worth for $1 trillion. And finally, Star Wars has the problem that the Soviets perceive it, the more generous of them, as economic warfare, the less generous of them as a token of U.S. intent to do a first strike on the Soviet Union. They recognize that it cannot protect the civilian population of the United States, but if the U.S. made a massive first strike on the Soviet Union, Star Wars might be enough to mop up the residual Soviet forces that might be used for retaliation. So Star Wars cannot protect the civilian population of the United States, can be overwhelmed, underflown, outfoxed, is ruinously expensive, and is likely to increase the chances of nuclear war. Except for that, it's a terrific idea. What we really should be doing, the first thing on the agenda, the thing that's most clear, because it has the largest leverage on the nuclear arms race, is a treaty banning further tests of nuclear weapons. In 1963, the United States unilaterally stopped testing nuclear weapons above ground. The Soviet Union immediately responded with its own unilateral moratorium, just by accident. It was a coincidence, same week. And this de facto moratorium became a de jure treaty, the 1963 Limited Test Ban Treaty. And from that time to this, not a single US or Soviet nuclear weapon has been exploded on the ground, in the air, or in space. On August 6th, 1985, the 40th anniversary of the bombing of Hiroshima, the Soviets announced a unilateral moratorium on underground nuclear testing and invited the United States to follow suit. The US response has been to explode 20 nuclear weapons and to contemptuously reject the Soviet invitation. It is a very good way to halt the further escalation of the arms race. It's not enough in itself. We want to decrease the arsenals. But it's an excellent first step to defuse the technological drivers of the arms race on both sides. It is clear that the Soviet leadership is under pressure from their own hardliners. The offer will not remain open forever. Present expiration date is New Year's Day. And I think there is an urgent necessity for the United States to follow suit. This is clearly indicated in public opinion polls. Both houses of Congress have urged that the United States join the Soviets in this, and many mainstream groups are supporting it. Just as an example, just in a few days, Annie and I will be there, a venerable organization, the American Public Health Association, meeting in Las Vegas, is going to have a massive demonstration at the Nevada nuclear test site on September 30th to protest continued nuclear testing by the United States, to urge the United States to come to its senses. And there is every indication that there will be massive civil disobedience. That means crossing a white line and getting arrested for trespassing. By very respectable physicians and health professionals and others. And I give this to you just as one example of the recognition of the seriousness of this issue by almost everybody but the Reagan administration. I'd like now to come to my last topic. And again, it's this bifurcation that the technology implies. We have vast abilities. There is an extraordinary amount that we can do. The U.S. space program is in deep trouble. It has lost a sense of purpose, which in fact it lost shortly after the Apollo program. And since then, it's merely been, let's develop machines, a shuttle, a space station, never what they're for. And in particular, the exploratory goal, which was the triumph of the Apollo era, has been completely lost from the U.S. space program. At the same time, the European Space Agency and the Japanese and the Soviets have had gradually increasing sophistication and vigor in their programs. Something that to me makes an enormous amount of sense is a joint US-Soviet manned and womaned mission to Mars as part of a long-term program. The science would be extraordinary. Mars is a world of wonders. I will not take the time to describe it, but it is a just fascinating place. 1 billion years ago, water was flowing on Mars. There were rivers and lakes and possibly oceans. Something happened between then and now, and it might be good for us to discover what. But I don't think that you can justify sending humans to Mars purely for the science. You can send robots, and they're a whole lot cheaper. But just as Apollo was primarily a political program, it was the U.S. response to the Bay of Pigs debacle and the fact that the first people to orbit the Earth happened to carry Soviet passports. So now also, such a program could only be justified by on political grounds. But the story has changed. It is not competition but cooperation, which is called for now. And a joint Soviet-American program could capture the imagination of people all over the planet
to show that these two nations could use that high technology on behalf, for a change, of the human species, and to blaze a pathway into the third millennium, eventually making the human species a multi-planet species. The cost looks to be less than the Apollo program, vastly less than Star Wars, roughly the same as a single major strategic weapons system. It is as if God said to us, I set before you two choices. You have the technology to destroy yourselves. You have the technology to carry yourselves to the planets and the stars. It's up to you. Thank you.
As you can imagine, we have questions on a wide variety of topics today, Dr. Sagan. This first question would like to know, why do you not support the impetus which the Strategic Defense Initiative has given to basic research in the fields of laser, nuclear, and space technology?
Thanks. Because that argument is basically flawed. In the case of Apollo, for example, we heard that, listen, Apollo is really great because of spin-off. That's what we're hearing here, spin-off. For example, because of the Apollo program, we have stickless frying pans or cardiac pacemakers. Well, if we want to have stickless frying pans or cardiac pacemakers, we can get them directly by investing in stickless frying pans and cardiac pacemakers without spending $25 billion to send some people to the moon. That's not the way you make a pacemaker. And in just the same way, if we are interested in lasers for surgery, we should develop lasers for surgery and not go via the route of a hydrogen bomb exploded in space to shoot down some foreign missiles in violation of about 4 different treaties the United States has solemnly signed. I forgot to say that before. The spin-off arguments are an indication that the other arguments have been found wanting. And I don't think for a moment we ought to be bamboozled by spin-off arguments. It's too much money. $1 trillion for laser surgery. You can do laser surgery for the tiniest fraction of that if that's what you're after.
France, through a United Nations initiative, has proposed the establishment of an international remote sensing agency, which would serve to provide total global reconnaissance so every country would be able to observe every other country totally. Would you be in favor of such an activity?
Thank you. There are many advantages of the space program. Meteorological satellites, which save enormous amounts of money in avoiding crop damage. Communication satellites, which are binding up the planet. A historic revolution occurs because of communication satellites. Scientific satellites, which it will be no surprise to you that I think is a good thing. But by far, the most important kinds of satellites have been military reconnaissance satellites. This is why I'm not opposed to military activities in space. It's only weapons in space I'm opposed to. Military reconnaissance satellites prevent the hotheads and paranoids on each side from thinking the worst of the other. It's a way to see what the other side is actually doing in terms of military capability and troop movements and treaty compliance and all the rest. And so it is enormously stabilizing. And that's why Lyndon Johnson said that those satellites were worth their weight in gold. And they are. And by the way, that is one of the many reasons why the Challenger disaster is a disaster in many senses. The U.S. has an important KH-11 and KH-12 satellite technology, which can't be put up into space because we don't have the booster. And at the same time, the United States does its share of saber rattling all around the world. Very dangerous to do that without having the optimum satellite reconnaissance. Now, if the monopoly in satellite military reconnaissance is held by only two nations, and they are the contending superpowers, there is a clear danger that they will, in public utterances at least, distort what they see for domestic or foreign political purpose. If there were an independent organization, some other nation which didn't have a political axe to grind, if you can find one, or some international organization, then this possible misuse of satellite reconnaissance capability could be avoided. But more than that, the rest of the world could be clued in to what is actually happening by the United States and the Soviet Union. And the French Spot satellite, for example, was recently used to see what is the state of Soviet preparations for resuming nuclear testing if the United States does not reply, except by exploding more nuclear weapons. So to make a long answer short, I think it's a very desirable thing to involve other countries, just as it's very desirable to involve other countries in verification of, for example, compliance with claimed moratoriums on nuclear weapons testing. The Natural Resources Defense Council, Washington-based public service organization, has an arrangement right now with the Soviet Academy of Sciences in which American scientists and seismometers are at the Soviet nuclear test facility at Semipalatinsk, monitoring the Soviets. They don't monitor any Soviet explosions, just American explosions. That is an example of a private organization helping in this way. The heads of state or government of India, Sweden, and 4 other countries have said they would be glad to take over the monitoring on both sides of compliance with a comprehensive test ban treaty, and I think that's a good idea.
This questioner notes that opponents of the joint U.S.-Soviet Mars mission fear the Soviets would use it to steal American technology and then use it for weapons. Would you give us your reaction to that, please?
Well, or the other way around. Maybe the Americans would steal Soviet technology and use it for weapons. What you have to bear in mind is that in this sort of planetary exploration space technology, the Soviets are very good. The Soviets were the first to land a spacecraft on the moon. They were the first to photograph the backside of the moon. They were the first to land working spacecraft on the surface of Venus. That's a tough place. Venus has a surface temperature of 900 degrees Fahrenheit. It has a surface pressure of 90 times the pressure in this room, and an atmosphere which contains hydrochloric acid, hydrofluoric acid, and sulfuric acid. Being the first to land a spacecraft there and take pictures and all that is not easy. You remember the Soviets did sent 2 spacecraft to Halley's Comet just last March. The United States did not send anything because we couldn't afford it. By the way, how expensive was it? It was exactly as expensive as a single B-1 bomber, of which the United States is committed to buy 100. 99 evidently would have compromised national security. American scientists have prepared a report for the Office of Technology Assessment, have testified before the Senate Foreign Relations Committee on just this issue, and what they say is that the two countries have very near parity on this sort of issue. But even if there was some technology transfer in both directions, you have to look at what we get in exchange. And the idea of the United States and the Soviet Union getting some practice in working together on high technological systems before the cameras, the television cameras of the planet, is worth a great deal. Just picture it for a moment. The interplanetary spacecraft is constructed in Earth orbit. Little astronauts and cosmonauts are welding, moving girders, building stuff together. and it's all on television over a period of a year or two. Then they board the spacecraft, again televised. They take off for Mars. It's some 9 months journey. They orbit Mars. They then get into a descent module. They land on the surface of Mars, Americans and Soviets together on behalf of the human species. Again, the television cameras show this happening. They then explore Mars. They go on, let's say, some wheeled vehicle down an ancient riverbed looking for fossils in the banks or whatever there is. There, they spend some time, months, let's say, on Mars. That's all before the television cameras. Then they come back to Earth with Mars samples, whatever wonders they have found, and that's all on television. Imagine such a sustained period of many years in which the United States and the Soviet Union together, maybe with Europeans and others, are doing something, a great adventure, great exploration, high scientific merit, together, and everyone on Earth sees it. That, it seems to me, is worth a great deal.
This questioner would like to know, why do you put such faith in U.S.-Soviet cooperation in a venture to Mars in today's climate of political distrust?
Distrust tends to be self-propagating. Distrust breeds distrust. There is no reason for the Soviets to trust us, or for us to trust the Soviets on any issue, except, I hope this is true, that each nation wishes to survive. That each nation wishes to have its people survive, and their children, and their grandchildren. There are very powerful human reasons why I think we can rely at least on that. And for that reason, doing things together, even small things, is well worth doing. Sigmund Freud said a long time ago that it is shared action between nations that leads to the diminishment of mistrust. The United States and the Soviet Union each have a list of abuses by the other as long as my arm. You ask for the justification of any abuse that one of those countries does, and they'll tell you about an abuse that the other country does. But this is a treadmill. There's no way of getting off this unless you're willing to break out. This is a way of breaking out without compromising national security, without involving anything to do with nuclear weapons. It could be done, for example, in parallel with whatever divestment of nuclear weapons I sincerely hope the two countries would be done. It also has the right timescale in order to make a useful goal for the National Space Program. It is not so far in the future as to be impossible to do in the lifetimes of people working now, and it's not so short term as not to focus the program. It's exactly at the right technological distance, in just the same way that Apollo was the right technological distance in 1961 when President Kennedy asked for an American to be landed on the moon and brought back safely by the end of the decade. And by all standards, present studies suggest that the technological leap from President Kennedy's speech to Apollo 11 is less than the technological distance from today to a landing of humans on Mars.
You referred to the importance of television coverage of all events attendant to that, and since you are before an audience of journalists, this questioner would like to have you grade the savvy and accuracy of science, technology, and space reporting in the United States today, and compare that to the reporting that you see in other countries.
What shall I say? There's some good and there's a whole lot bad. One complaint I have is that science has a kind of panache which is used to cover other stuff. On television, you see people who are called science reporters, but they're not science reporters. They're medical reporters, they're technology reporters. They're not science reporters. When people win Nobel Prizes in chemistry or physics, how many times have you gotten a coherent explanation of what they won their prize for? Just some guy, I was really surprised. They woke me up in the middle of the night. My wife said she didn't believe it. Yeah, I'll be glad to go to Stockholm. What was it for? We never hear. The virtually every newspaper in America has a daily astrology column. A daily astrology column. Astrology is, of course, a hoax. There's no such thing. All tests show it doesn't work. It's been known for hundreds of years. Why do we have astrology columns? Those newspapers don't have a weekly astronomy column, by and large. How is that? How many major American newspapers have one science correspondent, never mind a science bureau? One person whose job it is to do science. Never mind technology, never mind medicine. Those are important. I'm talking about science. You have pages and pages of stock reports, minuscule, quantitative information, pages after page. Does everybody understand how to read it? No. But it's considered that there is a subset of the readership of the newspaper for whom that's important. The newspaper feels it has an obligation to provide for that subset. You look at the sports pages, box scores, WB, RBI, SO. What's that? If you're not a baseball fan, you don't know. You pass that by. But there's enough people who are interested that the newspaper considers it its obligation to show that detailed quantitative information. Where is the page which gives the detailed science information? Where is the page that encourages youngsters to think about it, that shows them they can understand it? The mere appearance of science in newspapers would say to kids, look, it's not too hard for you, it's in the newspaper. Everybody knows newspaper isn't hard. I must be able to understand this. It must be okay, science. See, I think there is a vast underestimation of the intelligence and curiosity of the American people. When we did our Cosmos television series, constantly had that happen. And just recently it's been, Annie and I and some others redid it, something called Cosmos, a special edition. And again, we're getting people, I mean, ordinary people, not fancy academics, truck drivers, hairdressers, taxi drivers, saying to us, oh, I wish there was more of that on television. That's what I'd like. I learned something. The first time in months I learned something from television. Or people say, often, but by no means always, women say, I had always thought I was too dumb to understand science. Your program showed me I could understand it. It gave them a self-confidence, a feeling that they could go further. Lots of people went further because of Cosmos. I think in television, in magazines, in newspapers, in radio, much more could be done to convey science to the average person. And it's important. It's important, first of all, because we are a scientific species. I mean, we're the only species on the planet that does science. It's intrinsic to us. We're curious. We want to find out. But also, as I tried to say in my talk, understanding science is central to solving the very serious technological problems which face us. How can we challenge clear, false statements by one government or another if we don't understand the underlying technology? It's not harder. The technology you have to understand the nuclear arms race, to understand Star Wars, to understand any of these issues, is not more difficult than what you have to understand to follow the sports pages. And I believe there is a real obligation to get that information to the American people. Our lives may depend on it.
Dr. Sagan, what do you think it might take to get newspaper editors to devote more space and energy to covering science?
A reasoned argument, divine intervention, somewhere in between those two.
That's actually a good transition to this next question. This person would like to know, why should not creation science be treated equally with evolution in our classrooms?
Because there is no such thing as creation science. Evolution is the backbone of modern biology. You cannot understand the nature of the biological world without understanding evolution. I maintain that evolution is a fact, not a theory. Science uses the word theory in a way that's different from how it's used in everyday life. In everyday life, people say, oh, that's just a theory, meaning you invented it while putting on your slippers as you got out of the bed this morning. But in science, a theory is a very well-supported body of knowledge. There's the atomic theory, you know, that everything is made of atoms. People don't say, oh, it's only a theory. Evolution is a theory on that level. It is very clear that evolution happened. All you have to do is look at the record in the rocks. If you have an undisturbed sedimentary column, at the top are the beasts and vegetables, the fossils of the beasts and vegetables around now. As you go deeper down, you go further back into time, as is clearly indicated by radioactive dating, and you find fossils of animals and plants you don't know. Who are those guys? They're not around now. Also, down there, how come there's no cows? How come there's no people down there? They're just dinosaurs and trilobites? It's very clear. Down there, many of the plants and animals around today weren't around. They hadn't come into being yet. Up here, those guys, those dinosaurs and trilobites, they're not around anymore. They've all become extinct. Life evolves. Now, that doesn't say that when I say evolution is a fact, that's not the same as saying that the mechanism of evolution is a fact. There is still significant debate on, for example, the extent to which natural selection explains everything, or in which cosmic disasters have changed things, and so on. But I think evolution is absolutely clear-cut. And of all the nations on the planet, this is about the only one in which it's a serious issue. And it's a serious issue for emotional reasons. That is, there are a lot of people who don't want to be considered an animal. I'm sorry. I'll be glad not to call you an animal if it offends you. But we are animals. We have evolved, and it's very important self-knowledge. And then, of course, the main reason is that there are people whose belief in the literal truth of every jot and tittle in the book of Genesis is offended by evolution. But the book of Genesis, I must say, is not literally true. It has problems. It has internal contradictions. Genesis chapter 1 contradicts Genesis chapter 2, just to start at the beginning. The Bible clearly implies that the earth is flat. It talks about the four corners of the earth in many places. Maybe you remember the time that Satan takes Jesus to a high mountain to offer him all the kingdoms of the earth. From that high mountain, you can see all the kingdoms of the earth, only if it's a flat earth. If the earth is round, you can't see the kingdoms on the other side. At least Satan thought that the earth was flat, and nothing that the author of that section of the Bible wrote contradicts it. The Bible is a great literary document. It's a great historical document. It's a great ethical and moral document, but it is not a scientific document. And I think that is something which is clear and ought to be taught. And creation science, so-called, is merely an attempt to introduce, contrary to the clear intent of the First Amendment, and I certainly share your fondness for it, of a particular a particular religious viewpoint imposed on the educational system in the United States. Not only would I like to see First Amendment lounges, I'd like to see the whole United States declared a First Amendment zone.
Dr. Sagan, this questioner asks, do you believe there may be more to be learned in our inner space, namely our oceans, rather than in outer space? I don't like to compare the two, this questioner says, but would you like to give us your thoughts?
Well, there's a lot more up there than down here, more. But there's no question that the remaining major unexplored area on this planet are the oceans. They have great economic importance, great scientific importance, and very nicely, there is a range of submersibles now. Maybe you remember the vehicles exploring the Titanic. which are opening up a whole new generation of undersea science, and I'm all for it. By the way, this is not the only place with an ocean. Titan, the big moon of Saturn, looks to have an ocean of liquid hydrocarbons. And it'd be nice to explore that too. And if OPEC gets out of hand, there's an economic possibility, although the freightage will be high.
This questioner would like to know what will be the fallout of the split in the scientific community, especially at universities, on the merits of Star Wars.
Thanks. There were so many things to say about Star Wars, I didn't have a chance to mention this. It's not just academic community, it's also industry. You wave $1 trillion at the U.S. aerospace community and academia, and you are going to find, no matter what the merits of Star Wars are, a whole lot of people sign up. And what is more, there is a danger that you will produce a kind of technological momentum, all just to keep making money and perquisites of power and promotions and stock options and all of that, that you can't turn off. The political power of an already politically sophisticated industry that is devoted to maintain what one flag officer described, the feeding frenzy, can be enormous. I am very proud of the academic community that so many scientists who could have been supported by Star Wars have signed a pledge. I've forgotten how many people. It's something over 8,000, I believe, top-ranking academics from the best physics departments in the United States, saying that they will not accept any support to work on Star Wars. But of course, lots do, because they have mouths to feed, they have families, they have mortgages. And every time that happens, someone is taken out of the civilian economy, out of working on pure science, out of working on things which will maintain the economic position of the United States in the world, and into something which has virtually no economic value. The dollars put into Star Wars are much less efficient in stimulating the economy than dollars put into domestic technology or even pure science.
Dr. Sagan, what is your reaction to NASA's canceling some 11 major scientific missions that were to fly on the space shuttle? Should the private sector get behind these missions financially, and should the academic sector formally protest in excess of military missions?
Well, when Challenger blew up and the shuttle program was put on hold, there were a superb set of scientific missions that were in the pipeline, ready to be launched by shuttle. There was, for example, dear to my heart, the Galileo spacecraft to Jupiter, first spacecraft to orbit a planet in the outer solar system, first spacecraft to send an entry probe into the atmosphere of Jupiter to, as it descends through the atmosphere, to examine what's there. Fantastic mission. Or the Hubble Space Telescope, by far the largest optical telescope ever put into Earth orbit, promises to revolutionize our knowledge of cosmology, the large-scale structure of the universe, information on the origin and fate of the universe, search for other planetary systems, most extraordinary expected harvest. All that's just sitting around. The cost of maintaining the Hubble Space Telescope is something like $1 million a day just to maintain it. And where does this money come from? Where does the money come from to maintain the scientific and technological teams who will be needed later on to launch the thing to study the data that's sent back? So the loss to NASA is not merely the obvious human tragedy and the technological setbacks and the money needed to replace a shuttle, if that's what we're doing, but these subsidiary effects, which are extremely serious. I don't think there's any chance that private industry will put up the hundreds of millions to billions of dollars for pure scientific satellites. private industry is in the making money business. And you can't make money, just knowledge, which of course leads to money on a longer time scale, but industry is not interested in longer time scales. No, the only way to solve this problem is to put more federal money into resuscitating NASA, which is in desperate trouble, there's a great demoralization. There is no goal or direction to NASA. Scientific and technological teams are breaking up. Scientists who I know are leaving the top-ranking technological institutions within NASA or that support NASA. And we have a real crisis which has the danger, at least in the middle term, of being irremediable. That is, if all those people leave, and then we get somebody else in the White House who says, wait a minute, this is really very bad, we need NASA, the people to do it may not be so easily acquired. So I maintain there is a genuine crisis which can only be solved, A, by a larger NASA budget, and B, and almost more important, a coherent sense of the national goal in space of the United States. I will do so.
This next question is apparently from one of your television fans. This person wants to know, assuming that the universe is expanding, does that imply that it is finite? And if it is finite, what is beyond?
Great question. I can best answer by an analogy. Consider a sphere, and in the way this is often described, a balloon. And that's to represent the universe. But it's a two-dimensional universe. That is, it's just the surface of the balloon which is the universe, let's say. And on that surface, there are flat, two-dimensional things. Flat galaxies, flat stars, flat planets, flat astronomers. Now, consider that universe. Is it finite? Sure. There's only so many square inches or centimeters on its surface. But what's on the other side? There isn't any other side. The surface is all there is. You go around and you come back to where you started from. Now you'll say, oh, well, wait a minute, there's a whole lot of space inside and outside. But that's in that third dimension that those flat guys can't get to. Now up everything one dimension, and you have a kind of sense of what the answer is to the question. The universe can be, in Einstein's words, finite but unbounded.
I think you now have part of the answer of why there isn't more science reporting in newspapers.
If that wasn't clear, then that's my fault, not your fault.
This questioner would like to know, why should we want to establish colonies in space anyway?
Well, colonies in space covers a multitude of ideas, some of which I don't think are good ideas. For example, the idea of a large self-sustaining human community in Earth orbit, which could be done, by the way, could not conceivably solve any population problems. Every day on the planet, there's a few 100,000 more people born than die. So you would have to launch a few 100,000 people every day just to keep the population at a constant rate. And you will recognize that even when NASA was doing well, this was beyond its capabilities. There are some people who think it would be a good idea to have self-sustaining communities of human beings on other planets. So if the worst happened here, that at least there would be humans somewhere. I don't think that's a good idea either, because I think it would just a little bit add to the sense that, the worst isn't really the worst. But in the long term, after solving our problems here, the idea of humans moving out into the space frontier after the Earth is all explored appeals emotionally to a whole lot of people, not to everybody. James Van Allen has described this as a kind of religion in which a lot of people feel it, but they can't tell you what the justification for it is. But we are an exploratory species. Remember, we come from hundreds of thousands of years of hunter-gatherer ancestors, people who roamed, nomads. That's who we are. And I believe in our genes somewhere that urge is there. The Earth is all explored except for the ocean bottoms that a previous questioner asked about. It's natural to look out to the planets to do this. And I gave before some political reasons why I think it would be good to do United States and Soviet Union together, but I recognize that not everybody might find this last in the genes argument a compelling argument. Still, a lot of people feel it.
Dr. Sagan, as usual, we have way more intriguing questions than we have time today. Before I ask the last question, let me present you with our certificate of appreciation for being here today and a National Press Club paperweight, which can weigh down your newest theories, I guess. The last question that I have is from someone who would like to know, when can we expect to spot Sagan's comet?
Well, I'm not sure what that is. Annie and I wrote a book called Comet, and since I'm very unlikely to discover a comet, I guess that's more properly called Sagan-Drian's comet, is the only one I'm likely to have, and that's out in hardback right now. It'll be out in paperback in November.
Space Watch called Is the Strategic Defense Initiative in the National Interest?
Ladies and gentlemen, friends and colleagues, I want to welcome you here today to debate on the question, is the Strategic Defense Initiative in the national interest? To address this topic, we have with us two men who might be characterized as the architects of the President's Strategic Defense Initiative and two of the program's most formidable critics. Each of our participants holds an impressive set of credentials and unparalleled advocacy skills. There is little doubt that they will do credit to their respective points of view. This debate has been organized by Space Watch, a nonprofit research and investigative organization. I want to thank the staff under Eric First for their capable organizing effort to bring all of this together. This event could hardly be more timely. 3 weeks from today, President Reagan and General Secretary Gorbachev will be in the midst of a major summit meeting here in Washington. While the primary purpose of the summit will be to conclude a long-awaited treaty to eliminate intermediate and short-range missiles in Europe, it will also set the stage for other critical negotiations. For the INF Treaty is just the tip of the iceberg of arms control measures needed to reduce the enormous strategic nuclear weapons arsenal of both superpowers. Whether the Strategic Defense Initiative proves to be a bargaining chip or an impediment to achieving deep reductions in strategic nuclear weapons remains to be seen. But our hope is that this debate will provide a provocative prelude to the Washington summit. Moreover, I would hope that our distinguished panelists will provide insights and some effective debating points for those of us who will wrestle with these difficult questions in the Congress, and equally important to those who will be running in 1988 for the presidency of the United States. At this debate, we intend to disprove a pessimistic axiom written by British critic Cyril Connolly, who once said, "Where there are two alternatives, one intelligent, one stupid, one noble, one ignoble, one serious and sincere, one undignified and one false, one far-sighted, one short, we invariably choose the latter." We have agreed to the following ground rules for this debate. By a flip of the coin, we have agreed that the speaking order will be as follows. It will open with Richard Pearl, then to Richard Garwin, then to James Abramson, and then to Carl Sagan. Opening statements will be limited to 5 minutes, and we will be strict about adhering to these time limits. In the front row, we have a timer who will signal the chair and the speakers when the clock is down to 30 seconds. For rebuttals, we will reverse the speaking order, allowing no more than 4 minutes for each panelist. Following the rebuttals, we will allow questions between the panelists. In the original order, each panelist will be allowed one question directed to one or both of the opposing panelists. Responses will be no more than 2 minutes. And finally, each speaker will be given 3 minutes for their closing statements, and the closing statements will be presented in reverse order of the opening statements. Then it will be the audience's turn. Everyone should have received a card upon entering the room. If you would like to put a question to one of the panelists, write your question on the card and the panelist you would like to address it to, and also your name. There will be Space Watch staff members with name tags to pick up the cards throughout the debate. I will then put the questions to the panelists. We will try to hold as much time as possible for your questions. Without any further delay, let me introduce our panelists. Dr. Carl Sagan is the David Duncan Professor of Astronomy and Space Sciences and Director of the Laboratory for Planetary Studies at Cornell University. In addition to more than 600 published scientific papers and popular articles, Dr. Sagan is author, co-author, or editor of more than 20 books, including Comet, Contact, and The Dragons of Eden, for which he was awarded the Pulitzer Prize. His Emmy and Peabody Award-winning television series Cosmos became the most widely watched series in the history of American public television and has now been seen in 60 countries by over 300 million people. The accompanying book, also called Cosmos, was on the New York Times bestseller list for 70 weeks and is the best-selling science book ever published in the English language. Lieutenant General James A. Abramson is director of the President's Strategic Defense Initiative organization. He is responsible for managing and selecting key research and development programs designed to eliminate the threat posed by strategic nuclear ballistic missiles and to increase the contributions of defensive systems to U.S. and allied security. The General is a command and test pilot with more than 3,000 flying hours. He has a Bachelor of Science degree in Aeronautical Engineering from the Massachusetts Institute of Technology and a Master of Science degree in the same field through the Air Force Institute of Technology at the University of Oklahoma. In addition, General Abramson holds 3 honorary doctorate degrees in engineering from New York University, from Utah State University, and from Rensselaer Polytechnical Institute. The Honorable Richard Pearl, from 1981 until May 1987. Mr. Pearl served as Assistant Secretary of Defense for International Security Policy. From his office at the Pentagon, he had responsibility for theater and strategic nuclear weapons policy, trade and technology exports, European and North Atlantic Treaty Organization policy, and negotiations between the United States and its Western allies and the Soviet Union. Since leaving the Department of Defense, Secretary Pearl has become a resident scholar at the American Enterprise Institute in Washington, D.C., and a contributing editor of U.S. News and World Report. He has concluded a contract with Random House for a political novel that is intended for publication in 1988. And finally, Richard Garwin, who was born in Cleveland, Ohio, and received a degree, in a PhD in physics from the University of Chicago in 1949. After 3 years on the faculty of the University of Chicago, he joined IBM Corporation in 1952 and is at present IBM Fellow at the Thomas J. Watson Research Center, Yorktown Heights, New York, Adjunct Research Fellow at the Kennedy School of Government, Harvard University, Andrew G. White, Professor at Large of Cornell University, and Adjunct Professor of Physics at Columbia University. In addition, he is a consultant to the U.S. government on matters of military technology and arms control. He has published more than 200 papers and has been granted 34 United States patents. So that is our panel. It is a distinguished one. We look forward to a lively and enlightening debate, and we will begin with an opening statement from Richard Pearl.
I must say, Mr. Chairman, as I look at the audience, I'm reminded of the story of Machiavelli on his deathbed. Do you have a microphone? Can you hear? A priest was summoned and arrived at Machiavelli's side, and he leaned over and said, "Do you renounce the devil and embrace the Lord?" No response. He repeated the question a second time without response, and a third time. And finally, after the third time, Machiavelli slowly lifted his head from the pillow and he said, "Father, this is no time to be making new enemies." At the risk of making enemies, I intend to discuss today the view that the Strategic Defense Initiative is indeed in the national interest. And I will do so under 5 broad categories. First, the current situation. Then, what is the Strategic Defense Initiative? Something about the Soviet program. Something about defensive systems conceptually. And finally, some remarks about the future of technology. The current situation is easy to describe. As of today, the United States is wholly incapable of stopping a ballistic missile fired at our territory, even a single ballistic missile, even a missile fired by accident, even a single missile fired by, let's say, an errant Soviet submarine commander. No capability whatsoever. We would have to watch it complete its trajectory and reach its target. This is unprecedented in human history, that a threat as obviously large as the threat of a nuclear weapon striking our territory is, should go without any response whatsoever. It represents unprecedented indifference to the need to provide even minimal insurance against the possibility of an accident or a miscalculation. For those who believe that the most probable nuclear war is a nuclear war launched and initiated as part of a plan to achieve political purposes, or for those who believe that an accident could take place, it seems to me basic common sense to deal with both contingencies, including what I happen to believe is more likely, which is the possibility over time of an accident. Now, what is the Strategic Defense Initiative as a response to this situation? It is, first of all, a research and development program. No decision has been made to deploy the fruits of that research and development program, nor could one intelligently be made before the research and development and testing and evaluation is complete. The program is aimed at determining whether we have the technological and financial resources to develop and perhaps eventually deploy a defense that would strengthen our national security and give us reasonable insurance against the possibility of an accident. But we can't answer that question until the research, development, testing, and evaluation are complete. And I find it surprising that men of science, without waiting for the answers, without waiting for the research to go forward, have made up their minds. A strategic defense that might result from the program of research and development that we have underway need not, in my judgment, be a perfect defense, although there are those who believe it must. A partial defense would protect us against an accident or a miscalculation. A partial defense would strengthen deterrence by protecting the critical elements of our own deterrent posture. The Soviets have a strategic defense initiative. They don't advertise it, but they've been hard at work developing technologies very much along the lines of those that we have underway. And indeed, they invest massively in defenses. Conceptually, we do a great deal of a defensive nature. We put concrete around our missiles so that they can't be destroyed, or we make them mobile, or we hide them under the oceans in submarines. I see no fundamental difference in concept between the sort of passive defenses that we all recognize as vital to maintaining an adequate deterrent and the active defenses that could serve as a last resort, as a device capable of intercepting ballistic missiles when all other passive defenses and when the nature of the U.S. deterrent has failed, if it does, to deter or if an accident takes place. Finally, let me say that I find it difficult to believe that we can stop the march of technology now and forever. Almost arrogant to believe that. The Soviets are at work and will continue their program. We couldn't verify a termination of their program if they claimed to do so. And to believe that in the year 2050, let's say, we will be where we are today with respect to defensive technology is to ignore the lessons of history. So the issue before us is whether we will be part of the effort to develop this technology and explore our options, or whether we will drop out of this effort and leave it to others to make their decision and their determination, and perhaps to emerge with a monopoly of strategic defense capability.
Thank you. Our next panelist, Dr. Richard Gowen, for an opening statement.
Well, let us return to the origins of the SDI, the March 1983 speech by President Reagan, where he noted that deterrence of nuclear war has worked and will continue to work, but that it is morally preferable to rely on defense. We need, however, a defense so good that we can threaten no one. Then we can give up our own nuclear weapons, and it won't matter whether the Soviets retain theirs. If they use them against us, they'll do us no harm. They will rust, they will become impotent and obsolete. 4 days later, Secretary of Defense Caspar Weinberger said that we were seeking not any kind of partial defense, but a total and reliable defense, and he saw no reason why we couldn't achieve it. 4 years later, this February, in his testimony, Secretary Weinberger said that the administration seeks a completely effective system that will be a thoroughly reliable defense and will be able to destroy Soviet missiles as they come out of their silos. And if any should be missed, then at the separation phase and so on, we would destroy them we would protect entire continents. It would not be designed to protect missile sites or anything of that kind, but would protect populations. Well, those are great hopes and great promises, and that's how the SDI began. But that president is ill-served by the pretense that has deceived Secretary Weinberger, that permits him to believe that the president's goal is still the goal and the promise of the SDI. Indeed, that goal is now stated by the SDIO organization as enhancing deterrence of nuclear war, whereas the president's aim was explicitly to replace deterrence. The president's goal was to be able to give up persuasion of the Soviet leaders not to attack us or our allies, instead rendering a nuclear attack harmless. Last year, in a debate with me in Baltimore, General Abramson's special assistant defined quantitatively what SDI must accomplish for its leaders to believe that they have successfully carried out their mission and deterred nuclear war. He said the Soviets could right now destroy 6,000 military targets in the United States with their strategic nuclear weapons. He said that if SDIO could show us the way to limiting the Soviet targets destroyed in the United States to 3,000, then the Soviets would be deterred. Not accomplishing their military goals, they would never attack. But what about defense of population that we've heard about now? That was the president's goal. Would we defend our cities? No, he said, there's no military benefit to the Soviets in destroying U.S. or Allied cities, so they would not strike them, and we would not need to defend our population. According to SDIO, the Russian bear has become the Soviet pussycat. Apparently, SDIO says we are to forget about preventing Soviet compulsion, coercion of U.S. or its allies. We're supposed to forget about the threat that Secretary Pearl has been stressing for the last 15 years. By that logic, nuclear war could be reliably prevented and freedom preserved by our unilaterally giving up our entire military. We would have no more military targets to be destroyed, therefore no threat of war. More realistically, there is now the very real prospect of deep cuts in the Soviet nuclear weapon force, beginning with 1,500 warheads to be eliminated in the INF Treaty to be signed in 3 weeks here in Washington, and a cut of 50% or more in strategic nuclear weapons. This is a surer way and a quicker way to preserve those military targets in the United States than by continuing with the research program, which is bound to fail. Now, am I against strategic defense? Absolutely not. I think the unprecedented indifference that you heard about from Secretary Pearl, ignoring the threat of the missiles fired by accident, of a single missile fired by an errant Soviet commander, ignoring the threat to the Minuteman, is caused by the fact that the leaders of the United States have not had presented to them limited programs to accomplish these limited options soon and economically. Over the decades, I've been much involved in this sort of thing and have proposed, for instance, close-in defense of the Minuteman silos, taking advantage of the fact that a Minuteman silo survives if you can keep the nuclear warheads more than a couple hundred yards away. No interest in this government or in previous administrations because we do not regard the threat to Minuteman as real. In 1983, President Reagan's Scowcroft Commission on Strategic Forces said that Minuteman vulnerability could well occur, but that the overall force would be invulnerable and deterrence assured because of the presence of the submarines and the aircraft. As for the accidental launch of any number of Soviet missiles, we can solve that problem in a year, and I've written about it for many years, by retaining on the Soviet missiles in operation, as well as on our own missiles, the command-destruct link that you saw work so well on the two solid rocket boosters in the Challenger accident. The same is true against terrorist launch of single ICBMs. We have a weapon already in place. It's called the CIA. If we need a backup, it can be the Minuteman II to perform a nuclear intercept thousands of kilometers away. Thank you.
Thank you, Doctor. Our next panelist, once again, Lieutenant General James Abramson.
Throughout this debate, what you often hear are, in my judgment, oversimplistic arguments on a very, very complex subject. So I must start with a description of what the program truly is and build on what Richard Pearl has outlined. And secondly, reject what I consider to have been the simplistic arguments. And in fact, Dr. Garwin is often defining for me what my objective is. The objective is very clear. The objective was laid out in the President's program and has not modified. It was a threefold challenge that the President laid out. The first one was, isn't there a strategy that might be more effective for all the unknowns of the future? And that strategy is one, a search for a strategy that would not keep the nation naked to the worst weapon that's ever been developed in history. Secondly, that a strategy by itself is insufficient, in fact, to prevent war. In fact, the strategy must be supported by true technical development so it can be implemented. And finally, a very important element right from the start was to use our development, to use our technical prowess to enhance the ability to achieve meaningful arms reductions in the process. And it is the combination of all three of these elements that truly is the Strategic Defense Initiative. It is not merely an attempt to build lasers or to go to war in space. No. The technique that is often used is, in fact, to debunk this concept, is to reach way out into the future and to take three basic kinds of things. The first one is to define a poor system, one that we can't afford. The Union of Concerned Scientists have often done that, and if you go through their various reports, from the first one in March of 1984, where they defined what it is we're trying to build, and said that for a particular kind of laser, it would probably take something like 2,400 battle stations, and then costed that, and over time have finally come to the point that for those same conditions, that in fact it is not 2,400, but is on the order of, as Dr. Garwin indicated in his Nature article, 46 to 50. Then he shifted gears, changed the fundamental problem, and went back to the 2,000. And by the way, Dick, when I was in school, it really wasn't effective to, when I got the answer wrong, to change the problem. I usually didn't get any credit for that. The same kind of reasoning has occurred in several other places, but let me move on. In some cases, they make a simple analysis which is either irrelevant or wrong, and use that in the arguments to say that it cannot be achieved. And again, the Union of Concerned Scientists, in laying out their discussion on the neutral particle beam, scientifically made the dramatic error that made this, in fact, an impossible achievement, and in fact is incorrect. Finally, they say that it can't survive very often, and one of the ways in which they approach this is that they do a theoretical analysis, and which is practically and operationally not significant. Now, all of those are arguments that are often used, but frankly, those are details. The fundamental principles that each of you should consider is, do we forever wish to rely only on a vision that is dominated by a single weapon, and that weapon being and having our country and perhaps their country laid open to that weapon? Now, the single most important characteristic of any deterrent strategy, and by the way, very often, in fact, in my last debate with you, Carl, there was a final assertion that what we're dealing with here is destabilizing. What we must do is look to the single most important characteristic of any deterrent strategy, and that is, does it, when the crisis develops, when the problems develop, when the misunderstandings develop, does it discourage a first strike with these powerful, powerful weapons, or does it discourage it? So I would like to leave a challenge, in fact, two challenges, with the other members of this panel, and they are to explain how it is that defenses truly are destabilizing, and secondly, to explain how it is that they will deal with the fact that the Soviets have such an aggressive program searching in each of these fundamental areas. Because remember, the Soviets have been invaded. They understand just how it is that a nation cannot survive, particularly under surprise attack. They learned that in 1942 and in the First World War. So if you would please explain what your proposal is to deal with, and there are many of these over on the side, what the Soviet challenge is in strategic defense. And for those of you, I won't go into all of the details of that, for those of you who would like to see it, there are some booklets on the side that explain that.
Thank you, General. And our final opening statement will be presented by Dr. Carl Sagan.
Thank you, Congressman Markey. There are almost 60,000 nuclear weapons in the world, nearly 25,000 of them so-called strategic weapons, which are designed to go from the homeland of one nation to the homeland of another. There are only 2,300 cities on the planet Earth, if you define a city as having 100,000 people or more, and this is one of many ways of indicating the grotesque disproportionality between the power of the nuclear arsenals of the United States and the Soviet Union and any conceivable use. It is very likely that in case of a so-called central exchange between the United States and the Soviet Union, the long-run ultimate deaths will be several billion people. And given these stark and unprecedented perils, it is natural to try to find a way out of this trap that the United States and the Soviet Union have set for themselves and the rest of the planet. Jury-rigging, booby-trapping the planet Earth with 60,000 weapons of unprecedented ferocity and destructive power. The idea, therefore, of defending against a massive attack by the potential adversary is attractive and was reflected in the President's March 23, 1983 speech, in which he explicitly talked about population defense, not enhanced deterrence, not improving the balance of terror, not shooting down an errant missile or one launched by a terrorist group or a rogue nation, but defense of the continent of the United States. And this has clearly been the intent of the President and the recently retired Secretary of Defense. But because this is so difficult to manage, there is a temptation to shift the ground, to invent more modest objectives. And that is why we now hear of these other objectives. And this is sufficiently serious that it has been called on the floor of the Senate a bait-and-switch tactic. The population is drawn in by the prospect of being defended even against a massive Soviet attack, and when they're in the used car salon, then they are offered something more modest, and the hope is that no one will notice. SDI is fine if it is perfect. That is, if no significant number of Soviet warheads leaks through the shield. The most optimistic numbers you can hear from technically competent advocates of Star Wars is 70, 80, or maybe even 90% of incoming Soviet warheads destroyed. Well, take the more optimistic number. If 90% are destroyed, 10% get through. 10% of, say, 10,000 Soviet warheads is 1,000 warheads. 1,000 warheads is much more than is needed to obliterate the United States. The shield is leaky. Now, this is different from the usual presentation, say, on network television, where what you see is a 2 or 3 warheads on lazy arcing trajectories, each of which has the letters CCCP on them, so we know whose they are. And then screen left comes a spiffy laser battle station with the letters USA on it, so we know which one that is. And then there's a noise like bzz, bzz, bzz. 3 flashes of light, and surgically removed from the screen are the 3 Soviet warheads, and that's that. This is the video arcade version of SDI, and it has dominated the thinking of most Americans on this issue. An actual representation, which we've made an attempt in this painting by John Lomberg to the right to demonstrate, is an overtaxed U.S. SDI system shooting down some fraction of the incoming warheads, with hundreds or thousands of warheads penetrating the defense, landing on U.S. territory, and that's what all those little orange mushroom clouds are that you don't see on network television representations of Star Wars. There is a delusion of perfection. If you look at the weapon systems that have been procured during this administration, and look at the immense numbers of embarrassing failures. If you look at the 241 deaths of the Marines in Lebanon, or the 37 deaths on the USS Stark, if you look at the shuttle disaster, or if you like, Chernobyl, it becomes very clear that the enormous reliability required for Star Wars, there'll be the same contractors responsible for all those other systems responsible for Star Wars, is simply not achievable. And that is its most serious defect. It has many defects, but that's its most serious one.
That concludes the period for our opening statements. We now move to the rebuttal period, and the speakers will be recognized in reverse order. And so for a 4-minute time period now, we will recognize those speakers, and we will begin with Dr. Carl Sagan. Well, we will leave it to the decision of the various teams and their choices to have Dr. Garwin begin on the rebuttal period, and we will recognize Dr. Garwin for 4 minutes.
Thank you. Let's bring us back to a discussion of the SDI program on which General Abramson has been in charge of spending some $5 billion, and for which the Fletcher Committee in 1983, which wrote the technical blueprint for the research program, said that some $70 billion would be required. $70 billion over about 10 years. So that's what we're discussing, and the things that are being said now, not what people may or may not have said before. I want to address a couple of the questions that have been raised. For instance, in December 1986, the former head of System Design Studies for the SDIO joined with 4 colleagues to publish a proposal for early deployment of an SDI defense. Incidentally, it had 2,000 defensive satellites, but of a different type from those that General Abramson was talking about. But 2 years ago, President Reagan signed National Security Decision Directive number 172, which said that no SDI system could be considered for deployment unless it was adequately survivable and cheaper to build than to overcome by more offense. Why is that? Well, this addresses the question that General Abramson asked, how are defenses destabilizing? Because the State Department published an official explanation of this NSDD 172, it said that if it was not adequately survivable, it would provoke attack on the system, provoke nuclear war, rather than prevent it. And if it were cheaper to build than to overcome with more offensive weapons, it would stimulate a nuclear arms race in offensive weapons rather than quench one. I see, however, the same kind of head-in-the-sand ostrich behavior toward this question of survivability and cost that has led to the Challenger disaster and to a number of other failures in centrally directed programs. It is worse this time because we are not up against nature, cold launch weather. We're not up against the engineering realities of a supersonic transport airplane. We are up against the cleverness and determination and resources of the Soviet Union, which, if they wanted to have their weapons negated, could just throw them away. So obviously it's worth a great deal to them, as it is to us, to maintain the effectiveness of our nuclear weapons. Let me address another question as to why the Soviets have such a large program in defense and in every one of these areas discussed in the SDI. First, they don't. The defense literature itself says that there is no evidence that the Soviets, although they work in neutral particle beams for fusion research and so on, no evidence that they have a weapon program in neutral particle beams that we are proposing. They have had in the distant past anti-satellite tests, as we have had, and they have a deployed system for defense against ballistic missiles in the Moscow area. Their one site permitted under the 1972 ABM Treaty, just as we had a better system operated for the year 1975-76 in Grand Forks, North Dakota. The key to the question, though, of destabilization is in the other part of General Abramson's request. The Soviets know the perils of a surprise attack, and that's exactly why they fear a U.S. SDI. That is exactly why Caspar Weinberger said that a Soviet SDI program would be the worst strategic nightmare he could imagine. Because a system incapable of defending against a first strike might be very good at defending against a retaliatory strike, the little that's left after the other side has been disorganized.
Next, we turn in rebuttal to Richard Pearl.
Well, thank you, Mr. Chairman. Dick Garwin believes that arms control is a superior way to diminish the threat that we face. But Dick, arms control and SDI are not necessarily mutually exclusive. I can recall not long ago when the Soviets said there would be no agreement on intermediate forces unless we abandon SDI. And we, in all likelihood, will sign precisely such an agreement when the summit takes place in Washington. Moreover, our proposals to reduce offensive forces met with Soviet rejection until the President launched the Strategic Defense Initiative. I'm glad to see that Dr. Garwin believes in limited defenses. So do I. But I'm touched by Professor Garwin's confidence in the CIA's ability to deal with all contingencies. It's not a confidence that I share, and I see no reason why we shouldn't have the insurance that would go with knowing that if a missile should be launched at us, we would have some capability, some chance of preventing it from doing the destruction it would otherwise do. Dr. Garwin says that the SDI program is bound to fail. What is it that's bound to fail? All research and development in this area? Even the development of limited defenses, a partial defense? Even a defense that might strengthen deterrence by depriving the Soviets of confidence that they could launch an attack against us and have enough of their weapons reach their targets to diminish unacceptably our capacity to respond? And how do we know it will fail? History is littered with the intellectual debris of people who believed that things could not be done. For men of science, I find this certainty, not skepticism, but certainty, that our research and technology effort must fail, truly astounding. Dr. Garwin believes that there's no evidence that the Soviets have an SDI program, but I can assure you that the Soviets are investing heavily in a broad array of technologies, all aimed at determining what kind of strategic defenses might be deployed. And the evidence on this is overwhelming. Now, some of you may have noticed that in his remarks, Carl Sagan refused seriously to respond to the notion that there are objectives and purposes for the SDI program other than the construction of a perfect defense. He much prefers to erect as a straw man the concept of a perfect defense and then attack that. I don't believe that one needs assume a perfect defense in order seriously to face the questions of should we be without any defense? Is there not something in between perfection and absolutely nothing that makes sense, that's in our national security interest, that might protect lives if a disaster should happen? He accuses the proponents of SDI of having switched objectives, as though a program could have only one objective, and the most demanding objective. Most military programs have multiple objectives, and that's as true of the SDI program as it is of many others. And one of those objectives is to strengthen deterrence by diminishing the Soviet capacity to execute an effective attack. And another one, a vital one in my view, is to deal with precisely the kind of accident that Dr. Sagan referred to in another context. He reminded us of Chernobyl. He reminded us of the Challenger accident. And yet he would sit here and deny us even a research and development program, knowing that accidents can happen. And I regret to say that over the long run, accidents undoubtedly will happen. There is indeed a video arcade vision of SDI, but it is Carl Sagan's, not that of the program managers. The program is exploring a broad array of technologies. We don't know whether it can be done. We're withholding judgment about whether it can be done, but we'll never know until we try. And if we reduce a broad and serious program to a cartoon, then I can understand how one would be discouraged from proceeding forward. But that isn't the program that we've embarked upon. And I think we all have to answer the question of whether we are prepared so airily, so breezily, to take the risks of having no program whatsoever with whatever consequences that may entail.
Thank you. Next in rebuttal, Dr. Carl Sagan.
Thank you. I think we're seeing an important shift in the opinions of those outside of the White House who are supporting SDI. Note the concentration in General Abramson and Mr. Pearl's discussion on enhancing deterrence. It is as if they have acknowledged that defending the civilian population is impossible. It's an admission of the failure of the president's vision. And if there is a cartoon representation of SDI, it is Ronald Reagan's representation. And I think if they wish to distance themselves from the president's vision, they should do so explicitly. On the issue of other ways of enhancing deterrence, that's no problem at all. But is SDI the most effective, the most reliable way of enhancing deterrence? And we can argue that there are many other ways to do that. Mobile land-based missiles, demerving submarine, fleet ballistic missile submarines, and other new technologies. By no means clear that anything like SDI is the best way to enhance deterrence. As for research and development, of course there should be research and development, but nothing like the $3 to $4 billion cost that we have today. I'd like to say something about cost. Naturally, the advocates of SDI do not wish to put a dollar tag on what a full-up system will cost. Secretaries of Defense, former secretaries of Defense of both political persuasions have made estimates in the $1 to $3 trillion range, which gives us some idea of what we are talking about. General Abramson, in one of our past debates, has stated that if it was anything like $1 trillion, he would recommend to the president not to go ahead. And that is a very important and straightforward statement from him. The kinds of expenditures we're talking about in the present fiscal climate is a prescription for economic ruin. The United States in the last 6 years has gone from the largest creditor to the largest debtor nation in the world. The present national debt is not only larger than that of any previous administration, it is larger than the sum total of all previous administrations, back to that of George Washington. The United States has spent each year an increment in the Defense Department budget during the Reagan administration, which just equals the increment in the national debt each year. It is not very difficult to see that there's some connection between the two. As a result of these sorts of expenditures, a rhetoric opposing fiscal irresponsibility, a reality embracing it, the United States is now, in many respects, something like an underdeveloped nation. We're 17th in the world in infant mortality. 1/4 of the population is functionally illiterate. Patent applications are steeply down. They'd be much more steeply down if not for Richard Garwin. There are homeless in the streets of every major city. 20 million people go hungry every day. There are half as many degrees, advanced degrees in science and technology granted in the United States each year than there are in Japan, with half our population. The United States is 14th in percent of the population with safe water, and on and on and on. The question is whether national security is merely developing more gadgets. And I'd like to just close with a one-sentence quote from Dwight Eisenhower. The problem in defense spending is to figure out how far you should go without destroying from within what you are trying to defend from without.
And finally, in rebuttal, General James Abramson.
Dr. Sagan, I thought that that was a very interesting outline of many problems, although I thought this was that this nation and other nations have, but I thought that this was a debate about strategic defense. And talking about baiting and switching, I haven't got the foggiest idea in terms of what the relationship is between education and payment and SDI. Now, that's the real issue here. And in order to deal with the real issue and the investment, it's important to understand what we are spending on the research program. The research program consumes, over the last 3 years, less than 1% of the Department of Defense budget. It consumes, and the average over the last 3 years, less than 1/4 of 1% of the total federal budget. So if the implication, Carl, is that by eliminating SDI, you are going to solve all those problems, you're a brilliant problem solver, and I hope very much that you would be elected to a position of responsibility to do that. Now, I think there's one more key element that must be outlined. Notice the difference as when we say that we are attempting to enhance deterrence. Nobody has explained why defenses cannot enhance deterrence, because after all, the first objective is to prevent that nuclear war in the very first place. And the contention that we have moved away from the President's vision is Dr. Sagan and Dr. Garwin telling me what I'm doing. I know what I'm doing. I know what the President wants me to do. I have my direction, and it's very, very clear. And in the first direction that came out, it said that SDI will enhance deterrence because, after all, it is intended as a first objective to prevent war. And I think that it's very important to illustrate that merely because we recognize that there is nothing perfect in this entire world, that does not mean that we do not support the President's objective of working to make a very thoroughly reliable or an effective defense possible. Now, let me deal with one more key element of this, and it's important to recognize the differences between, even though they may be stylistically very great, the differences between what we're saying here are not so great as one might say. In both cases, we are saying there should be a research program. In both cases, that research program should be aimed at defense. In the case of Dr. Garwin, he has said it should be concentrating on terminal defense, the attempt to defend weapons in order to enhance deterrence. And in fact, he has offered several ideas in those, something called swarm jets. He's also offered a unique idea, and that's burying bombs across the northern territory of the country and blowing it up in such a way that the dust will stop the warheads on the way in. That's a last-ditch stand, I must say, as one looks at it. The real difference here is the thrust of the program. And one more time, I would say, we are searching for the most efficient way to do two things: prevent war by interfering with their strategy, and if the tragedy would ever occur, to find a way to protect as many human beings on this planet as we could, as the creativity of our engineers and as the resources that the Congress allows us, not only now but in the future, that can be applied to the overall program. And we are dedicated to making it affordable and cost-effective at the margin, those criteria. And the really good news is that we are making progress in all of these fronts. We are making progress in the strategy. The technical progress is immense at this point, and I invite many of you to come and look at that. Spend as much time as you do listening to both sides of the debate, seeing what the real progress is. We have the most open program in history. And thirdly, the last challenge the President laid out was one where, for the first time in history, we have the prospect of true arms reductions, in spite of all of the worrisome efforts that the critics of the program have said that this will make it impossible. For the first time, we have the real reductions, and we have real negotiable proposals on the table. Now, that sounds to me like a successful strategy and a good news story.
Thank you, General, very much. Now, that concludes the opening statement and rebuttal period. We're now going to move to a period of questions, wherein the panelists can ask one another questions. The limitation will be this, that collectively each side will be given 2 minutes to be decided upon by that side as to how they will use it in order to respond to any of the questions which are posed. We would ask that in anticipation of that, that all of you out there who have been given cards to write your own questions, that you begin to pass them down to the center of each one of the aisles, and the staff will come down and pick up your questions so that they can also be posed to the panelists. So let us begin at this time with a question by Richard Pearl to Dr. Garwin and Dr. Sagan.
Carl, for how long do you think it is prudent, safe, and wise for us to go on without any capacity whatever to interfere with even a single accidentally launched missile? And recognizing, as you did, that we should have an SDI program, but not at the $3 to $4 billion level, what level do you think is appropriate, and how would you organize that program?
Well, first of all, I think we have heard, CIA aside, from Richard Garwin, ways to do it which don't involve SDI. For example, the fusing by radio signals of warheads on U.S. and Soviet strategic missiles, so that if there is an errant launch, they can be destroyed in flight, assuming the goodwill of either side. And the use of existing, well, if they're really not goodwill, it's unlikely they would just fire one ballistic missile. And the other method that he mentioned was the use of Minuteman boosters and warheads to destroy missiles not so fused. Soviet Union or by some other nation, or the idea of a terrorist group having a ballistic missile is slightly laughable. SDI does not respond to the most likely delivery mechanisms of terrorist groups or small nations, which are nuclear weapons in embassy basements in Washington and motorboats in harbors. As far as what a prudent level of SDI funding goes, I would think something around $1 billion a year might not be excessive.
Next question posed by Dr. Garwin to General Abramson and Richard Pearl.
General Abramson, in a September 21 report from the Department of Defense to the Congress, it says, because it cannot be expected that the Soviet threat will remain static, a defense that could be effective if deployed in the mid-1990s may not be effective if deployed significantly later. Consequently, such delays could result in the loss of deployment options. I gather then that there is a race imagined between the deployment of a strategic defense and the evolution of the Soviet strategic threat. Now, your chief scientist told us last year that SDI would be feasible only if it could be done in a totally revolutionary management fashion, taking half the time of a normal program. And you yourself, I believe, have said that the launch cost to orbit has to be reduced from your $1,500 per pound for the space shuttle by a factor 10 or so. You would be working with exactly the same contractors as on the space shuttle and other defense programs, some of which Dr. Sagan mentioned. How will you and they achieve a tenfold reduction in launch costs below what you were able to do when you were in charge of the shuttle program, and do that responsibly and predictably sooner than the Soviets can react? How can you assure the nation and our allies that that can be done?
Dick, I'm delighted you asked that kind of a question, and I'm afraid I'll have to answer, since you are arguing by analogy with my personal history. I was responsible for the Maverick missile in the early days. That was, when I was in charge of it, the lowest cost and most effective missile within its specifications that had ever been produced. The lowest cost, most effective fighter that the United States has produced is the F-16. And in fact, I brought that in line in 3 years, and only I didn't do it alone. I was fortunate enough to have a national team of exactly those contractors that you are degrading. And I would say that when you compare with the space shuttle, first of all, when I was in charge of it, it was a safe program. Secondly, it was very clear from the start that the space shuttle was a generation of technology that it would not offer the cost effectiveness that we would need for not only this system in the future, but others. Therefore, we are embarked on precisely that, and that's the good news of the program. And I can give you example after example of that. The research is not scientific research primarily of the kind that is often suggested, creating a new laser or something of that, although part of it is that. Let me give you one example of a good news story of exactly that kind. In every one of these missiles, or in every one of our systems, we would have to have a inertial unit, something that tells the missile where it's pointed and how it's pointed. And we have now achieved what I consider to be an economic breakthrough in that area, where the past, all of these units cost on the order of $100,000, and we now have one that will promise in production to be on the order of $5,000. Now, I can give you any number of those, but that's part of the good news story. The answer is we will find a way, or we will not propose that it's ready.
Now we'll stay with General Abramson as he poses a question to Drs. Garwin and Sagan.
I think that I've already asked the key question, and Dr. Garwin countered by talking about a type of stability that I think is often confused. There are several types of stability. One is called arms race stability, and that's what's often used in these discussions. Perhaps the most important one, and the one the characteristic of any of these that I talked about, is this crisis stability, the one where we have a situation, not where it's merely an accidental launch, or maybe it is in fact this terrorist operation, but where the real issue is, how do you take away the incentive to strike? Now, you have given us you have not answered my fundamental question. Could you describe how it is that relying exclusively on offensive missiles forever, with all the technical and political unknowns in the future, truly can offer us the level of crisis stability the world deserves?
That's your question. We really can't rely on offensive missiles always. We will have some defense if it is necessary, but the defense for these limited jobs has to be put up against other means of accomplishing the same goals. And that was the recommendation of the Scowcroft Commission: no defense in our future, but single warhead ICBMs in survivable basing, either in silos or mobile, smaller submarines to permit the reduction of nuclear weapons without having all our eggs in a single submarine basket. The problem is that we want to escape from the fact of vulnerability. And one escape is into fantasy. We know people like that. But that is not an option for a democracy which wants to take care of itself and even contribute to the well-being of the rest of the world. So that's why I propose that we have a $1 billion a year non-SDI program. The SDI is too much advertising, too much demonstration, and not enough performance. And it should be oriented to investigating whether there are any new ideas out there. The ideas that have been proposed thus far have been found wanting. If you say maybe somebody will think of something new, maybe, and we want to be the first to do so, but we'll not think of it in a $70 billion program oriented toward deciding whether deployment is possible or not.
And finally, Dr. Carl Sagan for General Abelson and Mr. Pearl.
Thank you. I want to see if I can succeed in drawing the distinction I've been pushing at a little bit. The President, on more than 24 occasions, has stressed that SDI is either A, for population defense, or B, is non-nuclear. Now, it's true that he proposed SDI without much significant discussion with his advisors. When Secretary of Defense Weinberger heard about it, his comment was, "It's not a bomb, is it?" What I would like to ask is it true what the President says, that it's for population defense and it's non-nuclear? And is that what SDI is working on, or is the President misinformed?
Well, again, Carl, you're posing this as a choice between alternatives when, in fact, it is entirely possible, and the SDI program is indeed intended to explore a variety of approaches and a variety of objectives. My own judgment, you asked the question earlier, if we wish to put distance between ourselves and the President, why not say so explicitly? My own view is that the President's long-term vision of a comprehensive defense is just that, a long-term vision. In the practical world of the near future, I think we're unlikely to accomplish that. But you go to the extreme view of saying that because you cannot accomplish a perfect defense in the long-term future, you should have no defense now. And that strikes me as dangerous and unwise. Now, the program aims at a layered defense with varying degrees of capability, undoubtedly evolving over time. I believe that from the earliest deployment of a strategic defense, we would have the enormous benefit of knowing that we had some significant capability to deal with the kind of accident that you made a persuasive case is likely to occur. Dick Garwin wants to do it with Minuteman II missiles. I can remember talking to Dick Garwin 15 years ago about the effectiveness of a program of ballistic missile defense that was tailored specifically for that purpose. And his view was as pessimistic then as his view is today. And yet he thinks you can take an ICBM and easily convert it into an anti-ballistic missile device. If he would apply that standard of assurance and confidence to the SDI program, he might trade places with General Abramson. But the fact is that the multi-layered approach offers every opportunity to produce some early defenses that are partially effective, and depending on the evolution of technology, it may be possible someday to reach that more comprehensive goal. But you do not have to accept, and I think would be foolish to accept, that only a comprehensive defense is worth pursuing, and if it can't be pursued, then we should have no defense at all, and that's the essence of your position.
I think I do need to add a comment. It is continually posed that a partial defense or a defense that is building by phases, one step at a time toward the President's long-term goal, is either to defend strategic weapons or people, and that is not the case. If it were exactly the kind of terminal defense and limited to the terminal defense, as Dr. Garwin has indicated, that might be the case. Then we would have to make a choice. Do we put those terminal defenders around a city, or do we put them around a Minuteman field? That's precisely the function of a layered defense, to ensure that we can attack the ballistic missiles at the most efficient area, and that's when they're just getting started, and layers behind that. And what we defend depends on what the Soviets are shooting at. And we will indeed be defending people. We will be defending people right from the start. It won't be a perfect defense. But in the long run, we will continue in a responsible way, and the responsible way to build anything as radical as this is a step at a time, to get experience in that first step and then build toward a second step, enhancing the technology at each step of the way.
Let us just conclude at that point on the question period and move on to questions from the audience. And we'll begin with a question which is posed to the Abramson-Pearl side. We will give them 2 minutes to answer, and then 2 minutes to the other side to also comment upon what they've heard. The first question is this. Since the Soviets are and are likely to remain adversaries, why isn't SDI likely to provoke the Soviets to deploy additional offensive weapons in order to offset U.S. defensive deployments and to enhance their own deterrent forces? General Abramson, Mr. Pearl, 2 minutes.
If we were limited and limited our thinking to terminal defenses of the kind that Dr. Garwin is talking about, that would be exactly the case. A single layer with a single countable number of responsive missiles, all they have to do is to try to add a few missiles in order to change that. That's very different than a layered defense. For example, 5 layers with only 60% effectiveness at each layer. And by the way, this is an example. That's all it is. But we have very real possibilities of building to that level at this point. It's quite clear that it's possible. Instead of just 1 or 2 or 3 additional missiles, we're talking about 293. It's impossible for them, within their economic constraints, to deal with a layered defense by doing precisely that. Therefore, they're logical people on the other side. They're logical adversaries. And they would pick the approach that wouldn't break the bank for it.
If I might add to that, the question accepts implicitly the notion that the Soviets insist on having offenses at the level that they now have them, and that they would not be content with any lower level of offensive capability. And yet, as we look at the Soviet offensive force, thousands of warheads on ballistic missiles in particular, Many of us believe that that force is vastly larger than the Soviets need for deterrence. And if that is the case, and by the way, the Soviets themselves have said that they would be prepared to reduce their forces, if in fact the existing Soviet offense is excessive to their needs, over and above what is required for deterrence, then they would need not respond to the degree to which all that we were taking away from them was that additional and quite menacing capability that I believe they're not entitled to have.
Dr. Gowan and Sagan, 2 minutes for rebuttal.
It is not I who say that defenses are destabilizing. It is the Reagan administration in explaining the president's action. And I'll just say it again. Unless the defense is adequately survivable, it's likely to start a war rather than prevent a war. And unless it is cheaper to build than to overcome, it will cause an offensive arms race. Now, if you don't accept those statements, Secretary Pearl, General Abramson, argue with President Reagan, the Defense Department, and the State Department. Now, what you appear to be saying is that you're confident that you can satisfy those requirements. I see no sign of that. I see inside the SDI a willingness to assume away the threat, to make a straw man response, to fire all the Soviet nuclear-armed interceptors simultaneously because that's least effective, rather than holding them when the targets are within range. I see a continuing misconception that space mines have to be covert to be effective, ignoring the fact that they've always been proposed as overt. So once you find out that there's a space mine which says, I am a Soviet space mine, there's been no proposal what to do about it. It's no sense saying, we'll find out it's a Soviet space mine. So I believe that ignoring the requirement, assuming it away, is the way to disaster. And that's why I think that the research in ballistic missile defense ought to be done without an SDI organization.
Let me just add, going back to what the question asks, it is certainly clear that if the Soviets wish to maintain a high probability of a certain fixed level of damage on the United States, and if they believe that a deployed SDI will be able to shoot down a certain number of their warheads, then the option open to them, there are several options. One is to increase the number of warheads until it compensates for the capability they imagine for the US SDI. And since it is very likely that the capability to do that involves existing technology and will be much cheaper than SDI, we give the Soviets the advantage on that issue. In addition, the Soviets have opportunities to underfly SDI, even if SDI were to work miraculously. It doesn't touch ballistic missiles on depressed trajectories, it doesn't touch low-altitude aircraft, it doesn't touch cruise missiles, it doesn't touch motorboats in harbors. And finally, the Soviets have, if SDI is deployed, a strong incentive towards decoys and so-called penetration aids. And for all those reasons, the response to SDI available to the Soviets looks to be cheaper and technologically readier than SDI itself.
The next question goes to Dr. Sagan and Gowan, and that is that science entails constant technological advancement. Since SDI embodies the pinnacle of American technology, how can you as scientists justify suppressing it?
General Abramson said the work is not science, it's engineering. And what I want to do is to go back into a much smaller program where science and imagination hold sway. And I wouldn't mind having a general program for reducing the cost of everything we do in the Defense Department as well as in the government. So I think it's great if we can get this promise of a $5,000 inertial guidance system into production. I think it would be wonderful to use it in our strategic offensive missiles as well as in the defense. But that's not an SDI thing. That's a technological thing. Science, I'm in favor of. Cheaper products, I am in favor of. I just don't think this ought to be done under the mask of a long-term response to the president's dream, one man's dream, while delaying the near-term accomplishments in ballistic missile defense that we could obtain if we did not have a research and development only program.
Dr. Sagan.
One aspect of SDI, which I think has not been mentioned and it's important to not lose sight of, is that when you wave $1 trillion at the U.S. aerospace industry and scientists and technologists, you will produce what one general officer described as a feeding frenzy. Now, what happens is that any such goal, whether it can be accomplished or not, whether it's feasible or daft, deflects a large fraction of the available U.S. scientific and engineering talent away from other tasks, away from improving deterrence in other ways, away from conventional arms work, and especially away from the civilian economy. And in that way, SDI can work to erode national security in the broad definition of Dwight Eisenhower that I mentioned before. Just one other thing, I was asked, but not at the time that we had a chance to rebut by General Abramson, what was the connection, he said, between education and SDI? Why do I put at the feet of SDIO all of these underdeveloped nation qualities of the United States that are getting increasingly distressing? The reason is that all of those items I mentioned can be addressed by money. Education can be addressed by money. And you say it's only a small fraction of the Department of Defense budget and an even smaller fraction of the gross national product. Yes, that's true right now. But if you succeed in getting into a deployment circumstance, then the budgets, as everybody acknowledged, go way up. So not only will money be taken away from education, but scientific and engineering talent will be taken away from education, from the civilian economy. And so that's how all of those items are connected with SDI.
General Abramson, Mr. Pro will be a little bit lenient on the time you have for.
I'm a little disappointed, I think I have to say, frankly, because I came here expecting I would hear a spirited argument about SDI, and what I think I'm hearing is from the other side is nitpicking about how much money we're spending. They're for SDI, they're for having a strategic research program. They just want to spend less money on it than we do. And if you believe Carl Sagan, we're going to raise or lower the infant mortality rate if we just divert funds from SDI into I don't know what program. The simple fact is that SDI is affordable and manageable, particularly if one looks at the enormous investment that we now make in offensive forces and can look forward to a future in which we can reduce that emphasis on offensive forces and use the consequent budget reductions to finance SDI. It's all very well to talk about $1 trillion in some future, but that's not the program that we're operating. No request has been made for $1 trillion. Unless the research and development, which is of much more manageable proportions, indicates to us that we have a financially sound and technically competent program, there would not be any proposal to deploy, much less a proposal to deploy at $1 billion. So I think we are being burdened with responsibility for a program that doesn't exist. And yet when it comes down to the crucial issue, which is the concept of whether it is wise to go undefended, I find that the other side has conceded the point, and both Garwin and Sagan believe we ought to have a defense. They would just do it differently from the way we would do it.
In that differences, there are quite a few differences, and I commented earlier, between what is theoretically possible and what is operationally effective. Clearly, I agree. In fact, I'm in violent agreement with both of you that we must have a survivable kind of system. Dr. Garwin raises one of his most favorite of all kinds of issues, space mines. And it is a serious problem. It's one that we do deal with. We deal with very, very intelligently. We spend a lot of time and effort working on it. He also knows that much of it we are not allowed to talk about. However, let me just deal with one part of this issue so that you understand the difference between the way it is simplistically offered in the theoretical sense and the reality of this particular kind of a countermeasure. And I only offer this as one example. Often, Dick has explained that an orbiting satellite, if it's an SDI satellite, always goes in the same path And therefore, it's easy to put a space mine up there, and the image in your mind that comes out of that is perhaps something like a Persian Gulf mine that they just kind of sit next to one of our satellites, and there it sits, and we don't do anything. In fact, we make our satellites so that they can maneuver. We give them hardening so that they can handle nuclear weapons at least up to a reasonable radius, and those areas are ones we're making progress in. Dick then says, aha, but a space mine is simple, and therefore you can put more fuel on and you can always stay with this maneuvering satellite. Let me tell you from my experience, the last space shuttle mission that I had was the first time that we repaired a satellite in space. And Crippen flew a very nearly perfect kind of a rendezvous with the Solar Max satellite. And it took nearly all of the fuel for maneuvering that the space shuttle had as we did it. Secondly, that even if you can come into that position, and the Russians have automatic capability to do that, then the game is not even yet, even still, because it is never perfect. And once again, let me go to my experience. As a fighter pilot, you've watched the Thunderbirds or the Blue Angels, and as they fly, it looks very smooth as they stay in formation and move with this system. But I can tell you that the people who are on the wing, the wingmen are sitting there working like mad, putting all kinds of control inputs into this. The assertion that Dr. Garwin and the Union of Concerned Scientists often make at the theoretical level is far from the reality of the operational situation.
Thank you. Next question goes to General Abramson and Mr. Pearl, and that is, under what circumstances would you accept a ban on the deployment of SDI in return for deep cuts in Soviet offensive weapons?
Of course, one has to define the terms in order to answer that question, and I don't know what is meant by deep cuts. But the proposals that are currently being discussed, in which offensive nuclear weapons would be reduced to the order of 6,000, would still, in my judgment, leave enormous scope for horrendous damage, and to go utterly undefended in the face of nuclear forces of that scale would, I think, be dangerous and unwise. So I would certainly not agree to ban strategic defenses in exchange for a reduction of that scale. The President at the Iceland summit proposed to the Soviets that we would be prepared to delay the deployment of strategic defenses until after a period of disarmament during which all the offensive ballistic missiles on both sides would be eliminated. He made the point, which seemed to me logical, and I hope this is responsive to the question, that in the absence of strategic offensive ballistic missiles, no one would have anything to fear from the deployment of a strategic defense, since it would have nothing to shoot down unless the other side cheated. The Soviets flatly and categorically rejected that proposal, giving some serious rise to the question, why are the Soviets so dead set against the United States continuing a research and development and testing program that looks very much like their own?
John, you have 30 seconds. Okay, fine. 2 minutes to the opponents.
I think the Soviets are so unhappy about the U.S. SDI because they don't like to sign an agreement with an insane partner. Because they think that the SDI will not work against a Soviet first strike, and they ask what we want it for. And there's no real explanation why. Let me quote Secretary Pearl back from 1973 in a debate which we both participated. He says, if the Minuteman is vulnerable, there's no need to fear that the Soviet Union would actually launch such an attack, but the political consequences would be dangerous. How to get out of it? He said, the best procedure would be to defend strategic missile complexes with ABMs. The effect of such defense on deterrent survival would be substantial. As an alternative, however, we should press the Soviets to bring their strategic forces down to the level of comparable U.S. forces. Now, that's what we're talking about now. The 50% reduction would be only a first step toward much deeper cuts. But those deeper cuts will not happen if the residual forces are disarmed in prospect by the deployment of a strategic defense. I already quoted Secretary Weinberger as saying that a Soviet SDI would be the worst strategic nightmare he could imagine. Former Secretary of Defense McNamara in the 1960s said if the Soviets deploy this nationwide ABM defense with 5,000 nuclear-armed interceptors, we will build 50,000 nuclear warheads to counter it if necessary. The step-at-a-time defense is precisely the recipe for increasing the Soviet offensive force and at every moment increasing the potential destruction if nuclear war comes.
Dr. Sagan.
I think we have to bear very clearly in mind what would our response be if the Soviets were developing an SDI system of the sort that we're talking about, and we had to face the possibility that what they had in mind was a devastating first strike against the United States with their SDI system used to mop up the residual retaliatory capability of the United States. That is precisely the circumstance that they have to face with SDI, and they are quite properly worried about that, as we would also. Therefore, there is the makings of a bargain here. Each side forgoes SDI and is at least freed from that concern about a devastating first strike. We have before us a historic opportunity, it may not occur again, for massive reductions in the strategic arsenals on both sides, and considering the absurdly large number of such weapons, it would be foolish not to take advantage of that opportunity.
Next question to Dr. Godwin and Dr. Sagan. Richard Pearl has stated that there is evidence of an overwhelming level of Soviet SDI research. Do you agree that it's possible to document the level of Soviet SDI type research?
I heard Ambassador Warren Zimmerman in the fall of 1985 to a group about this size explain that the Soviet Union put about 50% of its military budget into strategic defense. That sounded extreme, and somebody from the audience asked whether he was sure and what was his source. He said, after thinking, yes, he was sure, and his source was a recent CIA study about which he couldn't say anything more. But I happen to have with me the unclassified testimony of Robert Gates and Larry Gershwin from June 26, 1985. And they said that the Soviet Union spends about equal amounts on strategic offense and strategic defense, together about 20% of their military budget. So here this honest, capable man, whom I knew personally, was misleading the audience. He said 50% of the military budget goes to strategic defense. The number in the document he was quoting was 10%. I have no reason to doubt that the Soviets spend $30 billion a year in our money on strategic defense. But that includes their vast air defense program operating 10,000 radars, 10,000 interceptors, 3,000 fighter aircraft, their civil defense program with $3 billion a year or so, the operation of their permitted system around Moscow, and yes, some research on SDI, the answer to which is not a U.S. defense, but our countermeasures program, which runs at about 1 part in 20 of our current SDI program. That's not a countermeasures research program, that's a countermeasures deployment program. So I'm not troubled by the Soviet SDI. They have a very substantial effort in numbers. If you believe in numbers, then you really ought to worry about the agriculture gap, because we have 2% of our people on the farm and they have 30%.
Dr. Sagan.
Just like to underscore the fuzzing that is often done by American spokespersons between Soviet anti-missile defense and Soviet strategic defense, which is largely Soviet anti-aircraft defense, which in turn is due to the very great preponderance of U.S. strategic intercontinental bombers over the comparable, the not comparable, much less Soviet force.
Mr. Pearl.
I hope those of you who are listening caught the word yes buried down deep in Dick Garwin's answer. Yes, he said the Soviets do have a strategic defense initiative. It doesn't trouble him. but the fact that they have one certainly ought to lead us to the question of whether we can afford to be without one. Now, Carl Sagan wants to make sure that nobody misunderstands the statistics about Soviet defenses. And in order to make sure we don't, he has pointed out how much they spend on defense against aircraft and a variety of other defenses. Dick Garwin used the figure $30 billion. It's fair to ask, isn't it, what does this tell us about the Soviet view of whether it is right and proper and legitimate to have a system of defenses? As you listen to official Soviet spokesmen who decry the notion of defending one's forces, and indeed we've just heard the other side in this debate decry the notion of mounting a defense, look at what the Soviets are doing. In every area in which they have been capable of mounting a defense, they have done so. Defense against our bombers, defenses to the degree they can against our submarines, a variety of measures intended to assure that their strategic deterrent could survive attack and perhaps to do more than that. We ought to be doing precisely the same thing, in the most effective way we can, providing for defenses. Now, on the other side, they would have us do it entirely by relying on offensive forces, and only those defenses other than SDI. I think the only conclusion you can come to is that on the other side, they just don't like the SDI program.
Well, that concludes the period for questions, and now we're going to go to concluding statements. Each participant will be allowed 3 minutes for a concluding statement, and we will begin with Dr. Gowan.
Secretary Pearl is right. I don't like the SDI program. It was born in fantasy and is carried out like the admirers of the emperor who had new clothes. Now, we don't actually have to be naked to nuclear weapons. We can wear a small amount of clothes, but what is bad is to believe that you are fully covered when you are not. I would like to take a little of my closing time to point out that the leader of the SDI program has here given a couple of comments which are not actually attributable to me. He says, I want to put nuclear weapons in the ground and blow them up in the Northern Territories. No, not unless you believe the Northern Territories are 1 mile north of each silo, where we would have a small nuclear explosion, which would never go off because there would never be an attack if there is an effective defense. Same argument as the SDI makes, except that this would really be an effective countable defense. He points out that the shuttle has great difficulty maneuvering to achieve a position with respect to a satellite. I'm not proposing a manned, a reusable space mine. That's the trouble with the shuttle. It carries a very small, almost vanishing percentage of its mass into orbit as maneuvering fuel. A space mine can carry 50% or 70% as maneuvering fuel. It has no other mission. I really do believe that the SDI has to look at the threat as it will come. If that's the best kind of space mine, a manned maneuvering space mine which costs $1 billion and carries 1% or 2% of maneuvering fuel, they don't understand the space mine threat. The other two counters to the SDI, and the reason why it will not be found to be adequately cheap and survivable, are the fast burn booster. The Soviets built missiles, as did we, liquid-fueled. If they go to solid-fuel missiles, which they already have, the number of satellites which can participate in the attack on the missiles in boost phase will drop from something like 13% to 1 or 2% with the missiles that the Soviets have now. With the fast burn boosters that the Fletcher Committee considered, not a single one of the defensive satellites could destroy a Soviet missile in boost phase. The other problem, the three problems are space mines, overt space mines, fast burn boosters, and the third is nuclear-armed anti-satellite weapons, which the Soviets already have. They're called Galash interceptors. They are deployed around Moscow. They could make as many of them as they like. They would come up against the defensive satellites at the time of a first strike, if you believe there would be one anyhow, and they would destroy them. They would carry decoys so that they could not be injured by the small rockets, which are the defending satellites' only means for the next 10 or 20 years to destroy boosters. In fact, it is unlikely that these warheads would even be seen by the defensive satellites. So we really have to look at this. We shouldn't look at it only in controversy like this. We ought to get together and discuss these matters. It would help if the SDI would read my papers. Thank you.
Time. Now, for his concluding statement, Richard Pearl. I'll say, I'm sorry, to General Abramson, excuse me.
I think the important thing about the entire debate is, number one, we both believe in some defenses, some investment here. That's critical. There is a complete difference about what it should be, what the investment really and truly should be in. Terminal defenses or something that can be much more effective, layered defenses. There's a great deal of difference between the assessment of progress and perhaps most importantly about where we can potentially go. The difference is that these are criticisms which are aimed at the potential of the future, where we have thousands and thousands of people across the country who are out there making the changes and making the future happen, so that when a deployment happens, it will indeed meet the criteria that the President outlined. Those criteria are very clear. We haven't projected any kind of a difference from those criteria. Those are, first of all, that it be militarily effective. Second, that it be survivable. Thirdly, that it, in fact, produce arms race stability by making it less expensive to build one of these systems than it is to counter it by building more of the same. Now, I'd like for you to imagine just a little bit. Dr. Sagan introduced an imaginative picture here. Think of what an SS-18 truly is. An SS-18, about 9 stories high, it's a huge machine, and that it weighs nearly 500,000 pounds. Now, just the raw material and the cost in that particular system is immense. We are working now for these space-based interceptors, and not exclusively only on space-based interceptors, but on those systems for something that will be about 3 feet high, and that will weigh on the order of 150 to 175 pounds. Now, will that be cost effective at the margin? There is no question, just from the overall kinds of technology and the differences in what we can produce, that we're working in an area where we have an advantage. We will not bring forward a proposal to deploy until it makes sense, until it meets those criteria. But I can assure you it's happening very, very quickly. Regarding Dr. Carwin's point, we're working more seriously on each of those countermeasures than he understands. He has had access to many of the classified areas of the program, and I have specifically authorized him to go into some of those areas. And I just leave you with one last challenge, Dick. For some of your systems that you think are so effective, I would ask for you to bring that proposal, an operationally effective proposal, to me, a practical proposal that we can implement, because that's what we're working on. Not the theoretical countermeasures, but the real countermeasures that can be effective.
And for his concluding statement, Dr. Carl Sagan.
Last week there was a Harris poll of the American people concerning the negotiations on reducing the budget deficit, which may or may not be concluded this week. 82% of the American people said that they did not want social programs cut. 58% believed that significant defense cuts are essential for deficit reductions. These are very large majorities. considering the enormous barrage of argument from the Department of Defense, the White House, and their supporters on the need for a military buildup. $2 trillion has been spent on the military since they've been in office. I think it is remarkable to see the independent voice of the American people on this issue. It is true that the smaller the scale that SDI is imagined, the cheaper it will be, and therefore the more politically accessible it will be. If General Abramson and Mr. Pearl are saying that full-up population defense is only one of the possibilities of SDI, fine. It is a possibility which is not very likely, not very cost-effective, and indeed very dangerous. If the objective is to find some other way of enhancing deterrence, if the objective is some other way to shoot down an errant missile, let us find out how to do that without being burdened by the President's vision of an overall population defense. Star Wars is a highly porous system which cannot protect the civilian population of the United States, even without Soviet countermeasures. There are a wide range of Soviet countermeasures available to them. The system can be overwhelmed. It can be underflown, overwhelmed by adding more warheads, underflown by delivering nuclear weapons by ways other than high arcing ballistic missile trajectories. It can be outfoxed. It is an inefficient way to enhance deterrence. It is ruinously expensive. It is likely to increase, not decrease, the likelihood of nuclear war. Except for all of that, it's a terrific idea. I would like to see this administration devote some small fraction of the media time and bureaucratic attention to explaining why it's important to reduce the strategic arsenals in a massive, bilateral, intrusively inspected missile reduction, and to be responsive to the grotesque buildup of nuclear weapons since 1945 to the present time, something which future generations, if there are any, will regard with the same abhorrence that we regard the institutions of human sacrifice or chattel slavery. In terms of simple planetary hygiene, it is essential that we reduce those arsenals, at least at first, to a tiny fraction of their present numbers, and to free the human species from this specter of massive destruction. Thank you.
And now, in conclusion, his final statement, Richard Pearl.
I hope, Carl Sagan, that perhaps when he visits here in December, you will have an opportunity to make that impassioned appeal to Mr. Gorbachev, because we have had on the table from the earliest days of the administration proposals to reduce radically the strategic arsenals of both sides. I find it a little curious the way this debate has taken shape. We are, General Abramson and I on one side, respectively a long-time public official and a professional soldier, and on the other side we have two scientists. I was brought up to believe that science has a method, and that method is to identify a hypothesis, to do research and experimentation, and carefully collect data, and ultimately render some judgment about the validity of that hypothesis. The hypothesis before us today is whether SDI will prove to be in the national interest. And us non-scientists on this side of the table have said, let's collect the evidence, let's do the research, let's record the results carefully, and then Following the scientific method, let's make a decision about whether we have accomplished a program that is affordable and that is in our national interest. That's not a question that we can answer today, and I find astonishing the certitude on the other side of the table, first, that SDI won't work, and second, that there are a dozen different ways to overcome it if it does work. They also seem to be quite certain about what the Soviets will do. And yet, if the Soviets take seriously their judgment about the effectiveness of the program, Carl Sagan just said you can underswim it and underfly it and outfox it. They needn't respond at all except by underswimming and underflying and outfoxing. They don't have to build additional weapons. Let me conclude by trying for a moment to put this in some historical context. This debate is not unlike a debate that took place in the 1940s after World War II, when Harry Truman was President of the United States. And some of you will recall a debate in those days over whether the United States ought to proceed to develop the hydrogen bomb. It wasn't carried out in public. It was carried out, in fact, in great secrecy. And the scientific community pretty much divided 90% against proceeding and 10% for. And the 90% were led, you will recall, by Robert Oppenheimer, and a small band, 10% or so, led by Edward Teller, argued that we should proceed to develop the H-bomb. The argument of the 90% was that if we proceeded to develop hydrogen weapons, the Soviets would do the same, and there would be instability and great danger. The argument of the minority was that it was imprudent not to proceed. We now know that while that debate was taking place, while Oppenheimer and Teller were making their respective arguments, a young Soviet physicist by the name of Andrei Sakharov had already been assigned by Joseph Stalin the task of developing the Soviet hydrogen bomb. And had Harry Truman, who wanted to see the facts as they emerged from the research, and Harry Truman decided with Robert Oppenheimer and not with Edward Teller, the Soviet Union would have emerged in the late 1940s or early 1950s with a monopoly of thermonuclear weapons. And I leave it to you to conclude how the face of the globe, how the values that Carl Sagan and Dick Garwin and General Abramson and I all share might have been altered. I hope we don't make the mistake that Harry Truman refused to make and believe that we can stop history and the other side just by wishing things were different.
I would like to thank all of the panelists for joining us here today. I believe that we've had an excellent debate, exchange of ideas, and I want to thank our speakers, and I want to thank all of you who are here for your participation in this important debate. The Cannon Caucus Room has never been as filled as it is today, and I think it's a reflection of the importance of the issue which we're debating, that it was able to draw this kind of attention across Washington, and in fact people from across the country who came in here today for this debate. I'd like to thank the staff of Space Watch who put together this forum here today. They consist of Eric First, Cynthia Kelly, Patrick Tracy, Catherine McGraw, Arthur Klein, and Dan Charles, and I think they did an absolutely splendid job in organizing a debate of this magnitude. And I'd also like to use this opportunity to offer some closing observations on the future of the Star Wars proposal. I believe that the year ahead of us is going to be a year of reckoning for the Strategic Defense Initiative program. Between now and December of 1988, the President, the Congress, and the American people have some important decisions to make about Star Wars and national security.
decisions which ultimately should be based on a determination of whether or not Star Wars is in the national interest. The President has to decide whether he is willing to accept some limits on Star Wars in return for deep cuts in U.S. and Soviet strategic nuclear arms. Congress has to decide what level of funding it wishes to provide for Star Wars and whether to limit Star Wars testing in order to ensure continued adherence to the traditional interpretation of the ABM Treaty. The American people have to decide on who will be our next president and whether they want an administration committed to Star Wars testing and deployment or one committed to preservation of the ABM Treaty and willing to discuss limits on the exotic technologies of Star Wars. How these decisions will come out is anybody's guess. But I think that in today's discussion, we have had a chance to look at some of the questions that must be considered before our country commits itself to proceeding with Star Wars testing and development. Questions like, will Star Wars work, or can it outfox, overwhelm, or be outflown? Will it make our cities and populations safer, or will it only defend our missile silos and military command centers? How much will it cost, and can it meet the NHTSA criteria of cost effectiveness at the margin? Will it usher in a new strategic relationship based on defenses, or will it destroy prospects for arms control and touch off a strategic offensive and defensive arms race? Underlying these questions is a more fundamental one. Should we put our faith in technological solutions to our problems, or should we seek political solutions, negotiated solutions? Congress has decided this year to limit Star Wars funding to no more than $3.9 billion and to prohibit any testing outside the traditional interpretation of the ABM Treaty. That gives enough time for our next president to make the decision on whether or not to go ahead with Star Wars. One of the great things about our system of government is that the people decide who they want to have serve as their leaders and what direction they want the country to move towards. The final decision on who our next president will be is in the hands of the people who are in this room, the people who are watching this broadcast, and millions of others across this country. For they will be choosing a new administration to begin serving in January of 1989. You and the people like you will determine who will sit in the Oval Office and who will sit across from the negotiating table from General Secretary Gorbachev. In making that decision, I would hope that very serious consideration will be given to the issue that we have discussed today, whether Star Wars is in the national interest. If you want to continue to be apprised of Space Watch's program of debates throughout the coming year on this and other issues, please contact our staff immediately after this proceeding, and we will be more than willing to put you on our mailing list. If you have any ideas in terms of how we can frame debates for public discussion, please come forward with those ideas as well. We need the input of all sides if we are, in fact, going to be able to frame this debate in a way in which the election of 1988 will reflect the informed citizenry that we really have to have. So once again, I want to thank our panelists, Dr. Gowen and Dr. Sagan, General Abramson, and Richard Pearl. I think they all did an excellent job, and we thank all of you for your participation.
You've been watching a debate on the Strategic Defense Initiative held by the organization Space Watch. This program will re-air on C-SPAN on Saturday, November 21st at 11:30 p.m. Eastern Time. That's 8:30 on the West Coast.
the next American Profile, C-SPAN asks Senators Phil Gramm of Texas and Bill Bradley of New Jersey how they first...
We continue now with a conference on international policies on the exploration of space. The program included remarks by scientist Carl Sagan, the president of the Planetary Society.
Our keynote speaker for the afternoon is indeed Carl Sagan, David Duncan Professor of Astronomy at Cornell University, an active planetary scientist, in addition to being a world figure with an agenda that's as broad as the concerns that push humanity. Interesting change in Carl's proposed talk that happened in the last week, and I'm interested to see how it will affect his remarks. The title that went out on the preliminary announcement of this program, I think most of you will remember, said, "What Mars Can Do for America." The title that Carl is going to speak to this afternoon is somewhat broader, "What Space Can Do for America." Carl Sagan.
Thank you, John. Well, I changed it from Mars to space when I realized that the audience would be rather different from the one at our meeting the last few days, and I wanted to be able to represent at least a range of opinions expressed at our meeting. And it is also true that the title says what it can do for America, but as you will see, I will try to broaden that focus as well. Imagine yourself as a kind of extraterrestrial observer watching the Earth over the last 4.6 billion years since its formation. At the beginning, especially, you see a lot of things falling into the Earth, the final stages of accretion. But you see hardly anything leaving it, an occasional hydrogen atom. That's about it. Maybe a big impact sprays debris off the Earth. For 4.6 billion years, it's one-way traffic. And then, suddenly, just in the last few decades, in our time, that situation changes. Suddenly, there are little objects filled with instruments leaving the Earth, orbiting it, entering into orbit about the Sun as artificial planets, and then running through the solar system. Little, elegant space probes examining every one of the planets known to the ancients, from Mercury to Saturn and beyond, Uranus, and next August, Neptune. And not just instruments, but occasionally people also. Mostly they hug low Earth orbit, cannot bear to leave the mother planet, so it would seem, but 12 of them go as far as the Earth's natural satellite, the Moon. This is an extraordinary event. It is an historic event. It is the first tentative stepping out into a vast cosmic environment. And in the long historical perspective, provided we're not so foolish as to destroy ourselves, I think these events will be as significant as when our ancestors came down from the trees about 10 million years ago, and when our still more distant ancestors crawled up on the land about 500 million years ago. We are entering a new environment far vaster, and more promising than the savannas of East Africa or the previously untenanted land. So in the broad picture, I think that's the large-scale significance of space. But on the other hand, there are all sorts of shorter-term issues, and I would like to address some of the practical benefits of space. By practical, I don't just mean making money, but also issues having to do with the human spirit, the human heart, and necessarily political issues. First, let me say that I endorse Lyndon Johnson's assessment that military reconnaissance satellites by themselves justify the entire cost of the space program, and I would say that that is true for the Soviet Union as well as for the United States. Reconnaissance and treaty verification satellites are essential. They calm the hotheads and paranoids on both sides, who otherwise would be making prudent worst-case judgments, which then drives the arms race. And especially as we are entering into a remarkable new era, apparently, of significant, perhaps even massive arms reductions, such satellites are even more important. On the non-military side, it is clear that communication satellites, for example, are a self-supporting, extremely profitable, extremely useful industry. If you, never mind in the United States, suppose you live on an island republic like Indonesia, where there are thousands of separate islands. The laying of submarine cables from island to island is vastly expensive. If you have a geosynchronous communication satellite sitting above your nation, you can talk from island to island at much less cost, much higher efficiency. The world is now bound up via communication satellites. And this has not just a practical utility for businessmen and emigres, but also a long-term practical consequence of binding up the world, of breaking down the barriers between peoples, of bringing us all together, something extremely important, in fact, desperately needed. The availability of direct long-distance dialing to and from the Soviet Union, I think, is a very useful figure of merit about the degree of openness in Soviet society. It was tried experimentally for a few months and some years ago, pre-Gorbachev, and then dropped for reasons we might speculate on. I think a very important gesture on part of the Soviet government would be to open up the Soviet telephone system both ways to world communications traffic. Meteorological satellites are extremely practical. These days we're quite used to looking at the evening television news and seeing a picture from a geosynchronous satellite showing clouds moving somehow not continuously. And in the practical value of alerting farmers about disastrous storms and temperature decreases, these are again extremely cost effective. And there are some other things along these lines we might mention, but I think this is a comprehensive enough list on the very straightforward practical side to see that space flight is an extremely important aspect of modern life. Beyond this, there is the scientific and exploratory function of the space programs of many nations. If you step back and just think about it, it's astonishing that real money has been spent by governments on astronomy from space, on sending spacecraft to other worlds. A lot of money has been spent on that. There's no immediate practical benefit. I will try to indicate a little later that the slightly longer term practical benefits are very significant. But basically this was supported in order to encourage the increase of knowledge. And I think the spacefaring nations should be commended for that. The United States, the Soviet Union, ESA, Japan, and fractionally a few others. I'd like now to turn more specifically to the NASA program and start with what I think is the key, the fundament of the history of NASA, and that is the Apollo program. NASA was started before Apollo, just a little bit before Apollo. It was formed in part as a response to the successful Soviet launch of Sputnik 1, but the formulation of the Apollo program was a specific response to the orbital flight of Yuri Gagarin, the first human to orbit the Earth. And this was not just a propaganda battle. The orbital flight of Yuri Gagarin indicated a very significant Soviet booster capability, lift capability, and must be understood in the context of the strategic nuclear confrontation between the United States and the Soviet Union. The flight of Gagarin and Herman Titov and their successors in precise orbits, their successful recovery, clearly indicated that the Soviet Union had a capability to deliver nuclear weapons halfway across the planet by strategic missiles. And this was considered to be very worrisome in the United States, not just for the obvious point that the United States could be annihilated. The Soviet Union could also be annihilated at that time by a much larger U.S. bomber force, but also because of the sense of diminished American self-confidence and concern about American allies looking eastward. The Apollo program must be understood in that context, and you can see it in President Kennedy's famous speech announcing the Apollo program. He did not advocate a return of a sample from Mare Tranquillitatis. He did not advocate determining the origin of the moon by the end of the decade. There was no science whatever in his announcement. What he said is that the program would put an American on the moon by the end of the decade and return him safely. President Kennedy's science advisor, Jerome Wiesner, had a deal with President Kennedy that if the president did not describe Apollo as scientific, Wiesner would support it. And that is, with a couple of exceptions, what happened. Apollo was a political program. Another way to see that is to look at the last Apollo mission, Apollo 17, which flew, I think, in 1974. On Apollo 17, the second guy to climb down the ladder was the last man, the last human to set foot on the moon. He was also the first scientist to set foot on the moon. Jack Schmitt, former U.S. Senator from New Mexico. As soon as a scientist set foot on the moon, it was clear that the program had gone too far. And it was promptly canceled as redundant. Apollo was not a scientific program. I think it's very important to remember that programs of that magnitude are driven by political, not scientific reasons, and that is even more true today when there's a lot less spare cash around than there was in the early 60s. Nevertheless, under the Apollo aegis, a great golden age of scientific space exploration occurred. And I don't know if this is going to work. I hate to ask for the Planetary Society's flag to be removed, but I would like to show a few slides. I also would appreciate if the lights could go down. Thanks. Oh, maybe this is going to work. Well, what I hope to describe to you is the timing of the major missions of the U.S. planetary program. Good, the lights now seem to be in good shape. Now all we need. This is a well-known, mass-produced, highly reliable Kodak technology. Now, can we do anything about the backstage light? I'm just trying to think of something to do. Thank you. Okay, now I really have run out of small talk. Oh, that's good. That'll take me a minute. Pose an intellectual test for the speaker, too. That's terrific, but that's not the slide. If I could have the one before that, please. Ah, great. Thank you very much. Okay, this does slip slightly off the edge, but why don't we have the left-hand margin and let the right-hand margin fend for itself? Thanks. Okay, so these are the decades of the U.S. space program, 60s, 70s, 80s. And here you can see in yellow the Mariner missions, Mariner 2 to Venus, first spacecraft to orbit another planet. The mission which gave what I consider the definitive first evidence that the high radio temperature was coming from the surface of Venus, and that led to confirmation that it was a massive greenhouse effect. Mariner 4, first spacecraft to Mars, 5 to Venus, 6 and 7 to Mars, 9, the first spacecraft to orbit Mars, 10 to Venus and to Mercury. Here in white are the robotic precursors to the Apollo missions, the Rangers, lunar orbiters, and surveyors. And then here are the Apollos. Apollo 11, first spacecraft to carry humans to another world, through Apollo 17 in 1973, not 74. Moving target. Also, we can see Pioneer 10 and 11, appropriately named spacecraft, the first to leave the inner solar system and fly by Jupiter and Saturn. The phenomenally successful Viking spacecraft, 2 orbiters, 2 landers, first spacecraft to successfully land on Mars. The Voyager spacecraft, which are still functioning and very well. that have given us our first close-up reconnaissance of Jupiter, Saturn, Uranus, and shortly Neptune, and their rings and their satellite systems, some 40 worlds, more, 45, have been explored by Voyagers, and then Pioneers 12 and 13 to Venus, first American spacecraft to land on Venus. Now, this is a spectacular record of accomplishment for a tiny fraction of the NASA budget, as you'll see shortly, except for the Apollos. Apollos cost a lot. But the rest of it costs very little, and that is a reminder to us that other things being equal, robotic spacecraft cost tens of times less than a comparable manned mission. Well, we see this big cluster of spacecraft here and here, all done under the aegis of the Apollo program, and a few that come after, Viking, Voyagers, Pioneer 12 and 13. Next slide, please. No, but before you go to the next slide, I beg your pardon. Can we go back? Okay. The arrow of time is unidirectional. You probably noticed that the decade of the 1980s did not have a single multicolored triangle in it. We have now finished an entire decade in which the United States has not launched a single spacecraft to the moon or the planets. 10 years after this golden age of planetary exploration, 10 years without a single spacecraft being launched. And this is not just due, it's not primarily due to the Challenger tragedy, because it began long before. The United States has opted out of planetary exploration. Here is the study approval and launch dates of the 3 spacecraft missions that followed Apollo 17, and you can see that the approval dates for Viking and Voyager were still in the midst of the Apollo missions, and Pioneer Venus just after. So while we could argue that the fascination with SDI has deflected some intellectual, fiscal, and presidential attention resources away from the civilian space program, I think the main reason that this decline in U.S. planetary exploration has occurred is because Apollo simply ceased. Next slide. Here is the planetary exploration budget in percent of federal budget, and the highest number here is 0.25%, so of course it's a tiny fraction of that. As a function of time, here's the big Apollo peak, and here is a subsidiary peak due solely to Viking, and it has been at this constant low level ever since. And the next slide. Now here are in constant, I can't read what year it is, constant 1980-something dollars as a function of fiscal year, 1982, thanks. And the total NASA budget is here in vivid puce, or whatever this is. And the OSSA, Office of Space Science and Applications budget, seen here in orange, multiplied by a factor of 10. So we can do the comparison. This is the Viking bump. And notice how closely the space science curve tracks the total NASA funding curve. So I think a realistic case can be made that the grand exploratory missions go up when the total NASA budget goes up, and down when the total NASA budget goes down, or put another way, that a grand long-term objective that involves exploration is the umbrella or aegis under which these other missions can be accomplished. Can I have the lights, please? Overhead lights, I mean. Thank you. So now NASA is in a rather different circumstance. It has just emerged from the Challenger disaster. I think it is not unfair to say that at least significant segments of NASA have been in a discouraged mood, distracted, uncoordinated, in some cases incoherent. The American space program has been on hold. The great exploratory ventures out into the universe have virtually ceased, and it is a very important question to ask what could be done to resuscitate NASA. NASA has not had a coherent goal since the end of the Apollo program, and it certainly has not had a long-term goal deriving from a coherent statement of presidential interest since the end of the Apollo program. And therefore NASA has been left to design its own justification. And when any bureaucracy is left to do that, it does what all bureaucracies do. It attempts to preserve the jobs of everybody who's employed at that particular moment, and you get a very interesting pastiche of unrelated programs. I would like now to address the issue of what the American space program should do. What should a coherent long-term goal embracing presidential interest be about? I think I should say just a couple of words on SDI. If I don't, you will see a glaring hole in my presentation. Needless to say, what I am about to say about SDI, as the rest of my talk represents only my own views, does not represent George Washington University or the Planetary Society or any other organization. I think the original population defense formulation of SDI is a tragic, ruinously expensive mistake, and one, if actually converted into hardware, would significantly decrease the national security of the United States. I'm prepared to defend that. I've done it on a number of occasions, debated in 3 public forums with General Abramson. I recognize that's not the function of this discussion, but just wanted you to know where I stood. Let's now return to the civilian space program and talk about what the overarching kind of goals should be. I see 2 principal such goals. They are neatly compatible. And they have a number of other connections as well. The first one I want to talk about is something that's been very nicely described as mission to planet Earth. That is, a study of the Earth from space from the same global perspective as these other planetary missions have done for other planets. And this has a great head of steam in our discussions in the last 2 days. While there were differences of opinion on a lot of issues, I didn't hear a single negative remark about that kind of goal for NASA, and there's a very good reason for it, and that is that as the human population has grown, as our technological capabilities have also grown, we have amazingly come to the point where we are able to make significant changes in the physical environment of our planet. I mean, globally, worldwide, by accident. There are a number of cases of these, and let me just briefly mention 3 of them. The increasing greenhouse effect, the depletion of the ozone layer, and nuclear winter. I'll just say a word about each of them. First of all, because the first two can be addressed in a very important way by such a mission to planet Earth. And secondly, because I believe there's a very neat connection between the discovery of those global dangers and the exploration of other planets. I want to put in the plug for that connection. So I'd like to now show a few of the slides. I borrowed these from Professor Dutton. I'd like to thank him for lending me those slides. First has to do with the greenhouse effect. Wait, let me say something generally first. I'm sorry to be so hard on whoever's controlling the lights. Could I have the lights back on again? If you imagine the Earth sitting at its distance from the Sun, with the present cloud cover, therefore reflectivity or albedo, you can calculate what the surface temperature ought to be. So much sunlight hits the Earth, it's a certain distance from the Sun, you know what the solar constant is, you know what fraction is absorbed. You can then calculate, it's done in Astronomy 101 all over the world, what the surface temperature ought to be. When you do that, the surface temperature calculates out to be 30 centigrade degrees colder than it actually is. And in fact, the calculation, if it were true, would speak of an Earth in which the surface temperature is far below the freezing point, and we'd all be dead. What's wrong with the calculation? What's wrong with the calculation is the greenhouse effect. The calculation neglects the fact that there is a blanket of air, infrared absorbing but transparent in the visible part of the spectrum, which surrounds our planet. And that infrared absorbing blanket permits the visible light through to heat up the surface, but absorbs the sunlight, absorbs the infrared radiation as the surface tries to radiate back to space. That is called the greenhouse effect. In an inept analogy with what happens in a florist's greenhouse, which isn't this at all, and we owe our lives to the greenhouse effect. A little greenhouse effect is a good thing. On the other hand, I mentioned before that the planet Venus has a surface temperature of some 750 Kelvin, 900 Fahrenheit about, and that is due to a massive carbon dioxide greenhouse effect. Nobody, by the way, proposes that there were a bunch of beings on Venus who went too much into the automotive industry, and that's the reason. But Venus is a very important object lesson in case anybody thought, well, nothing to worry about greenhouse effects. There's a very good case. Now, if I may have the next slide, and thank you. So here is a set of observations made from 1958 to almost the present, a ground-based observing station in Hawaii. You can see the annual variation in carbon dioxide having to do with the seasonal taking up of CO2 by plants. But the net trend is very clear and a monotonic increase in the CO2 abundance. And the same is true, and even steeper, with the abundance of methane, another greenhouse gas. The increase in these molecules means that there is an increasing greenhouse effect, which ought to result in an increasing average global surface temperature. Next slide. Here we can see the increase in the world's population from 1850 to the present, and there's been an absolutely spectacular exponential growth in the Earth's population, and the carbon dioxide increase parallels the industrial growth of the Earth. Next slide. Here is a set of measurements of the global average surface temperature, and this comes about not because anybody was in Earth orbit examining the whole Earth, but by putting together with appropriate weighting the measurements from various ground stations, a much less reliable method. Nevertheless, there is a trend which seems to be quite clear, According to James Hansen of NASA's Goddard Institute of Space Sciences in New York, the decade of the 1980s has already had the three hottest years in the last 150, and if the trends continue, he says 1990 will be on global average the hottest year in the last 120,000 years. That's something worth paying attention to. Next slide is just a neat graphic reminder of the mechanism of the greenhouse effect, which I talked about before. The infrared active gases, they don't sit in a layer up there. They're distributed through the troposphere. Visible light through, they absorb infrared radiation, heat the surface of the Earth. So what? What's a few degrees increase in temperature? Nobody can do reliable prognostications of the local weather from this cause, but there are a number of models, both the general circulation models and analogies with paleoclimates in which the carbon dioxide abundance was higher. And while these models cannot be believed in regional detail, something like what they say is very probable. Some of the models, for example, predict a, well, all of them do, something like a 3 to 5 degrees centigrade temperature increase by the middle of the next century, which is enough in some models to convert the American Midwest into something approaching scrub desert. The melting of glacial and polar ice is raising sea level so that a few feet rise can be anticipated in this period of time, and if the trends continue sometime in the century after, we may have the collapse of the West Antarctic ice sheet and the inundation of every coastal city on the planet. This is serious stuff. Next slide is a schematic about the ozonosphere depletion. A bunch of chemists in the 1930s are given the job of designing a perfectly inert, safe material to act as a refrigerant in refrigerators and for other functions. They come up with them. It's given the DuPont brand name of Freons, specifically designed to be free. Nobody figured that their very inertness would save them from chemistry near the surface of the Earth, so that when they reach the ozone layer, they would interact with a highly chemically reactive ozone, begin depleting the ozone layer, increasing the flux of ultraviolet light through the ozone layer. Its thickness, if brought to standard temperature and pressure, is only a few millimeters, and an increase in ultraviolet light at the surface of the Earth is dangerous in many different respects, increasing skin cancer for whites only, by the way, but there's a fair number of whites on the planet, and but that's not nearly as serious as the effect of sublethal doses of highly sublethal doses of ultraviolet light compromising the immune system, and the propagating consequences of killing one-celled plants that are at the base of a vast food pyramid at the top of which sit we. Lights, please. This is another extremely serious environmental hazard produced by human activity that we have only recently discovered. Overhead lights, please. And then the third, which I just want to spend a moment on, is nuclear winter, the discovery 38 years after the invention of nuclear weapons, that the explosion of nuclear weapons over, and put it a different way, even a small nuclear war can, through the burning of cities, produce a global climatic catastrophe of considerably more than 10 degrees centigrade temperature decline over the northern hemisphere. And I should say that all the recent models of nuclear winter have converged on the same answer. Now, it would be foolish for us inhabitants of the earth, but also us Americans, to ignore these very clear signs that the global environment on which we depend is in danger. It's essential for us to understand the nature of the danger, to figure out what we can do to ameliorate or prevent, and beyond that, to try to seek out and diffuse those other environmental dangers that we so far have been too ignorant to detect. There must be others that we haven't figured out yet. And that's one of the places where the convergence between planetary exploration and preserving the Earth comes. Because take a look at the greenhouse problem. I've already said the value of Venus in convincing skeptics that there really is a greenhouse problem. But beyond that, I'd like to call attention to the training of some of the scientists who've played key roles in these discoveries. One of the most important models of the greenhouse warming is due to Jim Hansen and his colleagues at the Goddard Institute of Space Sciences in New York. I already alluded to some of their work. That's already a connection, but the connection goes much deeper. Where did Dr. Hansen develop his interest and expertise on greenhouse effects? His doctoral thesis was an attempt to disprove the greenhouse effect as the source of the high surface temperature of Venus. He cut his teeth on a planetary global greenhouse problem and then applied it to the Earth. Take the ozonosphere depletion problem. This was done by Roland and Molina at University of California, Irvine. By the way, it wasn't done by the Environmental Protection Agency protecting us. It wasn't done by the Department of Defense defending us. It was done by two ivory tower scientists at the University of California, Irvine, and is an important reminder of why the nation should spend money on basic research. Roland and Molina used a absolute reaction rate kinetics scheme to figure out what the result would be of the chlorofluorocarbons in the ozonosphere. To do that, you need to know reaction rate constants. They have to be measured in various laboratories. If you look at those reaction rates, you discover that a significant number of the reaction rates used were derived from laboratory work supported by NASA. Why did NASA support it? Not because of interest in the Earth, but because there are halogen compounds in the atmosphere of Venus. So by this surprising indirect route, NASA played an important role in the discovery of the danger to the Earth's ozonosphere. The second group that confirmed the Roland Molina findings was a group under Mike McElroy at Harvard. They had a whole computer program set up ready to go so they could check Roland Molina as soon as they heard of it. Why did they have that program all set up and ready to go? Because they were working on the photochemistry of the atmosphere of Venus. It's relevant to the Earth to study Venus. By the way, Mars, which has no ozone, or no significant ozone, permits the full flux of ultraviolet light to reach the surface of the planet, and this may very well have something to do with the fact that in the surface layers to which we have so far dug, there is not only not a hint of life, but you can't find a single organic molecule. That region is being fried by ultraviolet light. And then the final case, nuclear winter, there were 5 of us who did the first calculations of the nature and magnitude of this consequence of nuclear war. 3 of us were full-time planetary scientists. 2 of us spent some fraction of our careers in planetary science. The computer used was a NASA computer. It was a very clear connection, and the connections go much further. Our first interest in what the global climatic consequences of putting a haze of fine particles up in the atmosphere would be came from work connected with the Mariner 9 mission to Mars. So, there are two things that come out of these remarks. The first, that NASA, but the government in general, needs to devote a very serious program of Earth satellites to monitoring the global environment, looking for items that change, and prescribing solutions. And secondly, that planetary exploration, I'm talking robotic vehicles, needs to be supported for this reason alone. If we didn't have an ounce of adventuresome spirit in us, didn't care about the adventure of exploration, for purely practical, everyday reasons, it makes sense to explore the planets. Now, I want to go to my last topic, which is the other aspect of what I believe the U.S. space program ought to focus on. There is nothing in robotic exploration of the planets, in great astronomical observatories in Earth orbit, in instruments in Earth orbit monitoring the health of our global environment, that requires people. It is much more cost effective and in some cases much more reliable to use robots than humans. Nevertheless, NASA is strongly oriented towards manned and womaned spaceflight, and as all ongoing bureaucracies, it probably needs a reason to continue flying people. I don't think that in itself is justification for doing it, but I think there is a reason, and I think it's a very powerful reason. It is the complement, the obverse of the Apollo program. The United States and the Soviet Union have now fully demonstrated to everybody on Earth that they are capable of obliterating each other and most of the human species as well. No further demonstration is needed. No politically driven space race makes any more sense, especially in this recent, astonishing Gorbachevian period. What is needed, though, is for the two nations that have booby-trapped the planet with nearly 60,000 nuclear weapons to demonstrate that on a long-term basis they can work together in high technology for the benefit of the human species. There are many ways in which they ought to do that, but the one that has a practical basis, has precedent in the Apollo-Soyuz mission, and has the very real advantage that the head of the Soviet Union has repeatedly called for it, is joint U.S.-Soviet manned and womaned exploration of Mars. And that's what I would like to spend my remaining few minutes on. I believe that a long-term goal of this sort, in which the two countries at first gingerly, with proper concern for technology transfer and the possible unreliability of the other partner, test out a new relationship in all the preparatory space science needed for sending humans to Mars. I think as confidence grows, the effect would be very significant. There is in the psychological literature a range of studies showing that if you, well, let me mention the classic experiment which was done in the 1940s by Muzaffar Sharif, in which healthy, well-adjusted adolescent and sub-adolescent boys were brought to a summer camp, divided into two groups, the Eagles and the Rattlers, I think they decided to call themselves. Everything was very friendly. They then started playing competitive games, two sides against each other. And there then got to be lots of dissension. I'd like to mention, quote just a couple of sentences from there. The tournament started in a spirit of good sportsmanship, but as it progressed, good feelings soon evaporated. The members of each group began to call their rivals stinkers, sneaks, cheaters. They refused to do anything more, have anything more to do with individuals in the opposing group. Secret hordes of green apples were piled up. The rattlers seized the Eagles' flag. One group deposed its leader because he was insufficiently aggressive. And attempts by the counselors to reconcile were unavailing. Then there was introduced a set of common problems which could only be solved collectively. Fixing the water main and others less significant. In the course of dealing with common problems that affected both groups, the hostilities vanished, and to quote the summary, the possibilities for achieving harmony are greatly enhanced when groups are brought together to work towards common ends. Then favorable information about a disliked group is seen in a new light, and leaders are in a position to take bolder steps towards cooperation. The same point was made by Sigmund Freud in his famous 1939 correspondence with Albert Einstein, published in the book called Why War. Freud says the following: anything that creates emotional ties between human beings must inevitably counteract war. Everything that leads to important shared action creates such common feelings. On them the structure of human society, in good measure, rests. Under the aegis of a declared Mars goal, a great deal would start falling into place in NASA. Manned spaceflight, long-duration spaceflight, space station, big boosters, staging in Earth orbit, solar physics, because you have to worry about solar flares on the way to Mars, and of course robotic exploration of the planets. Without such a superordinate goal, I maintain that a lot of that does not make much sense and is likely to be poorly supported in a time when there are so many other urgent claims on the available federal budget. Now, the Soviet Union is in rather good shape for sending people to Mars eventually. They hold by a large factor the long-duration microgravity record, long-duration spaceflight. It's likely to be a year with the current Mir crew. They have the Energia booster, which is Apollo Saturn V class. The United States foolishly threw it away, our own Saturn Vs. They have a very ambitious Mars robotic program, and beyond that they have the repeated clear endorsement by President Gorbachev in favor of a joint U.S.-Soviet human mission to Mars. I think it's rather clear that eventually the Soviets will go with us or without us. I also think it's clear that if the United States does not wish to join the Soviets, and as I'll say in a moment, if it does as well, that other nations, Europe, Japan, perhaps China, perhaps India, will join them. It's not a question of if we don't join, it won't happen. It's a question of it's going to happen. The human species is on the time scale of some decades going to go to Mars, and is the United States going to be involved? I maintain that there is no good justification for us spending badly needed funds on a human mission to Mars other than the political goal of international cooperation with specific attention to improving relations on a long-term basis with the Soviet Union. The various Democratic candidates made strong appeals in this direction, including, to the surprise of some, Jesse Jackson. It is in resounding language in the Republican Party platform. I'll quote the sentence: "We must commit to a manned flight to Mars around the year 2000 and to continue exploration of the moon." I know that most party platforms with a quarter will get you a cup of coffee, so I don't know what weight to give this, but I am told that this is intended seriously by the Republican Party. In addition, there are a number of other congressional senses of the Congress, bills that will be reintroduced in the next 101st session. There is the Mars Declaration of the Planetary Society, in which a remarkably ecumenical group of American leaders has endorsed such a goal, and there are a number of opinion polls which show that the bulk of the American people would be in favor of such a goal. It is, therefore, I claim, politically feasible, and it would do wonders for NASA. I think it is essential that this set of missions, if it comes to pass, be done not just bilaterally between the United States and the Soviet Union, but multilaterally, involving many other nations who have a great deal to contribute financially in terms of intellectual, scientific ability, engineering, and also to play a nice moderating role between the two superpowers. It would clearly be step by step. We would be doing experiments in long-duration spaceflight, in shielding, in staging, in robotic exploration, as I said before, testing each other out. Finally, let me say just a final word about Mars. I had intended to show some slides of Mars, but I've been yammering on too long, so Mars is a world of wonders. It is vastly more interesting than the moon, I claim, both in scientific terms and in public wisdom. It is a dynamic planet with an atmosphere, with seasonally changing ice caps, with the possibility, by no means certain, of past or present life, with signs of past climatic change, which is something we ought to understand. We who are pushing and pulling with our own environment ought to understand how Mars once had running water, abundant rivers, warmer temperatures, and today is in a deeper ice age environment. The surface area of Mars equals the land area of the Earth. It will occupy us for a long time. Mars delivers. It is not a boring place. There are enigmatic landforms. There are great volcanic eminences, one of them 3 times the height of Mount Everest, a remarkable polar terrain. There's lots of terrific science: geology, meteorology, seismometry, possibly biology. Keep scientists happy. But I stress, you could do all of that with robots. The reason for sending people there has to be political. So in my mind's eye, I see sometime in the next century, one or more great interplanetary transfer vehicles constructed in Earth orbit daily, if we want it, before the eyes of the world's television cameras on the nightly news every night. Cooperative construction by many nations, the completion of the spacecraft, the boarding of the crews, the goodbye to Earth, the long, many-month journey to Mars, injection into Mars orbit, landing site verification, deboosting from Mars orbit, setting down on the surface of Mars, the first landing on another planet by the human species. There are some who are worried about which nation will first step on the surface of Mars. My solution is you bind the ankles together of the American and Soviet commanders and have them hop out on the 0.38 gravity world. They'll gently settle down, and nobody will be first. Imagine now what I think would be hard to beat in capturing the imagination of people all over the world: a roving vehicle with Americans and Soviets and others in it, wandering across the Martian landscape, going to the exotic terrains that we could never land in Viking, wandering down one of those ancient river valleys, looking for stratification in the banks, looking for the geological record, trying to understand the changes in the environment of that planet, and all of that on the nightly news every night. And then finally the long journey back to Earth. I maintain that that could put space exploration, space activities on the front burner all over the world for a long period of time in the political context of binding up the wounds of the Earth. I think it would be a wonderful thing if the planet named after the god of war could help to increase the peacefulness of the inhabitants of our small and vulnerable world. Thank you very much.
Thank you very much, Carl. We do have about 5 or 10 minutes for questions, if there are any. So there are microphones in the aisles if people have some questions. Are there questions? Joe?
This is a soft question. In addition to supporting international cooperation at the level of going to Mars with the Soviets, are there other lesser projects, such as the International Space University and other initiatives that you would support that might build some bridges to the Soviet Union? And another possibility is some small missions, communication mission for health and medicine that's been discussed with the Soviets. Do you see some possibilities at that level if we don't get the big bucks?
Absolutely, and search and rescue satellites in Earth orbit, and activities across the board. I think it is to the interest of both nations, within reasonable technology transfer constraints, to do as much of that as possible. Soviets have good scientists in a lot of areas. In a lot of areas they have significant space technology experience. They have large budgets, and it's very much in the interest of everybody on this planet for the United States and the Soviet Union to find a range of important joint activities to do.
Dr. Sagan, you didn't mention in your description of NASA activities over the last 2.5 decades anywhere what effect the space shuttle and the research into that has had on it, and I know it's a fairly controversial issue. Could you just mention what your opinion is of that effect and how the space shuttle may be utilized or should possibly not be utilized in further exploration and development of space?
Thank you. It's as you recognize, a long and painful issue. I think the United States made a extremely serious error, the civilian program, more foolish than the military program, in putting all its launch eggs in the single shuttle basket. It means every time you want to launch something, you have to send people up, not just putting them at risk, but making the whole launch business much more expensive. It makes competition and waiting in line for the next available shuttle when, if there were non-reusable launch vehicle fleets that NASA had been using, that wouldn't be the case. And of course, there's the Challenger tragedy. I think the shuttle is an example of a capability without a mission, without a real, unique mission that could not be done otherwise. I mean, the usual justifications are, yes, it's needed in order to put people up into space, but why do you want to put people up into space? Well, we want to study human physiology in Earth orbit. But why do you want to study human physiology in Earth orbit? So we can have longer duration spaceflight by humans. Why do you want to have longer duration spaceflight by humans? And we never get a coherent answer. The kind of answers that one can hear are humans have capabilities that machines don't have. And so when there's an unexpected problem, the humans can solve it and the robots can't. And then there'll be some pointing to, let's say, the Skylab sunscreen, which required an astronaut and a screwdriver to first order. But if anything like the amount of money spent on humans in orbit could be spent on artificial intelligence and a new generation of robots, you could have screwdriver-wielding robots in Earth orbit, or teleoperator-controlled machinery in which the human operator is on the ground and the robot is in orbit, to do that sort of thing. I think sending people up into space started out as political. The political justification then withered, but it remained a constituency that was very powerful in both the United States and the Soviet Union, with considerable inertia of its own. As far as I can see, the only justification for the cost, both in money and in the danger to human lives, of people in space has to be political, or, if you wish to think of it in those terms, historical. But if that's going to really work, we have to understand precisely what is the goal of those humans in space. And I maintain that a goal like the Mars Initiative makes sense out of that otherwise redundant capability. Yes, please.
Dr. Sagan, the idea of a manned mission to Mars is a very exciting one. It's one that captures our imagination. But if such a project were undertaken and successfully brought to conclusion, how would we avoid the trap we found ourselves in when we had the whole world excited about going to the moon? Once we got there and we gathered a few samples and we looked around, public interest fades. It's going to be tremendously expensive, and what's more, we could get missions to the moon pretty quickly and back. We're talking about a substantial period of time getting to Mars and back. How do we sustain the energy and the funding and the resources for something like that?
Thank you. It's a very important question, and I should have gotten to it in my talk. I think the fact that it takes longer to develop the technology and infrastructure to go to Mars is an advantage if you believe in the argument that what we want is a long-term common goal for many nations. If it's too easy, if it's too near, if it's too quick, then we run into the problem that you said. If it's 15 to 25 years away, then I think it has the right reach to prod this continuing collaborative multinational enterprise. It is sometimes said, and I should say there are proponents of going to the moon and not to Mars on those grounds. There are proponents to going to the moon on the grounds that the Russians are going to go to Mars, so we better go somewhere else, which makes no sense whatever in my mind. You could just as well argue the Russians are going into space, so we should stay at home. It is sometimes argued that, well, the moon is a good stepping stone to Mars. It's a good place to practice out Mars roving capability or staging or other things you want to do on Mars, but I point out that low Earth orbit and the surface of the Earth are much better and much safer places to check that out. It's also sometimes objected that the Mars goal doesn't work because it's going to be a stunt, as you sort of suggested. We'll go there once or twice and then it'll end, like Apollo. But I point out that the reason the Apollo program ended is because the United States demonstrated its extremely formidable rocket capability. In fact, the Saturn V booster is far in excess of the military boosters that can reliably deliver nuclear weapons halfway around the world. So you reach a point where you've demonstrated you can annihilate the other nation, and then you don't have to demonstrate that anymore. But you do not reach a point where you've demonstrated that you can cooperate, so you don't have to cooperate anymore. And so I maintain that in terms of political goal, Mars has continuance, which Apollo did not have. Beyond that, Mars is so vastly more interesting in a scientific and adventuresome and exploratory sense than the Moon that I think we land on Mars once or twice and we will find so many fascinating things that Mars will help us to continue.
I want to take one more.
Okay.
I think perhaps, Dr. Sagan, you're being too modest, because even in your proposals, I think a political objective is only one objective. But as we think about what we're doing to the planet here, and perhaps in the long run irretrievably or irreversibly, we really have to find other places to live for the human species, and Mars probably isn't very habitable, at least not from a practical point of view, nor is any place else in the solar system. So we have to find some other solar systems and go there. Now, that's a much longer objective, and it probably is an objective of hundreds of years rather than decades. Conceivably, it's unachievable, although I rather doubt it. My own feeling is that it is achievable. And that's a long-term objective for the whole species. Right? You could call it political or social or whatever. But it is a coordinated and cogent long-term objective, and Mars is conspicuously the next step for it.
Thank you. Permit me to disagree a little bit. The Earth is not a disposable planet. It's not if once we mess it up, then we'll go somewhere else. There is, as you properly point out, no other habitat for the human species in the solar system. The excess of births over deaths on the Earth every day is about 200,000. We are not within hailing distance of the lift capability to put 200,000 people every day, even in low Earth orbit, much less to Mars or some other place. Spaceflight is not the answer to solving the demographic problem, and it's not the answer to solving the environmental problem. If I thought things were that critical, I would say we should simply spend our money in making the Earth a better place. And I think that's a good idea in any case. But as I've tried to indicate, I think there are ways in which going to Mars makes the Earth a better place in terms of the relationships of the various quarrelsome nation states. And also observing the Earth from Earth orbit permits us to gain a perspective and understanding of our deteriorating environment, which is essential so we all can survive and prosper on the planet. Thank you.
Thank you, Carl.
Thank you.
Let me ask our panelists to move forward as I introduce their chairman. The idea now is to spend the remaining time both communicating to you in short form the kind of things we've been talking about in our smaller workshop, and then hopefully engage you in some give and take with the members of the panel on the insights and conclusions that we didn't reach that you think should be part of a deliberation. So can I ask all the panel to come forward as I do. This is doing things in real time, and this is the sort of thing those of you that are in the space business will recognize as draconic. I have not warned any of these people, but we have no overhead projector, and so you can't use view graphs. And we're not set up just the way the panel is to show slides because you're in front of the screen. So you got to depend on rhetoric. There's enough rhetoric in these 6 gentlemen, I think, to suffice, though. The chairman of the panel, Bruce Murray, professor of planetary sciences at the California Institute of Technology and vice president of the Planetary Society. From 1976 to 1982, Bruce was director of the Jet Propulsion Laboratory. Before that, an active participant, before, during, and since an active participant in planetary exploration. Dr. Murray, floor is yours.
Thank you, John, and it's a good feeling to be trying to focus on the issue of international cooperation in space, and to do so in Washington, D.C., which plays a central role, although not necessarily the dominant role in that regard. And to focus, and the title of this panel is on the prospects for international cooperation. The point, we spent 2 days talking about different facets of this in a group that had both international and U.S. representatives. We have here a collection of people who are going to give some little snapshots of parts of that discussion and perhaps give the flavor of it and discuss it in a way, and we'll have some time for questions afterwards. What I will do as an introduction to this is, in my own way, try to summarize what I thought were the key issues that were sort of cross-cutting. Not saying so-and-so talked about this problem or that, but rather what seemed to be generic, what was kind of flowing out of it. And aiming it at an audience concerned with international cooperation, or at least international relationships, and policy issues. That's been the focus. This is not, despite Carl's enthusiasm and mine and most of us for space in its own right, the thing that brings us together is space as a part of an international set of relationships. And so that's really the focus here. Certainly a key part from the U.S. point of view of the civil program and NASA is the fact that NASA started out as an instrument of national policy. The Apollo program, as Carl described, and we all know, was a key element in U.S.-Soviet competition that period of time, and most of us feel a brilliant response to a set of circumstances that presented themselves. When that job was completed in 1972, no subsequent national priority or objectives were established for NASA. And so what's evolved in that period of time is an agency and a set of enthusiasts and a set of budget support and so forth in the Congress and elsewhere that has diverse goals without any stated objective by the United States government as to what it's supposed to do. Lou Allen made a comment in our meeting which I thought was very, very much the point. He says, NASA is not nearly as valuable to the government as it used to be. And that really underlies a lot of the bureaucratic and administrative problems that emerge. Challenger just exacerbated these. So that's a problem that's got to be dealt with, or will have mediocre outcomes. The second circumstance is, especially with the Gorbachev change, which is not only opening up and novel, but a choosing space activity as an instrument of Soviet foreign policy, and clearly with the establishing U.S.-Soviet collaboration as an objective in its own right, and picking up Western Europe by default, at least from my point of view, we are not positioned well to respond to that. We don't have policy guidelines, and they're fabricated sort of on a case-by-case basis, so the U.S. responds very sluggishly and slowly, and the Soviets have, in an adversary sense, the initiative and maintain it. So that we have to decide and do something about how do we cope. There's a new thing there, and whatever we decide, independent of what the value judgments about how we ought to do it, we ought to do it. There isn't a policy apparatus. There's sort of an incremental decision-making process which is sluggish and cumbersome and makes us look, from the U.S. point of view, a bit foolish, frankly, in the international scene. We don't seem to know where we're headed. An exasperation is that this creates a tension between the traditional relationships we've had with our Western European allies and we were developing with Japan and the Soviets. And again, we're not real clear at a practical level how we cope with that. Have we got a new set of friends over there, or are these still adversaries in a different way? How do we do a Mars mission, how does Western Europe fit in? Is that part of them or not? So, and the people trying to do this do not have policy guidelines or even attitudes in the structure here to help make those decisions. And so again, we're not doing a very good job. That, I think, is factual. What we should do is a matter of opinion. Third, it cuts a little thing, is the role of the moon is a little, is there an international role for the moon or not? Is it the Antarctic explanation or not? A fourth issue that we spent a lot of time on, and Carl's touched on it too, is I think everybody agrees this mission to planet Earth, the use of space as well as other national assets to understand the changes in the Earth's environment and lead into policy attitudes of what to do about it. That's great. We want to do it. There's probably money for that, and even in restricted budgets. The problem, again, is that we're not organized properly in that case. There is no agency that has that job. There are agencies that have pieces of it. There's certainly in the past has not been a good mechanism for them to work together. And even more difficultly, this is intrinsically an international job. It doesn't do any good simply to observe the Earth from space if one can't get surface and atmospheric ground truth, and that in turn forces you to deal with other countries. Even if we didn't want to on political grounds, on technical grounds we would have to. There is certainly no easy mechanism for that. So we got two structural weaknesses in our structure to deal with this. And then finally, looking further ahead, there are some of the speakers gave the common view now that both Europe and Japan's economies are growing so large that in the world that we're going into, we're not going to be the dominant player. We're going to be a major player, but not the dominant. We have to learn how to do that. But more importantly, we have to learn how to persuade the Japanese and the Europeans to make larger resource contributions to these global projects. And that's a leadership job by us. It's not something we can do ourselves. And again, that's a longer range goal. It's an immediate task, but it's something we need to be thinking about for the future. Well, that was my list of cross-cutting issues. Let me introduce the panel and then turn this over to our first speaker, at the end of which we'll permit some questions from the floor, depending on how our time is running. I'll just go from left to right. Dr. Harlan Smith, who's director of the McDonnell Observatory, cooperated with Dr. Hans Mark, who's the chancellor of the University of Texas and a former deputy head of NASA and Secretary of the Air Force, who talked about the moon as a policy objective for the United States, man-moon missions. Roger Bonnet is the director of scientific programs for the European Space Agency, has been very active in trying to get international collaboration, both at Comet Halley and other things, and has played a very important role emphasizing the role of Europe, as well as the rest of the world, in this bilateral changing into multilateral space environment that we're living in. Important, and we appreciate very much his efforts in coming here. The next person, Dr. John Dutton, who is the Dean of Earth and Mineral Sciences at Pennsylvania State University, is an advocate for mission to planet Earth. He doesn't really have to advocate, everybody's kind of agreed, and but he did a good job of doing that, and he will be our first speaker when we start talking. Dr. John McLucas is currently the chairman of the National Advisory Council, has a former secretary of the Air Force, a former key person at ComSat Corporation, has a very broad experience in all elements of space activities, and is been a strong advocate for the international space activities. And then finally, from Canada, the Ministry of State for Science and Technology, Dr. Evans represents another country. Roger represents an aggregation of countries, namely Western Europe and ESA. Evans represents a country that has worked both with the United States and with Canada and, and with Europe, and of course is involved in our shuttle and space station programs as a major player. So that I think that's a valuable perspective in its own right. We're going to then start out with Dr. Dutton on the whatever he wants to say.
The priorities are set today, in this instance, not by the urgency of planet Earth, but by the urgency of my flying schedule. But it gives me an opportunity to say a few things about Earth science, global change. You might reflect in your own education whether or not anybody talked to you about the future of planet Earth. We've talked a lot about the past. It's a traditional part of education, secondary school, high school, in college curricula. But it's not until the last few years that we have started to be seriously concerned about the future of this planet. And I think it's not that the future is in doubt. The planet certainly has a future. The point is that it's going to be different. The world is changing. It's changing before our very eyes. And most importantly, this planet is evolving toward conditions never before experienced in human history. It's moving toward this new, unfamiliar, and perhaps inhospitable state because of us, as a result of human activities. The changes are significant. They're occurring today. Dr. Sagan did a very nice job of explaining to you the elements of the global warming that's coming from greenhouse phenomenon, carbon dioxide, largely a product of the use of fossil fuels, and the problems with the ozone layer. I see a lot of you out there are experiencing the ozone problem. You're all hiding from the ultraviolet light. So what do we do? Well, from a scientific standpoint, first of all, we document the extent of global change. We determine the rate at which it's occurring. And we determine what the local manifestations of global change are. This requires a commitment to observation, a commitment to maintaining records, a commitment to processing those records. First of all, it's a commitment to using the data that is available today. We have a great deal of information about the Earth, but in our wisdom, or perhaps our bureaucratic inefficiency, we have tended to place most of that data in write-only memories. We could use it. Second of all, we need to observe the state of the Earth, the evolution. We need to study the interaction between the atmosphere, the oceans, the biosphere, and the ice regimes of the Earth. And a good way to do that is with what's been called Mission to Planet Earth. Mission to Planet Earth involves 4 or more polar orbiting platforms. Present plans are for 2 of those to be built by the United States, 1 by the European Space Agency, 1 by Japan. There's no reason that the Soviet Union, or for that matter other countries, could not contribute polar orbiting satellites to take the detailed snapshot of the Earth that we need. The other part of Mission to Planet, or another part of the Mission to Planet Earth, would be geosynchronous satellites, the kind that produce the weather pictures that Dr. Sagan mentioned. They're in orbit over the equator. They are looking constantly at the Earth. Finally, there are a number of research missions designed to measure a variety of things on the Earth. We have a stream of them in the United States. The European Space Agency has some in mind. Japan is planning some. Some of those will be cooperative. We need to continue with them. Given this database, we need to create computer models of the evolution of the planet, which are similar in spirit to the computer models that are used today to make weather forecasts that are often remarkably accurate at 4 to 5 days in the future. With such models, we can attempt to predict what is going to happen to the statistical state of the Earth some decades, perhaps centuries ahead. And with those predictions, we can assess the various alternatives in energy use and energy sources that we might be interested in trying. This clearly is an international endeavor. Mission to Planet Earth, you could say, is a mission with a crew of some 4 billion people. It's a global problem. It's a global study, and it requires a global solution. Scientists the world over are concerned about the Earth, the atmosphere, the ocean, the biology, and the ice. We need all of them, and we need their talents to bring this to successful to make successful progress. These scientists are cooperating now in a variety of studies. The World Climate Research Program, the International Geosphere Biosphere Program, and of course they set precedent for much of this with the International Geophysical Year some 30 years ago. They're talking about cooperating with the International Space Year in 1992. And finally, these space programs do involve all of the Earth, and there's no reason that they shouldn't involve and that we shouldn't take advantage of all of the spacefaring nations. And finally, and maybe it's not the most important reason at all, is that it's going to be expensive enough that we should share costs. Well, nothing is as powerful as an idea whose time has come. Global change is here. The need for the peoples of the earth to respond to it is upon us. We need to understand it. We need to predict it. And we may need to change our own behavior. And I think all of this is indeed an idea whose time has come. Thank you, Mr. Chairman.
Next speaker will be Harlan Smith, and picking up on, I guess, the moon.
Dr. Mark regrets that he can't be with us today. He's over at the Pentagon, in fact, and I feel a bit like the boy replacing the 900-pound gorilla, because not only has he had the jobs that were mentioned of being Secretary of the Air Force and Associate Administrator of NASA, but he's also Chancellor of my university. But anyway, Hans and I see more or less eye to eye on these issues, and in fact, I've had probably a good many more years to think about the particular one I'm going to stress today, so maybe it isn't totally inappropriate that I have this chance to be with you. Carl has asked, and several have asked already in the short time we've been with you, why the moon? I think there's a completely different class of answer that Carl did not touch on, that one of the questioners did. And it goes something like this. There are two possible, radically different scenarios for the human race. One is to stay on the earth as long as the human race shall last. Now that's a possible scenario. I think it's a pre-Copernican one in the sense that, there was a time when the earth was the only material body in the universe. But I really believe that that, in fact, is not the plausible or the probable scenario, assuming civilization lasts. In addition to robotic exploration, I quite agree with Carl, that's the way to do most of the exploration. In addition to that, I think there's no slightest question that the human race is going to migrate out into space. Now, the time scale is not simple. The costs are not small. There will be loss of life. But I mean, what in human endeavors in history have not involved high cost not only in expenses, but in human life? Not that I advocate that, but I think that the human race is a pioneering species which is on its way. Ultimately, perhaps the stars, although that's more difficult than any but astronomers know, and that's many, many, many centuries downstream, should it happen at all. But to the rest of the solar system, especially the inner part, to some degree, an increasing degree as time goes on, I am very confident that's the case. Carl's at liberty to disagree, others may, but I'm stating my basic position. Okay, if the human race is moving out to space, how does one do it? The first step is to be able to get into orbit. Well, we learned how to do that, and then as Carl pointed out, we destroyed it. We actually wrecked the machinery, broke up the machinery that built the Saturn rockets, I think in 1974. It's an astonishing thing. But anyway, the Russians have it, and we are recovering it. So we have ways of getting into space. And even the shuttle, bad as it is in some ways, is not entirely a wrong-headed thing in my estimation. It's the first attempt to build a vehicle that can fly into orbit and fly back. Now, it's a primitive beginning. It's sort of not even a Ford tri-motor, but you have to start somewhere. And back in the 20s and the teens, we didn't have Boeing 747s either. And the shuttle, I think, is an evolutionary development that I personally do not think the country need to regret, except that at the same time we threw away our auxiliary launch capability as well, which was the great mistake. All right, so we start out being able to get into orbit. What do we do next? We build a space station. Most of you know the Russians already have a very competent space station, and we're marching along behind. We will probably have one in 96 or 7. Then, where do you go next? Now, here is the crux of the question. Do we then decide that we shall make the leap to Mars, just like that, or shall we go next to the moon? I contend we should go to the moon next. Not that I disagree that Mars should be a goal immediately beyond that. I absolutely firmly believe Mars should be the subsequent goal, and it in turn, not only for its exciting science and history, but also as a further springboard for the human race ultimately to move out and develop resources of the solar system. I mentioned resources of the solar system. One very brief detour here. What are those resources? Fundamentally, there are three. There's effectively an infinite amount of energy there in the form of solar energy to be tapped in the free space environment. And there's more energy than I can describe. I've sometimes spent 20 or 30 minutes trying to get that one concept across to a class. The indescribable amount of energy that is pouring out from the sun, large amounts of which ultimately can be trapped and made use of. Energy is the ability to do work. If you can do the work, you can do almost anything else. There's virtually an infinite amount of material out there. Now, it's not always in easy forms to work with, but with energy you can work with it. And finally, there's an awful lot of space. And I think given those three things, energy, materials, and space, the development of the solar system will in fact continue, and the reason for having people out there supplemented, in fact heavily using robots, is precisely the development of space. Now, the moon is the next place to go, I contend, on that route. But is it only for future development? In fact, this point of development scarcely appeared at all in our discussions in the last 2 days. And it's, you might say, my idiosyncratic point of view, although one I believe in quite firmly. But I think also there are reasons intrinsic why we should go to the moon, which are in several categories that Dr. Mark spoke of earlier today, in fact. These include the fact that we really can learn a lot. It's not absolutely essential to use the moon as a way station to Mars, but I contend that in so doing, we will make the Martian expeditions a lot more feasible, successful, and probably not even delay them an enormous amount beyond trying to do it in one fell swoop. Also, if we wish to set up really continuous shuttling to Mars, which I think is the only thing that makes real sense, because you have to remember that if one talks of human exploration of Mars, these poor astronauts or Martianauts are going to land somewhere on Mars. Their job is to survive for a few months before they get in the spacecraft and get back. They're not going to be able to traverse hundreds or thousands of miles and explore all the wildly exotic terrain. They'll examine a local area, which already may be fairly well known, or the site wouldn't even been picked by robots for that landing. Ultimately, when human beings can truly, deeply explore Mars, it's going to be an immensely exciting place. But in the beginning, for a long time to come, it's going to be a spot check, and the science will be limited. But the point is, we'll do more Martian work. We'll have an infrastructure in place if we have the moon well developed, and if in particular, the moon, as seems now can surely be done, becomes the source of the primary fuel, oxygen, for the really large-scale interplanetary voyages of the future. Now, all of that's background. The foreground that I particularly come to it from, the point of view of an astronomer, is what can you do on the surface of the moon? The answer is science. A number of very interesting kinds of science we don't have time to go into. I'll mention just the one I'm especially driven by, astronomy. The moon is the place in the solar system from which to do most of the best astronomy of the future. Now, that's another long story. I've spent a whole hour at times talking this subject alone. No time to go into details. But briefly, the moon offers you an atmosphereless place which nevertheless is solid. You can put down very low-cost telescopes, large numbers of them. You operate them remotely from the Earth. If repair is needed, you have your little lunar base. People, in effect, wander out and make the repair. Immediate proximity to cryogens, power, repair, and so on. It turns out that astronomy from the moon should be a great deal less expensive if you don't require the astronomers to pay all the cost of setting up the lunar base. Now, that's quite an if, and it involves all these other things. But once the lunar base is going, astronomy should piggyback with great success with extraordinary developments, especially in terms of what we call interferometry, where we get not merely the present 1 or fraction of a second of arc resolution on the sky that we get from the ground, but 100th, 1,000th, even in time a millionth of a second of arc resolution on celestial objects. And telescopes of enormous size, great complexity, essentially free, low temperature conditions for thermal IR. One can go on with the virtues of the moon. It's a great place from which to do astronomy. Now, very finally, the moon also offers, as far as space is concerned, the leading place, I believe, for early international cooperation after we indeed get going on this absolutely essential mission to planet Earth. Because within reason, when we get the freighter lines going to the moon, and I do visualize them starting within 12 or 15 years, it will be possible for many nations, just as we do in Antarctica, to set up their own little base, but in collaboration with others. And I sincerely believe that we'll have an international observatory with a large number of astronomical instruments which are operated both individually by countries, much the way the European Southern Observatory has individual telescopes from Denmark or France or what have you, but all part of a complex and sharing with each other. Only this will be truly international, and we will cut our teeth there, and then we will make the trip to Mars successfully. Carl, I want to go too. All right.
Thank you for a very, I think, cogent and lucid presentation of the idea of the value of the moon. Roger, do you want to take over and bring us back to Earth? Western Europe, in fact?
Thank you, Boris. As the non-American participant in this workshop, together with other colleagues from Canada and from Germany and France, I would like to say that it was for us a great opportunity to participate in this workshop. And I would like to thank the Policy Institute and the Planetary Society for having invited us and participated in this debate. I was invited because I represented the European Space Agency, which is, as you may not know, but I say it again here, an agency which puts together the efforts in a coordinated way of 13 nations in Western Europe. And we have also Canada as an associate member. And as such, we cooperate with the United States and with Soviet Union also, but we also collaborate with other parts of the world, China and India. It is true also to say that there are other space agencies in Europe, in France, in Germany, in Italy, and in England. It would be dishonest not to say that very often, sometimes during this workshop, the Europeans and the non-Americans felt a little bit left aside in these discussions, which mostly focused on the dipole, Soviet Union, USA. And we had some delicate moments to find our place in this discussion. And in fact, it's true that it's not an easy matter, and it's true also, it's fair to say that dealing with a new partner who shows mood of openness, perestroika or glasnost are two words which are very popular these days, needs a learning period. And of course, this was a key element in our discussions. But it's true also to say that space exploration has ceased today to be the affairs of only a few countries or a few organizations, but is a worldwide activity and an essential motor of knowledge in science, but not only in science, also in politics and in international relationship. So the question is no longer today whether or with whom to cooperate, but rather how. And the example of Soviet Union was a good example during these discussions, because very few people did not know how to handle this situation. We also have to deal with making today lasting commitments in a world which is changing every day, if not every minute. The example again of Soviet Union is a clear example of that. 2 years ago, who would have guessed what happens today? And who knows what will happen in 2 years' time? So this evolution is an essential element to take into account when we deal with long-term commitments, which probably dictates that we have to work prudently, but not necessarily taking a negative approach to that. But USSR is not the only place where things are moving. 1992 will mark the 500th anniversary of the discovery of the America by the Europeans. But 1992 will be also a very important date in Europe. This will be the time when the borders between the largest number of nations in Western Europe will be opened, a real open market. And this is a changing element in the world scene. It has been said that it creates a new superpower. I hope it is the case. It will be at least a tripole. But we also see Japan coming up at the horizon. And this is also an essential element in the world scene. So these elements have to be taken into account when we deal with international cooperation on such big ventures as a mission to the moon, or even more, a mission to Mars. There are two ways to cooperate internationally. One which is simple and the most cost efficient probably, and also the most scientifically rewarding, but probably the less politically interesting, is the coordination of missions already existing in each nation or in each agencies, whereby you add a lot to the science you get out of these missions by putting them together in a coordinated way rather than taking the science of each individual one and adding them together individually. So as I said, this is a low-risk approach, scientifically rewarding, but not necessarily the best approach politically. The other one, which consists in defining a common goal and achieving this goal together, is, of course, the one that we are talking about when we discuss more the Mars mission or even the Moon mission. This is much more risky and needs new means of cooperation, new means of working, new methods. It's very difficult to accommodate this. For example, I remember in July this year, we had, thanks to the Planetary Society, and we organized with Planetary Society and ESA a workshop to assess how the Europeans could participate in the Mars mission. We found ourselves completely stuck in a discussion where the Europeans and the Americans on the one side said, well, you need to go into a phase A activity, and then you go into phase B and phase CD. And the Russians looked and opened their eyes, and they didn't understand what we were talking about. What is a phase A? What is phase B? What is phase CD? As they told us, we design our mission at the same time we think about it. And these two different approaches, long-term planning in a sense and a real-time activity on the other side, are sometimes not easy to reconcile. But if we are serious about going together on these big missions and tightly coordinating or cooperating, requires that we learn the methods of each others. We have been, as I said, able to cooperate on both sides, with the Americans and with the Soviets in Europe. With the Soviets, I would like to recall that we coordinated our missions to Halley's Comet 2 years ago, and that was a beautiful success thanks to the international cooperation. The Soviets leading the way to Comet Halley and showing exactly where the comet was, so that the Europeans, following a few days later, could target very precisely the nucleus of the comet and shoot at it at 500 kilometers of missing distance. This was also possible thanks to the crucial help of the Deep Space Network of NASA. But we also cooperate extensively with the Americans in Europe. We have many missions that have been done in cooperation. The Ulysses mission, this mission which goes above the plane of the orbit of the Earth and will fly above the poles of the Sun. We participate in the Hubble Space Telescope, certainly as minor partners, but our participation is crucial to the fate of the Space Telescope, since we supply one focal plane instrument, a crucial one, and also the power system of the Space Telescope. But we also coordinate and cooperate in the field of solar terrestrial science. And we also just recently accepted in our program a participation into a new mission which is being discussed at this time in the United States, a mission to explore the rings of Saturn and to land a probe on Titan. The Europeans would land this probe on the atmosphere of Titan and land it on the surface of Titan. Incidentally, the name of this probe is called Huygens, from the name of the European astronomer who more than 300 years ago discovered Titan through the lenses of his telescope. In this changing environment where we see this new power arriving, coordination is necessary. We cannot do that randomly. As I said, we have to learn and we have to find ways of knowing better our partners. In mission to planet Earth, I think myself that there is here a great potential and a great necessity to coordinate our efforts for the benefit of mankind. We are really, and Carl has shown us the danger of not controlling what we are presently doing on our environment. Space offers a unique way to have the global view in order to control better this environment. But here, how can we think of such a cooperation without the major industrialized countries, which are the main outputs of all these hazardous elements in the atmosphere, the CFCs or the carbon dioxide? Here, I see a great necessity to improve on the ability to exchange data, especially between Soviet Union and the rest of the world, where they have a lot of data and where they need the data from the West. So this dual link is absolutely essential and is missing, but it's a delicate matter because it needs to transfer data from that part of the world to this other part of the world, and you need the networks or the necessary element to do that. For the moon, I think it is another dimension there. We are going to a place which we know already. We have explored it. We have landed on it. We have put man on it. We have brought samples of this soil, and we know how rich it is in certain elements. So the moon's mission is more or less an exploitation mission. We need to exploit the moon, scientifically speaking. It's a very challenging place to put astronomers, or telescopes at least. It's also a place where you can find enormous richness in the soil. So it's more like an exploitation base that we should think of. On the Mars mission, here I think we are in the realm of exploration still. It's not because we have landed the two Vikings, and that was a beautiful mission, and that the Russians will land a series of robots in 1994, that we should say that we know the planet. We don't know the planet. We have to go to many places on this planet, which is a very fascinating one. And here again, it is impossible, given the resources involved, that this is not done in a coordinated way. I think that my own experience, our own experience in Europe to cooperate with Soviet Union has been to go prudently, but in a positive gradient. And I think we are certainly encouraged by the very positive attitude of the present Soviet leaders in this approach. And during the workshop we discussed, and I certainly did strongly endorse this concept of making a small step in this direction to study jointly, just study, not spending a big amount of money, not changing hardware, but just study a mission to Mars together with the Soviets, the Japanese, the Europeans, or whoever wants to join. We have to find this approach with the Europeans, cooperate on the space station with the Americans, the Japanese, and the Canadians. We also cooperate with the Soviets. We have to accommodate this dual activities, this dipole. And I think it is essential that we get together the five main space agencies, the five main space powers together to work in the future. I will stop here, but I would like to make a suggestion to Carl Sagan. He had a problem to identify who would be the first one to put his foot on the planet Mars. And he suggested that we should fasten the ankles of the American and the Soviet commanders of the mission. First, you could take a bigger rope and maybe fasten the ankle of the European on board. And if you don't find the bigger rope, then ask the European to step down first. They have done that 500 years ago when they discovered a new world. They could do it again.
Thank you, Roger. The United States has much to learn from the experience of Europe becoming a federation of nations, and certainly in the space experience, there's a lot of directly applicable experience and ideas, and I hope that we're aggressive in pursuing it. Dr. John McLucas, our next speaker, is now coming to the podium and will provide yet a different perspective on international cooperation.
Well, we were told that we should talk about what came out of our meetings of the last 2 days. I suspect that most of us came out with the same biases we went in with, but perhaps reinforced to some extent. But I did learn some things. For example, I learned that Carl Sagan does not talk only about Mars. He used quite a large fraction of his time talking about mission to planet Earth. But I passed out at this meeting 2 articles that I had co-authored on exploration of Mars. And so none of us is following the prescribed scenario. I've gotten quite a bit of criticism from my friends who say, you're supposed to work mission to planet Earth. You're not supposed to work Mars. So I think it's just as well if we diversify a bit. In Carl's talk, he mentioned the practical aspects of space as well as the political and the visionary. And one of the most practical examples, of course, is communication satellites. And they're not only practical, but they're a big thing, and they've had a dramatic effect on the way we see the world, see ourselves, the way we communicate. And in fact, I think they've had very far-reaching consequences, political as well as otherwise. Some people say the military reconnaissance satellites are the most important outcome of space activity. I won't debate that, except to say that a few people see the results of the military reconnaissance satellites, and everyone has a television and therefore knows what the communication satellites do. Well, we all know that Arthur Clarke is a man who invented the geosynchronous satellite, which is used for communications, and we know that he also uses frequently the term a global village, although he's not the only one who uses it. Arthur has chosen to live in Sri Lanka, which is a paradise, at least by his definition. It has good scuba diving and a mild climate, and perhaps it was the only country available at the time who was willing to pass an act of Parliament to give him a tax break on all of the royalties he was earning in the United States. But in any case, he chose Sri Lanka, and he has become something of a hero over there. But Sri Lanka is a sad example of what can happen in paradise. I happen to be chairman of the Arthur Clarke Foundation, and one of my jobs is to pick the annual speaker who will give the Arthur Clarke Lecture in Sri Lanka. This year is the 25th anniversary of the communication satellite in synchronous orbit. It seemed a logical time to pick Harold Rosen, and he has written a speech which he should give next week in Sri Lanka, describing the invention of communication satellite in a practical sense. Arthur had done it on a theoretical basis. And I have a copy of his speech. Unfortunately, he will not be able to give it next week because the situation in Sri Lanka has deteriorated to the point where it's considered not a smart idea to go over there. And so I point this out for one simple reason. The communication satellite has brought people together all over the world. Continents are now in touch with each other which could not be in touch before. At the same time, it cannot solve the simple problem of a civil war created by ethnic differences in an island which is only 30 miles across. You would think you wouldn't have to go into space to solve that problem, and yet it's bigger than what the satellite has been able to do. Well, the reason I'm here talking, I think, is because I'm involved with some international activities, and the first one I will mention has already been mentioned by Joe Pelton, the International Space University. I think this is significant in two senses. This university was created by 3 young men in their 20s. They call themselves first the space generation. What does that mean? It means they were all born after we were engaged in space flight. As they looked around for practical things to do, it occurred to them that an international space university, which would bring people together from many countries, could play a key role in getting people to learn to work together. And that those people who plan the space missions of the future would have a total international perspective. So they persuaded some of us to act as their board and to help them sponsor this activity, and we just completed our first successful season. We had 104 students from 30 countries, convened at MIT, and everyone involved has pronounced the results a huge success. I see several of our board members in the audience, including our chairman, Ian Pryke. The first year, as I say, was at MIT. Next year, we'll go to Strasbourg. I think Carl also set the stage for this. Mr. Sharif showed that people who learn to cooperate and share joint experiences, we'll be able to do good things together. And now to the next international activity I wanted to mention is the International Space Year. This, of course, is the year 1992. One of my daughters said when she heard I was working on the International Space Year, you know, there's an interesting coincidence. That's going to be the 500th anniversary of Columbus's voyage. I said, it's not a coincidence. Anyway, in 85, 86, the International Space Year legislation was put on the books. Congress, the President signed off. And a year later, we were able to conduct the first International Space Year Association conference in Hawaii under NASA sponsorship. And there we had nations from all around the Pacific plus Europe planning together on what could be done internationally with regard to space exploration. And we had 6 different workshops: space science, planetary exploration, space transportation, etc. But the one that I was most interested in was the remote sensing group, and I proposed there something called International Landsat. I thought that Landsat would be a much better project if it were operated on a basis comparable to Intelsat. Well, there was a Frenchman there named Pierre Bescon who said, well, that may be a good idea, but you can't jump from where we are today to an international Landsat. Why don't we form a remote sensing council, and one of its agenda items would be to look into whether international Landsat is a good idea. I thought that was a terrific suggestion, so when we held our second conference in New Hampshire in April of this year, I again talked about the Remote Sensing Council. Well, we had another good Frenchman there. Hubert Curien was chairman of this particular conference, and he convened a session with the various space agencies that were represented there. There were 17, by the way. And he came out at a coffee break and he said, John, I'm having trouble selling the idea of a council. He said, we've got to come up with another term. Some people say council connotes too much authority. I said, I didn't realize it connoted any authority at all. He said, well, I'm having trouble with the term. What would you think of the term forum? And I said, it sounds like a wonderful term. So anyway, out of there came the SAFIC, Space Agency Forum for the International Space Year, and these 17 space agency representatives agreed that they would convene periodically and share their activities on remote sensing, or if you want to call it mission to planet Earth. And since that time, we've had 2 more meetings, and the number 17 has grown to 22. So I think that is moving along. By the way, one of the people at that meeting was Roald Sagdayev, whom many of you know. And I frequently say that if Sagdayev didn't exist, he'd have to be invented, because he's the precursor of Gorbachev. He was following his own model for years before Gorbachev saw him in action and decided, you know, there is a way to operate and to win brownie points by acting more like, you know, ordinary people. But when I saw Sagdayev there in New Hampshire, he saw me, he rushed over and he threw his arms around me, and I was sort of taken aback. I mean, I don't have Russians grabbing onto me every day. And so I said, you know, if my Air Force friends see me here, they'll probably lose my clearance. Anyway, Sagdayev is an interesting character, and he always has something interesting to say. For example, we had lunch with him here recently, and he said, it's not true that we don't have personal computers in the Soviet Union. He said, we have 50,000 and 1 printer. Anyway, at this particular meeting, his comment was, you're trying to find a term that doesn't connote too much authority? He said, I've just been made a member of the Politburo. Why don't you call it the Politburo? Well, I think if we're going to talk about space activities at a time of budget constraints, we have to show that space is a practical kind of activity. And that means we have to draw up certain priorities. At the same time, I think we have to recognize that one of the main reasons for being in space is political, because we started the Apollo program because of political reasons. I claim that one of the main reasons we're doing the space station on an international basis is political. And people talk about how you can save money by going international. I think that's probably true, although I think it's also true that it's much more difficult to operate an international management structure than it is one based only in one country. So I think there's many offsetting factors, but the political factor overrides, I think, any of the other difficulties of a management nature if you can pull it off successfully, because these people who are working together are going to develop common ties and reasons to cooperate more in the future. I'd like to think that, as Carl has said, that the political significance of cooperation that involves the Soviet Union would transcend what we've done with our friends in the International Space Station, and that there might come a time when we would think just as casually about cooperating with any nation on Earth as we do in cooperating with our friends in Canada, Europe, and Japan today. The last subject I wanted to mention was my role as chairman of the NASA Advisory Council. In that role, I get an opportunity to give NASA advice, which they may or may not want. But recently I went to a meeting of the International Astronautical Federation in India. And this is, let's face it, India is a third world country. The International Astronautical Federation typically meets in an advanced country, a country with high technology, with mature space programs and so forth. But India is the, you might say, the example of how a third world country can mount a space program which has very practical consequences. First, they had an experiment which NASA helped them do to show that communication satellites could be a good educational tool. Now they have INSATs in operation. Not only is it good for education, but it's a huge money maker. They've found that everybody wants to put ads on their television programs, and not only that, it stimulated a new television production industry over there. But anyway, that's not what I'm supposedly talking about. In the lead-off sessions of that conference, there were several speakers talking about different things, but one of them was Bill Ballhaus talking about space exploration. The other three talked about how space could be used for what I'll call down-to-earth problems. I see one of the speakers sitting there who talked about an audio broadcasting satellite that could take programs all around the world. But the three people talking about down-to-earth problems, which the third world needs space to help solve, it seemed to me sort of set the tone of that whole conference. So I came back, composed a letter to the NASA administrator and said, mission to planet Earth is the way we've got to go. On a priority basis, it's obvious that every third world country, every advanced country, all of us need what we can get by intensive exploration of the Earth's parameters, and this has to be our priority mission. About 6 months ago, I found myself talking to a second grade class because I had a grandson in the class. And I pulled out various models of spacecraft, airplanes, various gimmicks. And the thing that surprised me about this exercise was they kept me there for 2 hours. But although they learned something from me, I learned a hell of a lot from them. I found that these 7-year-old kids knew 100 times as much about space as I did at the same age, and that they were ready. Anything you mentioned to them about what kind of activity you wanted to carry out, or any international cooperative venture you might imagine, they were ready to talk about. So I think we've got to get up in step with our own kids. And let me close on a small example of international cooperation. There's several of us in the room here who had something to do with putting together a 10th anniversary celebration of the Apollo-Soyuz event. Now, there was a political event, and it's a good example of how you can gain political mileage out of international cooperation. Many people thought the Apollo-Soyuz event was sort of a nothing happening. It was so small. What really happened? A handshake in space. And yet, when we brought together 600 people in the National Academy Auditorium to celebrate that event, you could feel the chemistry, the vibrations in that room. People saying, you know, this was a great thing. Why don't we do more of this? And I was reminded of some of the problems we had in pulling that off. For example, relations with the Soviets were very upset at the time of the 10th anniversary because of Poland, Afghanistan, and a lieutenant colonel had just been shot in Berlin and so forth. And when we called the NASA administrator and said, we'd like to put on this demonstration, this celebration of the 10th anniversary, and we'd like to have you participate, he said, I can't go near the place. And he recited all these problems that we were having with the Soviets. And he said, besides, if we tried to cooperate on that, the White House would be all over us. You guys don't understand the problem. Well, fortunately, I knew someone in the White House who used to work for me. He was a colonel. And so I called him and said, you know, I think a call from you to the White House, from the White House through you, is all that's needed to get the NASA administrator to cooperate with us. The colonel made the call. We had the celebration. And as I say, 600 people had a hell of a good time celebrating international cooperation. Now, I don't know which event leads to which next event. I think there's no way you'll ever know. But the Soviets were impressed with the fact that we were willing to take an initiative at a time when the relations were not ideal. And they sent people over, all the cosmonauts who'd participated in that event were there with us. People had their arms around each other. And the Alexei Leonov and Tom Stafford were on TV the next morning together. They had their arms around each other. And I remember Alexei's last words. He said, I would go anywhere with Tom. The advantage of international cooperation. I'll use my time.
John deserves some extra time because I neglected to mention he's been the chairman of our whole conference, and so he deserves a lot of credit for putting this together. Our last speaker, Dr. Evans from Canada, is going to give us the view from our close neighbor as I think both the view of the problem and perhaps the view of ourselves in that regard.
Well, thank you very much, Bruce. I'd like to echo Roger's sentiments that certainly I and the Canadian government are very pleased that we were invited to participate in this conference, and we extend our appreciation to the organizers for having us come down. We've heard a lot in the last day and a half and today in today's plenary session here about some very high ideals in terms of space cooperation and in terms of international cooperation. We have lots of ideas: mission to planet Earth, a return to the moon, and a voyage to Mars. What I'd like to do in a very quick wrap-up from my perspective is to try and bring us a bit down from some of these high ideals and explain, or at least talk a wee bit about some of the practical sides, the practical problems of, in fact, carrying off these very large international cooperative programs. And what I'm going to give you is a perspective from the small guy. Canada is a small guy in the space business. To put us in perspective, we're about 8th in the world in terms of our expenditures in space as a percentage of our GNP. But nonetheless, we do feel that we have contributed to our own national economic and social strength through the use of space, and also we believe that we've been able to contribute to various programs around the world. We do cooperate, as Roger mentioned, as a cooperative member of the European Space Agency. We have cooperative programs with Russia, with the United States, of course, Japan, Sweden, and many other countries. And what I'm going to give you is a perspective from somebody who has just come from the front lines of negotiating the space station agreements. I was a co-chairman of the Canadian side, responsible for our participation in the negotiation of the Intergovernmental Agreement and the Memorandum of Understanding. In my view, the space station agreements have forged a substantial new ground and have set a new baseline for international cooperation. I think we also have to appreciate how long it took to do that. I can remember the first visit of James Beggs to Canada with the invitation to participate in space station, and I believe that took place sometime in 1984. It was in 1988, near the end of 1988, that we eventually signed the international agreements. It was 4 years of intense discussion, negotiation between friends and allies. And what I would like to caution about is, or at least put on the open for people to think about, is when you start involving other nations with whom you have not had such extensive and long-term cooperation, how long will it take to negotiate the agreements for a trip to Mars? What did space station agreements do? They really set new ground in terms of political commitments. For the first time, we have a multilateral treaty between nations with respect to an international cooperative space venture. These international treaties have established the very difficult ground rules in terms of legal cooperation, the legal aspects of living and working in space together. These documents have addressed the very touchy issue of technology transfer. How can we have all these nations working together to build hardware which will exist together, and with foreign nationals from many nations working on the space station and using each other's equipment? But primarily, I believe that what space station has done is forge a new way in which international programs will be managed. And to some very large extent, I believe that the way in which this program is implemented over the next several years, the success or failure that we collectively, the United States, Canada, Europe, and Japan, the success that we collectively have in actually making the space station management process work, I think will have a significant influence on the way in which future major international space programs are undertaken. There were several lessons that we had to learn as we went through the very arduous and sometimes difficult process of negotiating these agreements. One thing which is very clear is that the space agencies around the world are not in control of such major programs. It is the governments of the various countries that are in control. I go back a long time in the space program, and I remember negotiating agreements with NASA, with ESA, with Japan, on projects which involved just the space agencies of those countries. Those are very simple agreements to negotiate, because the technical people have exactly one common desire, and that is to produce the best piece of hardware to meet a common set of objectives. When you move into the era of creating international treaties, you bring in a whole baggage of other concerns. And I think it's something that we all have to bear in mind, is that there has to be a very strong political government will behind these projects in order for them to work. Another thing which was alluded to today at lunch by James Beggs in his speech to those of us who were privileged enough to be there is a lesson, I think, that was also learned in this process. And that is that the United States no longer can claim to be the leader in everything in space. If we go back in the past 25 years, that was clearly the case. However, in my mind, there is a new order, and as a small player, I think I can say this, there is a new order in the international space arena. The European Space Agency has had more than 10 years experience in making 13 nations at the government level cooperate in international space programs. The European Space Agency is going to double its space budget in the next 3 years. Japan is an emerging space power with goals of having its own independent manned space capability. We're all aware of the progress and the prowess of Russia and China. And I believe that this new playing field, this more level playing field, is a fact of life which in the space station negotiations I think the United States had some difficulty realizing. The other important thing that we realized, that with this leveling of the playing field, with the oncoming of strong players internationally in the space business, technology transfer is a two-way street. That means that no longer is the U.S. concerned only about protecting its own technology and its transfer, that the rest of the world has similar concerns. And so there is now a new force, a new impetus, I believe, on the international scene to ensure that we share our technology towards a common purpose, and that we do so in a regime which meets the individual objectives of the various countries. I think the prospects for international cooperation are better as a result of the fact that we have the space station agreements in place. They are a forerunner of what will be necessary for a multilateral manned mission to Mars, or a multilateral exploration and revisit to the moon. However, I believe that space station is a turning point in terms of these international treaties and management setups and organizations, and that as we go forward, we'll find that there will be more equal partnerships, and that we will find that in some instances the United States will take the lead, in other instances other nations will take the lead. I also believe, as we listen to I guess what I took away from this conference is, and I apply my space station experience to the concept of moon missions and Mars missions, that the time is now to start to plan and work with all the international partners towards a common goal. It takes a long time to put these in place, and if it takes 4 or 5 years for friends and allies who have had a long history of cooperation to put an agreement of this nature in place, it's going to take much longer to bring in the rest of the world's countries. Thank you.
Well, thank you very much for some very fitting words. I think we do have some time for questions. What I'd suggest, Carl, we got an extra seat. Why don't you come on up and provide a target here. And I guess the best way is for people who have questions simply to approach one of the microphones. I'll try to recognize you and, if necessary, repeat the question. Go ahead. No, speak a little louder.
I don't believe that there's a great deal of skepticism that given enough money and the desire to do so, that we can technologically stage a mission to Mars. One of the concerns that was expressed at a recent conference of the American Astronautical Society is how fit is man physiologically and psychologically to undertake a mission that will last anywhere from 18 months to 3 years, depending on how it's staged. That is going to take a long time to develop and demonstrate the human technology to coexist and to exist in a small environment for a long period of time. An example that was made is that when the Russians come back from their very extended missions in in Earth orbit, that they need physical assistance when they depart the spacecraft because of the condition of their physical state. Who's going to help the Mars visitors?
We'll let Carl respond to that.
Well, there's no question that the physiological issues have to be addressed. I remind you, however, that Soviets have already been in Earth orbit for longer than some of the trip times to Mars. I spoke to one of the Soviet cosmonauts who had been up for many months, and he said when he landed he was able to walk 1,000 steps along the center line on a highway. Sort of an interesting image of him emerging from the spacecraft and doing this drunk driving test. And so he was a physician. So it was his contention that this is not a serious problem. If it is a serious problem, then the alternative is to spin the spacecraft up so you get through the centrifugal pseudo force 1G or 0.38 G or whatever you want to do. But there's no question that you would not commit people to such a mission without a great deal of experience in a simulated Mars flight, and that's one of the many things that has to be done. That's why it takes time to do the preparation, but there is no hint of insuperable physiological difficulties.
Let me just add to that we've talked a lot about the goal, the long-term goal of human flight to Mars, or the Moon, but especially Mars, and discussing the political benefits and so forth. What we haven't talked about, and I think it tends to corrupt the conversation a bit, is that that's not what people would be doing now. Nobody's going to run in the wildest scenario and ask for a budget to go to Mars. What would from now to the end of the century, realistically, by any nation, is you got to solve at least 3 critical problems, which can be solved within current budgets and current technologies and current programs, provided they're focused. One of them is you have to know more about Mars. That's robotic. That's fairly straightforward. Secondly, you need to know more about humans. That was a question mentioned here, both physiologically, psychologically, a lot of subtle things. You do that through space flight as well, but very carefully done. And thirdly, you have to know about reliable closed ecosystems, which is another thing. These spacecrafts have got a lot of recycling in them. They've got to work for years, and it's a new technology. Those all can be done nationally, or they make very nice candidates for binational or multinational programs. They don't cost very much, and they enable the human species to go sometime in the next century to Mars. They also provide the critical political information as to whether these countries are really going to be able to work together. And you do it within technically manageable and financially manageable chunks. And so I want to be sure that's clear, that I don't think anybody's advocating making a decision to go now or to commit the kinds of funds that are required, but simply to pick it as a goal and then do the enabling things for the next decade. Well, I've used the chairman's prerogative on this. Do you want to add to it, Harlan?
Just make one additional comment. Anyone who's read stories of the Napoleonic Wars period, for example, knows of the incredible conditions that men were crowded under decks in ships that sometimes took the better part of a year to go from anywhere to anywhere. Now, admittedly, they used the lash to keep them in shape, and maybe we should worry about that for the space program of the future. But no, seriously, human beings are immensely adaptable under difficult conditions, and these will be very selected people under highly stimulating conditions with all the resources a human race can bring to bear. I have no doubt, I agree with Carl, that the voyages in that sense can be made. There are other hazards.
When you begin to speak, if you wish, you might identify yourself.
Thank you, Dr. Murray. My name is Les Dorr. I'm with Final Frontier magazine. I wonder if you could address a point which I believe Dr. Evans touched on briefly. Something on the scale of an international mission to Mars is a decades-long undertaking costing billions and billions of dollars. And I wonder if you gentlemen have any thought on how an endeavor of that sort can be insulated against change in the political winds. Right now, of course, we have the movement toward perestroika and toward glasnost in the Soviet Union, but there's no guarantees that that's going to continue for an indefinite period. And in the United States, there's no guarantees that a future American president will continue to support the outlays needed for such an endeavor. So is there any way to insulate a joint mission to Mars, an international mission to Mars, against those changes in the political winds?
Who wants to answer? Carl again.
Well, I think it's a question of cause and effect. I think, at least my reason for supporting such a goal is in order to help produce a political climate in which the two nations have this shared common purpose and do not have uncomfortable changes of the sort you mentioned. So I don't think it's a question of first we magically produce a global situation in which neither nation has any chance of defecting from the cooperative relationship, and then we establish the joint mission. I think instead we establish the joint mission in part to accomplish that improved relationship between the two countries. And of course, there's some risk of failure, but the stakes are so high. I mean, I remind you that the cost for each side of this mission is roughly the same as a single strategic weapons system, and we have plenty of those. It seems to me worth doing, considering the importance of the issues at stake, quite apart from the adventure and science of Mars exploration.
The other aspect of this, which for this audience ought to be emphasized, that in a program of this type, you would segment it in time. That's what I'm referring to. There are near-term milestones, like 10 years, but nevertheless, that's the enabling technologies. And then if those milestones are met, one is prepared as a later decision to make the commitment to go ahead and go. So you segment it in time, and you also segment it functionally. And we've looked at, there's been a lot of study of Mars rover sample return by a group, a NASA-sponsored group of this, and a lot of attention has been given to how you do that. And it turns out that if that's a criterion of the structure of the program, that's rather straightforward. And so the idea of developing functionally separate and compatible synergistic units, but that have standalone capability if one of them fails or doesn't go. So there, you can design, I think a lot can be done in program design and in system design if it's understood that's a requirement. And that's part of our learning process in this new world. We ain't going to be the dominant one that does the system design, sets the program goals, and then invites our secondary allies, so to speak, to come join us. I think that was the message that derives from the talk we've heard from our foreign participants here, is that when we're no longer the big gun, even with the Soviets, if it's egalitarian with the Soviets or multinational involving ESA and the Soviets and other countries, then we're going to have to design programs differently. And I think that's possible, but we've got to change our mindset to do it.
Just one point that I was trying to make is that Space Station is a very large program, a very large multinational program. You have to realize that Space Station, in essence, changed the direction of very significantly the direction of the program, certainly in Canada, in Europe, and Japan. They've all focused on Space Station as a primary objective. This led those international partners, Canada, Europe, and Japan, to think in terms of an international treaty as a way of buffeting the program from the whims of annual budgetary processes. And so we have tried that approach in the Space Station program to try and use that to buffer us from those problems.
Thank you. You want to take the phone and identify yourself?
My name is Ron Griffin with the Vitro Corporation. The question I have is, can someone briefly describe the major advantages of deploying telescopes on the moon for exploring the universe as opposed to just putting them in space like the HST?
Just a couple minutes.
Thank you. Yes, I'd like to speak to that. When you put a telescope in free orbit, you can do it. If it's in near-Earth orbit, you get into all kinds of complications. Let me mention a couple. First of all, you're whizzing around in only 90 minutes. You're moving at 8 kilometers a second with respect to the atmosphere. You're encountering ionized oxygen at a ferocious rate. The Earth fills half of your field of view. You can get a dark sky exposure for maybe 40 minutes at a time. It takes an hour or two to move the telescope from one orientation to another in extreme motions, somewhat less for closer ones. You have to balance the thing to the order of 1,000th of a second of arc against gimbals. Incredibly difficult, expensive. This is the reason why Space Telescope costs $1.5 billion, even though it's smaller than my relatively modest 107-inch telescope at McDonald. Now, that's tough. We could put much bigger telescopes on the moon for much less money if we only had to pay the transportation costs to the moon and had light-weighted units there. That's one level of argument. They really will be cheaper, provided the cost of building the lunar base is amortized against the human move into space and is not charged against astronomy. And I agree, the astronomy budget couldn't carry it. Now, that's only the most obvious example. Let me mention another. You'd like to do what we call interferometry in space in order to get high angular resolution. In principle, you can do that by putting remotely floating vehicles in space, and probably some of those problems are soluble, but it's all going to be expensive to maintain baselines, orientations, constant aiming of the telescopes at the source you want to study, and so on. In principle, it can be done, but staggeringly expensive. On the moon, if you have the lunar base, you go out and plunk down your little telescopes. I'll mention just one more and then I'll subside, but again, this is a long story. I have several long articles on this. Let me mention one more. If you wish to explore new domains of frequency that have never been studied before, you normally find exciting new astronomical results. There is a domain from roughly a few hundred kilohertz in frequency up to about 10 megahertz that is essentially totally unknown. It's the biggest spectral window we know essentially nothing about. It would be almost impossible to build an effective system to observe this in space, and you can't do it from the ground because the Earth's ionosphere blocks it. On the surface of the moon, it would suffice to lay out little elements, really about the size of a pencil, at intervals of hundreds of meters, each of which has a little chip, solar battery, a little transmitter to send signals to a common computer. For an incredibly low cost, you build an array of tens of kilometers in size on the moon and get an extraordinarily effective radio telescope of a kind that could be built nowhere else in the universe. These are just a very few points.
Again, a lucid answer, and I can assure you there's a lot more where that came from. So what I'd like to do, because of our time situation, is acknowledge the two questioners are at the microphone, and that's where we're going to cut off, and hope that the panelists' responses can be fairly brief too.
And my question is there any ongoing programs or even exploratory meetings on an international scale or even national scale? And if there isn't, the feasibility of exploring new means of propulsion in space beyond chemical propulsion so we can take up greater masses at greater efficiency and get greater distances in quicker time.
Who volunteers? Harlan, do you want to take?
I think that's yours, Captain. You're a JPL man.
Well, not recently. As far as I know, we did a little bit of work, or there was a little bit of agitation on this back in about 1980, and it turned up matter, antimatter, and it turned up exotic sails with giant lasers and so forth. And those were the two things. The outcome of those have been the giant sails became the basis of a science fiction novel by Bob Forward and technical papers with Freeman Dyson. And the antimatter is something that you watch because they take one antimatter particle at a time in CERN and they try to keep it in a magnetic bottle and they put another one in and then they put another one. And if you want to extrapolate in that way, it's a long way in the future. The answer is that there, as far as I know, there is nothing in the time scale we're talking about, including going to Mars, and by the way, I include any kind of nuclear rockets in that regard, that competes with existing chemical systems. And there's certainly no constituency to develop them. Beyond that, you know, science goes on, technology goes on. It's hard to know at what point some, radical change might take place. But there's certainly nothing that one can foresee or that I foresee in that time scale.
Specifically, one area I was interested in was evidently new material processing developments has allowed the thinking of solar electric propulsion and ion generation. Just in the last couple of years, Ted Taylor, who was behind the Orion project, is very enthusiastic about this potential.
I think the problem is that you can't show that the mission they propose to do, you can also do chemically. The chemicals exist, and that therefore there's not an incentive to launch a large development program. Let me give our last, I'm sorry, we got to sign off the last speaker here. Go ahead.
The name's Kevin Owens. I'm just a member of the Planetary Society. And one of the issues that has me puzzled is we've discussed a lot about international cooperation and the cost, the engineering, and the systems to get to Mars and the Moon. But there's little discussion of after we've gone there and come back is what do we do next? Is there been thinking about homesteading these places, or we find out what's there and then just do like we did with the Moon and say, well, we found out what there was to find out?
I think the easiest answer is a National Commission Space report, which is widely available, deals with that hope and aspiration and also some of the difficulties in rather great extent. And beyond there, it's kind of voting your conscience about the future. I think but I think that report really is the best response to that. So with that in mind, I'd like to turn the meeting back to the chairman here and let you take over here.
Thank you, Bruce. Thank you, rest of the panel.
God, we're right on schedule. It's remarkable. We're done, I think. It's been I hope you found a useful afternoon. I think the retention of a significant portion of the audience suggests that you found in our public discussions the same kind of intellectual excitement and challenge that we've been finding for the past day and a half. I thank you all. And who knows when the next one of these things will happen here at the university, but you'll certainly know about it. Thank you.
You've been watching a conference on space exploration, sponsored by George Washington University. Be sure to join us later tonight for a live viewer call-in program on the recent Soviet troop reduction proposals with Ambassador Edward Rowney. Coming up at 6:30 p.m. Eastern Time, 3:30 p.m. Pacific, live on C-SPAN. And coming up in a moment, a look at the congressional budget process with Rudolf Penner of the Urban Institute.
Since the removal of Manuel Noriega. Sunday beginning at noon Eastern Time, 9 a.m. Pacific Time.
Coming up next, Carl Sagan, Director of Planetary Studies at Cornell University, addresses the Interparliamentary Conference on the Global Environment. It is the first U.S.-sponsored conference of legislators to focus on the global environment and includes representatives of more than 40 nations.
Ladies and gentlemen, welcome to the first U.S.-sponsored Interparliamentary Conference on the Global Environment. Today, together, this week, we're making history. We begin a task of tremendous importance with implications for this generation and every generation to follow, for our children and our children's children. Thank you for joining us here. Thank you for your courage, leadership, vision, and your energy, and for the commitment your presence reflects. More than 42 nations from all parts of the globe are represented here. Many different voices with many different concerns will all be heard during the next 3 days as we work together to find one voice with which we can all speak out to advocate the policies our global environmental crisis demands. I would like to take just a moment to recognize the host delegation from the United States Senate and ask that members of the host delegation stand. First of all, Senator John Chafee of Rhode Island, the ranking member of the Senate Environment and Public Works Committee. Senator Chafee. Senator John Hines, a member of the Senate Finance Committee of Pennsylvania. Senator John Kerry of Massachusetts, a member of the Senate Foreign Relations Committee. Senator Tim Wirth of Colorado, a member of the Senate Energy and Natural Resources Committee. Two members of our host delegation, Senator Rudy Boschwitz of Minnesota and Senator Max Baucus of Montana, are unable to be with us this evening, but will be attending the conference sessions later on. One of our vice chairs from the United States House of Representatives is here, Congressman Bill Green of New York, of the Appropriations Committee. I would also like to recognize Walter J. Stewart, Secretary of the United States Senate. Now I take particular pleasure and great honor in recognizing some of the delegates who are also the heads of parliamentary bodies in their own countries. Monsieur Laurent Fabius, President of the French National Assembly. Nelson Carneiro, President of the Senate of Brazil. Marco Antonio Dardon, President of the Congress of Guatemala. Lucien Xavier Michel Adrien Naran Injak, President of the National Assembly of Madagascar. Mutari Musa, President of the National Assembly of Niger. During the next 3 days, we will work together in plenary sessions and in smaller groups focused intensely on 7 different issues about which we will hear a good deal more tomorrow. We will hear from scientists, researchers, policymakers, and even poets. We will see the first ever whole Earth photograph and the very latest in a special film made from Earth orbit about our Earth. Our goal will be to produce specific legislative strategies for action sensitive to our various concerns that will mean real changes and real progress. The problem we are facing is so difficult and unprecedented that sometimes we must move beyond mere words to poetry. And so we begin this evening with an original poem composed especially for this occasion, the first time he has composed a poem in English, the legendary poet of conscience, who is himself a parliamentarian from the Soviet Union. It is my pleasure to introduce a wonderful friend and parliamentarian, Yevgeny Yevtushenko, a delegate to the Soviet Congress of People's Deputies.
Such a change of time when American senator could inspire a Russian poet to write one poem. I'm sorry for my pronunciation. The last petals dedicated to my brother, Senator Elgor, who did a lot of things for Mother Nature. The last purple, but almost not palpable, pale petals. Probably the last child revolving around the pedals, the slow and creaking pedals of probably the last bicycle. The rusty smell of probably the last roof reminds in the transparent soul of probably the last icicle. Your lips, my beloved, are like last petals on the dried up tree of life. Mother Earth looks like a widow bleeding from her own grateful children's knife. We live at the strange time of the moral autumn. Last petals of conscience, last pets, last polar bears, parrots, poets, last political peacocks, last prophets, last prophets, last sweet pity of probably the last babies, last peaceful pleasure to play with puzzles, last privilege to have faces without muzzles. At the Earth Day, at the funeral of Earth, at the day of common thirst, when nobody wants to die first, I feel like a last petal of a flower not yet born. Thank you.
It's wonderful. Thank you so much. Thank you. Thank you so much for that original composition, which is so moving to us at the start of our proceedings. Before our keynote speaker, we must attend to several conference formalities. By addressing these matters this evening, it is my hope that we will be able to begin immediately tomorrow morning with the formal proceedings of the conference. If there is no objection to proceeding with these matters, for the selection of officers, I turn the podium to President Laurent Fabius of France. President Fabius is an internationally respected parliamentarian and President of the French National Assembly and former Prime Minister. Mr. Fabius, we will give the gavel to you for these conference formalities. Mr. Fabius will be speaking tomorrow morning as well to give us an international greeting.
Thank you. I will speak English. Pidgin English. And it will be very, very quick, very short. I move that the organizer and chairman of the host delegation of this conference, Senator Al Gore, be named the chairman, and that we also name a group of vice chairmen to assist the chairman in conducting his duties. That's all. Is there any objection to that difficult decision? Seeing no objection, the chairman and vice chairman are so selected. Thank you very much.
Thank you very much.
Congratulations.
Short speech. Yeah. Thank you very much. We do have two other procedural matters that it would be helpful to address briefly this evening. We need to adopt the conference rules and conference agenda, which all of you received in the package of materials distributed at registration. These are fairly self-explanatory, and if there is no objection, I would propose that we adopt them. Is there objection? Hearing none, the rules and the agenda are adopted. For those who are not parliamentarians and who have attended other conferences, please understand that we parliamentarians have to have rules in order to proceed. Finally, I would ask that we appoint a coordinating committee of the conference who shall have the responsibility of preparing each day's working documents for consideration by the conference at large. I would suggest that the coordinating committee consist of the working group chairs and co-chairs, as will be determined by each working group tomorrow. And if there is no objection, we will so designate the coordinating committee. Thank you for attention to these matters, and now let me introduce our honored speaker this evening. Our keynote speech tonight comes from an individual who has helped us dream and has helped us see what before we could only imagine. Carl Sagan has inspired not one nation or one people, but many nations and many peoples. The children of those of us here in this room know him on a first-name basis because he has taught them so much through the magic of television all over the world. Carl Sagan is a Pulitzer Prize-winning author whose television series has won Emmy Awards and Peabody Awards. If I tried to share with you tonight every award he has earned for his outstanding contributions to our understanding of the world, he wouldn't have much time left to speak. Carl Sagan has been a leader in the Mariner, Viking, and Voyager expeditions to the planets, for which, I might add, he received the NASA Medal for Exceptional Scientific Achievement and many other international and national awards. His scientific research has enhanced our understanding of the greenhouse effect on Venus and here on Earth, dust storms on Mars, the organic haze on Titan, the origin of life, and the search for life elsewhere in the universe. He has most effectively sounded an alarm that is being heard worldwide, alerting people to the global environmental crisis before us. I am honored to know Carl Sagan, to be able to call him a friend, and tonight to introduce him to you, Carl Sagan.
Thank you, Senator Gore. I'm most happy to be here at this gathering of members of the human community from all over the world. You know, we humans started out in East Africa some hundreds of thousands of years ago and spread all over, so that there's hardly a place on the planet that is not occupied by human beings. And in all that course of time, we've been divided into small communities, wandering tribes. And only lately, in the last blink of an eyelash, compared to this great time scale, have we begun coming together again, even knowing about each other. So a gathering like this is kind of a gathering of the tribes, in which humans from all over the world come together to discuss common concerns. But this is not just any group of humans, it's a group of humans who have actually a possibility to make things better. I very much hope that you will. Several people have asked me why I, as an astronomer, am involved with these issues, and there are many, many different schemes of causality that are responsible, but I want to just stress one. I'm a planetary scientist. It's been my great good fortune to participate in what has certainly never before occurred in human history, the direct exploration of other worlds by robots constructed by our species. And so for the last 25 years, I've been lucky enough to be involved with the design and execution of missions to other worlds in which a spacecraft flies past or orbits or lands on another planet or one of the moons of another planet. Those other worlds are extraordinarily beautiful, highly instructive. As I'll mention later, there are very important lessons for our world that we've gathered by studying other worlds. One of my interests has been the search for life, the possibility of living things on those other worlds. And before we look, no one is in a position to know whether life exists on many worlds in the solar system or on just one only, namely ours. Well, we have now recently completed the preliminary reconnaissance of the solar system. Our spacecraft have now passed beyond Neptune and Pluto, the outermost planets. We have gone past the worlds in the solar system. We have 4 spacecraft heading out into the space between the stars. Of those dozens of other worlds that we have examined, we have not found any trace of life elsewhere. In the case of Mars, for example, where we landed 2 spacecraft and examined the surface for years, we found not a mouse, not a blade of grass, not a microbe, not even an organic molecule. We have found the stirrings and premonitions of life elsewhere. Organic molecules being synthesized on worlds in the outer solar system, but no trace of life. And this gives a certain useful perspective, I think. You can have dozens of worlds that are complex, rich, environmentally diverse, and have life on only one of them. Life is rare. It is therefore something precious. And at the end of this long set of voyages of exploration, I think it's very natural to turn our sight home again, to recognize that what we have here is precious and needs to be cherished. If you look at a picture of the Earth from space, or if you talk to astronauts and cosmonauts who have been in space, one of the most striking aspects of the view of the Earth from a few hundred kilometers up is how thin the atmosphere is. There's just this faint blue aura that surrounds the Earth. It has a distinct appearance of fragility. And it is fragile. The thickness of the atmosphere compared to the size of the Earth is about the same as the thickness of a coat of shellac on a globe of the Earth, in a schoolroom, say. There's not much air. Or consider the ozone layer, about which we are rightly concerned. If that entire layer were brought down into this room, at the pressure and temperature of this room, it would be about the thickness of this pen point. That's all the ozone there is to protect us from the dangerous ultraviolet light of the sun. When we humans started out, our numbers were very few, our technological powers were very limited. The idea that we could affect the global environment was absurd, and the issue, of course, was never raised. But now, our population is immense, more than 5.1 thousand million of us. Our technological powers have become vast, even awesome, and now we pose a danger to this thin and fragile atmosphere. Not intentionally, not because we intend to do it harm. Who would want to harm the life-supporting environment? But simply because our technology is powerful, there are many of us, and we are still not very good at thinking ahead, at recognizing the future consequences of present action. I will come in a little bit to talk about at least one of these environmental issues, but you are a group of parliamentarians. You must make decisions on policy. you must figure out how to decide which issues to devote how much attention to. And I'd like to talk a little bit about that very grave and important question. Human history has faced this kind of issue before. And I want to describe to you two cases that come from the classic Western tradition of ancient Greece. What do policymakers do when faced with predictions of catastrophe? The first story, actually both of them, have to do with the Greek god Apollo. Apollo was an Olympian, god of the sun, but beyond being in charge of sunlight, Apollo was also in charge of prophecy. That was one of his specialties. All the Olympian gods could see into the future a little bit, but Apollo did this on an industrial scale. He established oracles all over the classic world, the most famous of which was at Delphi in Greece. He sanctified the priestess, who was called the Pythia, and kings and aristocrats and occasionally even ordinary people came to this oracle to beg to know what the future holds. Among these supplicants was Croesus, king of Lydia. We remember him a little bit in the phrase rich as Croesus. Part of the reason he was so rich is that he was one of the guys who invented money. The first coins were minted in Lydia in his time. Lydia is in Anatolia, contemporary Turkey. As happens to rich people on occasion, his ambitions could not be contained within a small volume. And so, according to the history of Herodotus, he got it into his head that it would be a good idea to invade Persia. Persia was the superpower of the 7th century BC. The Persian king Cyrus had united the Persians and the Medes into a very powerful empire. So naturally, Croesus had a little reservation about going ahead and invading Persia. So naturally, as anyone would at that time, he sent a delegation of emissaries to Delphi to ask questions. And you can imagine them laden down with opulent gifts for the Delphi to the Oracle of Delphi, because after all, prophecy doesn't come free. And the question that his emissaries put was, what will happen if Croesus makes war on Persia? Without hesitation, the Pythia instantly answered, he will destroy a mighty empire. The gods are with us, Croesus must have thought. Time to invade. So, he invaded and was humiliatingly defeated. Not only was Lydian power destroyed forever, but he himself was destined to live out the rest of his days as a kind of minor functionary in the Persian court, offering little pieces of advice to often indifferent officials. A kind of hanger-on ex-king. Well, time passed and the injustice of it really got to him. After all, he had played by the rules. He had gone and asked the Pythia. He had paid handsomely, and she had done him wrong. So he sent another emissary, this one on a much more modest scale, appropriate to his diminished circumstances, and asked, in effect, how could you do this to me? Here's the answer, as recorded in Herodotus' history. Quote, the prophecy given by Apollo ran that if Croesus made war on Persia, he would destroy a mighty empire. Now, in the face of that, the priestess says, if he had been well advised, he should have sent and inquired again whether it was his own empire or that of Cyrus that was spoken of. But Croesus did not understand what was said, nor did he question again. And so he has no one to blame but himself. Close quote. Now, if the Delphic Oracle is just a scam to fleece credulous kings, then of course it would have needed excuses to explain away the inevitable errors in prophecy. Disguised ambiguities were its stock in trade. But the lesson of Croesus is germane to the questions before us today. Even of oracles, we must ask questions, intelligent questions. Even when what we're being told tallies with what we want to hear, the policymakers must not blindly accept. They must understand. And since the prophecies that concern us today involve scientific issues, the policymakers must educate themselves on science. And this advice, it seems to me, is fully applicable to the modern oracles, who are the scientists and the think tanks and the universities. The policymakers send, sometimes reluctantly, to ask of these oracles. And the answer comes back. These days, often the oracles volunteer prophecies, even when no one's asked them. The first thing to do is to understand. Now, I want to tell you another story about Apollo and oracles. This one is quite different. This is the story of Cassandra, princess of Troy. It begins just before the Greeks under Agamemnon invade Troy at the beginning of the Trojan War. Cassandra was the smartest and the most beautiful of the daughters of King Priam. And Apollo, constantly on the prowl for attractive humans, fell in love with her. Strangely, this almost never happens in Greek myth, she resisted his advances. She said no. So he tried to bribe her. But what could he give her? She was already a princess, she was rich, she was beautiful, she was happy. But Apollo was very clever. He promised her the gift of prophecy. And that offer was irresistible. She agreed. Quid pro quo. So Apollo did whatever it is that gods do to make seers and oracles and prophets out of mere mortals. But then, scandalously, Cassandra changed her mind. She said no again. Apollo was not amused. But he couldn't withdraw the gift of prophecy because, after all, he was a god. And whatever else you might think of them, gods keep their promises. So instead, he condemned her to a cruel and ingenious fate, that no one would ever believe her prophecies. What I'm recounting here is in Aeschylus's play, Agamemnon. So Cassandra predicts to her own people the fall of Troy, and nobody pays attention. She predicts the death of the leading Greek invader, Agamemnon, and the Greeks don't pay attention. She even predicts her own death, and nobody was the slightest bit interested. They didn't want to hear. They made fun of her. Both Greeks and Trojans called her the Lady of Many Sorrows. Today, maybe they would dismiss her as a prophet of doom and gloom. At the end of all this, she says, I prophesied to my countrymen all their disasters. But they ignored her, and they were destroyed, and soon so is she. That's the other extreme in the policy response to predictions of disaster. If we're faced with an ominous prediction involving powerful forces that may not be readily influenced or even understood, we have a natural tendency to reject the advice, to put it off, to ignore the prophecy. Dealing with the danger might take time, effort, money, courage. It's politically expensive. It's difficult. It might require that we change some priorities in our lives. Now, I don't for a moment want to suggest that every prediction of disaster made by scientists is true, and there are many cases in which scientists, like everybody else, made mistakes. But there's a way. There is a error-correcting mechanism built into science. It's part of the ethos of science. And that's why there's a community that argues and checks each other's statements and yells and complains. That is a healthy and vigorous sign. Nevertheless, there's a tendency, no matter how well supported the prediction of disaster is, to be tempted to put it aside. What's more, if the factors precipitating the problem are long-standing, then the prediction itself is a kind of rebuke. Why have we permitted this peril to get so far? Shouldn't we have informed ourselves about it earlier? Don't we ourselves have complicity in letting this come about? Now these are uncomfortable ruminations that our own inattention or inaction might have put us and our loved ones in danger, and so there's a natural tendency to reject the whole business. It'll need better evidence, we say. There's a temptation to minimize it, to dismiss it, to forget it. This is a very common and very human response. Psychiatrists have a name for it. It's called denial, to deny the danger. I don't know if the following remark is going to translate at all. It'll pose a real challenge to the translators. But there's a rock and roll group in America called Dire Straits. And there's a line in one of their songs that goes, "Denial ain't just a river in Egypt." Now these stories of Croesus and Cassandra represent the two poles of policy response to such predictions. Croesus himself representing the pole of credulous, uncritical acceptance, propelled in his case by greed and other character flaws. And the Greek and Trojan response to Cassandra, representing the pole of stolid, immobile rejection of the possibility. The job of the policymaker is to steer a course between these two shoals. And I believe that it is perfectly possible to do that. And in the case of some of the problems before us, the seriousness of the issue is so well established that we cannot, I believe, exercise denial anymore. There are a number of these global problems. Depletion of the protective ozone layer is certainly one, but considering that we are going to have a question period, a dialogue afterwards, I'm not going to take the time to discuss that here or any of the other important issues that you will be discussing at this meeting, save one. And that one is greenhouse warming. In a way, it's the most serious, it's the most difficult. Responding to it requires the greatest change in how we think of the world. And so let me try and address that. But before I do, I just want to point out that we now have a precedent that the nations can get together and can agree on steps, even expensive steps, to mitigate or avoid such a danger. And I'm referring to the Montreal Protocol, in which 33, I think, nations have agreed to phase out the production of the ozone-destroying molecule chlorofluorocarbons, CFCs, despite the fact that it will be expensive for the industries involved. And that is a demonstration that the nations of the world can work together on these issues. It's a sign of optimism, a reason for hope. Now let me talk a little bit about the greenhouse effect. I myself got involved in the greenhouse effect, as Senator Gore said, by studying it not on the Earth, but on our nearest planetary neighbor, Venus, where it is vastly larger in proportions than it is here. The greenhouse effect is something like this. Imagine the Earth sitting in space, and the sun, let's imagine that bright television light is the sun. The amount of sunlight falling on the Earth warms the Earth. The warm Earth then radiates back into space to cool itself off. And the temperature of the Earth, one would think, is determined by the balance between the amount of sunlight that is absorbed and the amount of radiation that's radiated to space. If you do that calculation, we know how bright the sun is, we know how far away the Earth is from the sun, we know how much sunlight is absorbed by the Earth. If you do that calculation, you would predict, and it's done in elementary astronomy and meteorology courses, you find that the temperature of the Earth would be 35 degrees centigrade cooler than in fact it is. Something's wrong with the calculation. What's wrong is that we've forgotten something. That the Earth is not airless, that there is a thin layer of atmosphere that surrounds the Earth. Some of that atmosphere is in front of us, right here, in this room. So I can see people in the back of the room. I hope people in the back of the room can see me. Our eyes work in visible light, ordinary visible light. The air, except in places like Los Angeles and Mexico City, is transparent to ordinary visible light. On the other hand, in the infrared part of the spectrum, beyond the color red, wavelengths longer than red, the atmosphere is not fully transparent. And at some wavelengths, some colors in the infrared, it's opaque. And that means that if we have lots of infrared absorbing gases in the atmosphere, they may not block the sunlight that's coming in to warm the Earth, but they will block the infrared radiation that the Earth radiates back to space, and then the atmosphere acts as a kind of blanket, warming the Earth. Some molecules in the air, like oxygen and nitrogen, the most abundant ones, don't absorb, almost not at all, in the infrared. So they are not greenhouse gases. But other molecules, like water vapor, or carbon dioxide, or those CFCs I talked about a moment ago, do absorb in the infrared and are greenhouse gases. The more of those gases, the more infrared absorption, the more blanket, and everything else being equal, the more the temperature of the Earth should rise. There's no question that since the Industrial Revolution, we have been pouring CO2 and other such gases, carbon dioxide, CO2, and other such gases into the atmosphere. Recently, because of the exponential growth of our technology, we've been pouring many more of those gases into the atmosphere, including new gases that were never known in nature, like CFCs. And all the calculations show that the temperature of the Earth should be increasing. We do not know precisely by how much. There is not yet perfect agreement on these matters. But the bulk of the calculations show that temperature increases of a few degrees centigrade in the average temperature of the Earth should happen sometime in the next century. Now that doesn't sound like very much, a few degrees centigrade. It's a few degrees centigrade warmer in this room with the lights on than with the lights off. What's a few degrees centigrade? But an average, a temperature increase in the average temperature of the Earth of a few degrees centigrade has much greater implications for local and regional temperatures, and I'll show you an example of that shortly. Some of these predictions are very dire. They include the conversion of crop-growing regions into scrub desert, including the American Midwest, at least almost scrub desert. They involve the rising of sea level and the eventual inundation, flooding of coastal cities all over the planet. They involve the destruction of natural ecosystems, the spread of disease, the obvious likelihood of conflicts over water rights. Think of a place like Bangladesh, much of which is already nearly at sea level, and there is not the fiscal resources to build dikes and levees as has been done in Holland, which has a similar problem. It seems very clear that tens of millions of people will find their homeland underwater in Bangladesh alone if some of these predictions are fulfilled. There will be vast numbers of environmental refugees. You can see that putting all of these issues together, we can foresee a very serious set of problems that face all of us. There is essentially no winners. Everybody all over the planet is a loser. Now, I would like to show a few slides. I think it's just 10, and I promise to go through them quickly. This is very dangerous for an after-dinner speech, and I recognize I'm taking a risk. But I want to illustrate a few of the items that I've been saying and say them in another way. This picture is of the surface of the planet Venus, taken by one of the Soviet Union's Venera series of spacecraft. First spacecraft to land on the surface of Venus. Venus is it's the nearest world. It has the same mass, size, density as the Earth. You might figure it's very much like the Earth. But it has a massive atmosphere, 90 times the pressure of the atmosphere of the Earth. And that atmosphere is made primarily of carbon dioxide, CO2, which we know to be a major greenhouse gas. The temperature of this surface is, I'm trying to do a calculation in my head, it's about 470 degrees centigrade, about 900 degrees Fahrenheit. It's hotter than the hottest household oven. It's hot enough to melt tin or lead. And this comes about through a massive greenhouse effect. So if anyone tells you that there is a doubt about whether a greenhouse effect exists or can be serious, please direct them to the planet Venus. Now, I'm not proposing that what's happened on Venus is that there were a race of Venusians who drove fuel-inefficient autos, and that's how they got into this problem. This comes about, as far as we know, without the intervention of supposedly intelligent life. But it is a very important object lesson. Next slide, please. And speaking of planetary object lessons, I cannot resist the temptation to spend just a moment with you on the planet Mars. This is a photograph taken by the United States Viking 1 spacecraft in 1977. Lovely, beautiful, instructive world. That's the subject of another talk. I mentioned the antiseptic character of this surface. Not a microbe, not an organic molecule. Why not? The reason seems to be that there is a planet-wide ozone hole on Mars. There is essentially no ozone in the atmosphere of Mars. The ultraviolet light strikes the surface of Mars unimpeded by the Martian atmosphere, and the result is a surface which is made antiseptic by oxidizing compounds, peroxides, superoxides. And this also may be a useful reminder to us of the importance of an ozone layer. Next slide. Now let me try to just take you through a few slides illustrating the greenhouse effect. Here is, this is a beautiful photograph taken by the Meteosat satellite of the European Space Agency of Africa and much of Europe, taken in ordinary visible light. The next slide shows exactly the same area, photographed by exactly the same satellite at almost exactly the same moment, but at a wavelength of 10 microns in the infrared. This is a wavelength where the atmosphere is still mainly transparent in the infrared. Red is hot, and we can see the hot places on the Earth, and by the way, also you can see over Zaire and much of Central Africa a set of clouds which also work, in this case, to keep the heat in. But now, next slide, if we look at one of the wavelengths where the atmosphere absorbs, we can make out none of the features of the surface of the Earth. We're looking here at high altitude features. And the reason is that at this particular wavelength, the atmosphere of the Earth is opaque. This is an illustration of greenhouse, how the greenhouse works. Next slide. Here is a picture notable in many different respects, one of which is that it accompanied a very excellent op-ed piece in the New York Times on Earth Day by our chairman, Senator Gore, showing the result of boring cores through the Antarctic ice cap done by the Soviet Vostok team, in which are plotted both the observed change in temperature over the last tens of thousands of years and the observed change in the amount of carbon dioxide in the atmosphere. And notice how well the two curves, quite different, track each other. The temperatures are determined from oxygen isotopes in this core. The deeper down in the core, the further back in time. And the carbon dioxide abundance in the atmosphere is determined from little bubbles of air that have been trapped in the ice. So each point in each depth in the core corresponds to a certain moment in the past history of the Earth. You determine the temperature, you determine how much CO2 is in the air. When there's more CO2, the temperature is higher. When there's less CO2, the temperature is lower. This is a very significant and useful demonstration that adding greenhouse gases to the air actually does increase the temperature. And now the carbon dioxide abundance is much higher than it's been anywhere in this period. And the imminent prediction is that the temperatures will be much higher as well. And in fact, even though the average temperature of the Earth has not been much increasing during the decade of the 1980s, the decade of the 1980s still has the 5 hottest years in the 20th century. And just speaking anecdotally, this year looks to be another hot year. Next slide. This is for 3 different gases, how much of the gas there is against time in recent years. This is the carbon dioxide increase with time. Here is a gas called methane, its increase in time. Here is one of the chlorofluorocarbons, its increase in time. There's no question that human activity, and mainly the burning of fossil fuels, is increasing the amount of greenhouse gases in the atmosphere. Next slide. This is one set of computer models. And I can't quite make out the times. Just 1 minute. So I don't know if you can make this out, but there is a Mercator projection map of the Earth here. Western hemisphere here, eastern hemisphere here. And it's the same in each of these 4 maps. This is 1960, this is right now, this is 2000, and this I can't quite make out, but it's about 2050. 2020. 2020, 2050, thank you. And the browner it is, the warmer it is. And you can see the clear trend, and something like this is the trend in all of the 3-dimensional general circulation computer models that have been run. This one from the Goddard Institute of Space Sciences in New York. And the next slide shows, for just the same circumstances, there are maps underneath here as well, and for the same years, a measure of drought. And you can see the drought getting progressively very serious. Now, what should we do about this? The next slide, this is my last slide, is from a official White House handout at a meeting held just a week ago on global warming. And there were many issues discussed in that handout, one of which was called balance. Balance in the parlance of the White House. By the way, I understand this is a non-partisan gathering, but on the other hand, there is glasnost now even in the Soviet Union, so I'm sure you will permit me a personal remark. balance, in the view of the White House, you can clearly see it, has two pans on the scales of a balance. On one side is the planet Earth, and on the other side are 6 bars of gold. And maybe you can notice that they exactly balance each other in the view of those who put this picture together. This is a perfectly good way to address the problem. I'm certainly happy to go along with the White House on this. The question is the picture drawn correctly? Or might the Earth weigh more heavily than 6 bars of gold? I think it's perfectly possible to treat the issue on the grounds that the White House suggests. But the answer is not a perfect balance between the Earth and money. Because the Earth, or at least the part of it that sustains our life and civilization, is priceless. And I would like to argue that before we are absolutely sure, which means that we are either in desperate greenhouse warming or not, it would be wise to take certain precautionary steps. May I have the lights, please, and the slides off? I'm not done. Now, what should be done? What is a reasonable set of responses to this new oracle, this set of mutually supportive prophecies by the different scientific oracles, with some differences between them, of course? The main problem is the burning of fossil fuels. When you take a lump of coal and burn it in the oxygen of the air, the carbon in the coal combines with the oxygen in the air. Carbon, C, oxygen, O2, makes CO2. It is an irreducible consequence of the burning of coal, oil, natural gas, petroleum, wood, and so on. One thing surely that can be done is to have a more efficient burning of those fossil fuels. So, for example, in this country, the United States, by the way, is the worst carbon dioxide producer on the planet. The Soviet Union is the second worst. And if we were to lump all the countries in the developing world together, they would represent the third worst producer of carbon dioxide. And therefore, it is very important to remember that this is an issue we are all in together. We are all in this greenhouse together. Certainly the countries that have the largest responsibility, have the largest contribution should have the largest responsibility, but everyone on the earth is producing this stuff. More efficient burning of fossil fuels. Almost a third of U.S. production of carbon dioxide comes from driving cars and buses, trucks. Why do we drive cars that get 20 miles per gallon when it is perfectly feasible in an engineering sense to have cars that get 60 miles a gallon? If everybody got 60 miles a gallon, everybody could go as far as they ordinarily go, and we would have reduced the amount of CO2 put up into the atmosphere by internal combustion engines by 2/3. And this goes across the boards. Every area of energy use can be made more efficient by feasible technologies. And by the way, if you think of the development of these technologies, it becomes very clear to capitalists that there is money to be made in dealing with the environmental issues. It's not that the coal, oil, gas, and auto industries are going to go bankrupt because they may have to change their ways of doing things. On the other hand, just the opposite. This has a wide range of investment opportunities for smart corporations. Second thing we should do is to make large-scale research and development investments on alternatives to fossil fuels. The paradigm of these alternatives is solar power, which converts sunlight into electricity or sunlight into hot water, producing no polluting gases, no greenhouse gases, no radioactive waste. And such systems are within hailing distance of being competitive with other means of generating electricity. If we were to include, even in our minds, a kind of tax on the fossil fuel industry for the damage that they do every time some CO2 goes into the atmosphere, solar power would be fully competitive right now with the burning of fossil fuels for those regions of the country that, that have sunlight. I happen to come from a place in upstate New York which has sunlight only rarely. The third thing that we ought to do is massive reforestation on a global scale. Growing trees take carbon dioxide out of the atmosphere. They are a kind of anti-greenhouse machinery. We plant a forest, CO2 gets taken out of the atmosphere. There is a corporation not far from here called, I think, Applied Energy Systems. It's in Arlington, Virginia. They are building a power plant, I think maybe coal-fired, in Connecticut, anyway, somewhere in the Northeast, which will, of course, put carbon dioxide into the atmosphere. What AES has committed to do is to plant a forest in Guatemala, which will take out of the atmosphere the same amount of carbon dioxide that its power plant will put into the atmosphere over the anticipated lifetime of that power plant. That's an example of responsible corporate behavior. Instead of planting forests, we humans are destroying forests at an amazing rate of an acre a second. An acre of land every second is denuded of its trees worldwide. This is stupid and should stop. And the final mitigating step that I want to call your attention to has to do with the population of the human family. All of these other issues, no matter how heroic we change our practices in fossil fuel efficiency, in finding alternatives to fossil fuel, in planting forests, they will all come to naught if we don't do something about the rapidly increasing population growth on the planet. Every human has to burn fuel to go about his or her daily lives. The more people, the more greenhouse gases. Now, let me just say a couple of words about that. There is a very mistaken view that you sometimes can come upon in the developed world, that the problem with population growth in all those poor countries is that those poor people don't understand why they should limit their population. or that there is an unavailability of birth control devices. I believe that the situation is very different from that. I believe that the billion poorest people on the planet tend to have many children out of a careful cost-benefit analysis. If you're very poor, it doesn't cost much to raise children. They might be helpful in carrying the water and the wood. Since no one is educated, you don't have to pay at all for their education. And if a few of them survive, they might be able to take care of you in your old age because your country doesn't provide anything like Social Security. It makes sense on the time scale of a human lifetime, under such circumstances, to have many children. And it is clear, if we just look back in the developed world, a few generations, the generation of my grandparents and great-grandparents, for example, people had huge families. They do not have them today. Why not? All over the world, there is a very interesting phenomenon that's been called the demographic transition. And it occurs east and west, Buddhist countries and Catholic countries, communist countries and capitalist countries. And it goes like this. When the per capita income is raised above a certain very low level by American standards, the population growth rate automatically turns down. People make that cost-benefit analysis anew and decide to have fewer children. The solution, the principal solution to the world population crisis is to raise the standard of living of the poorest people on the planet. And so if we wish consistently to follow through the implications of our proper concern about global warming, we must address the issue of poverty. And I believe in the old adage of providing not fish, but fish hooks. There are ways for the developed countries to provide self-sufficiency, to help provide self-sufficiency for the poorest people on the planet. And the cost can be readily estimated. And the key fact is that it is enormously less than the amount of money that we spend on arms every year. The world military budgets are now at $1 trillion. $1 million every year. A modest fraction of that would be enough to raise the standard of living of the billion poorest people on the planet. And there's one other aspect of that, and it has to do with the status of women. There are a few places on the planet which have substantial per capita income and still have very large population growth, and they are all places, I believe, where the status of women is very low, where women are not educated, are not permitted to be educated, and are not co-equal with males. So I think a very sober, non-ideological approach to these issues would drive anyone concerned with these global environmental issues to the reduction of poverty and the increase of the status of women worldwide. You don't have to have any sense, it seems to me, of the justice or humanitarian aspects of these mitigating steps, although they're obviously there. You only have to be concerned about the future of the planet, and you're driven in that direction. Yevgeny Yevtushenko, in his stirring poem, talked about moral autumn. It seems to me that if we merely have a sober assessment of the situation facing us, we could automatically find ourselves in a moral spring. There is one final aspect of this issue I'd like to mention, and that is molecules don't have passports. Molecules are very stupid. They do not understand the importance of the concept of national sovereignty. They do not recognize national boundaries. And on those pictures of the Earth from space, it's very hard to make out the national boundaries. The national boundaries are man-made. The Earth is really there. So carbon dioxide or CFCs put up by one nation do not stay over that nation. They are carried by the general circulation of the Earth's atmosphere all over the planet. And therefore, we are all in this together. These global environmental issues have a fascinating trans-ideological, trans-national, and transgenerational character. They force us to think of the planet as a unity. They force us to think about our responsibility to future generations. There is a passage in the Bible, in the book of Proverbs, which sometimes haunts me. It goes, "They set an ambush for their own lives." If we do nothing on these global environmental issues, that's what we will be doing. But if we use our intelligence, which is the secret of the success of our species, if we use our ability to foresee the future consequences of present actions, if we draw upon our common humanitarian feelings, then I think that we are fully capable of solving these problems and in the process making the world a far better place than it is now. I wish you all success in your work.
We have time for only 3 questions. If you do not speak in English, please do not hesitate to ask your question anyway. We have headsets up here as well. So anyone who would like to ask a question, please raise your hand and stand, and we will repeat the question for those who might not hear it. 3 questions. Who would like to ask the first?
Going on back, like the CFS have a hazardous effect on the ozone layer. Fluorocarbons destroys the ozone layer. Also knowing that 80% of these gases are produced in the northern part of the Earth. In spite of this, the ozone layer is destroyed less and more in the thousand more. I need an explanation.
The questioner, who Senator Gore tells me is from Egypt, asks the perfectly reasonable question. The CFCs are mainly made in the northern hemisphere, and the biggest destruction of the ozone layer is a hole over the continent of Antarctica, as far south as you can go. How does this come about? The answer has to do with the circulation of the Earth's atmosphere, the movement of air at high altitude. The CFCs are remarkable They were invented by brilliant chemists who were motivated to find a perfectly harmless and inert molecule to use as the working fluid in refrigerators and air conditioners and other useful functions. They made a molecule so inert that it's impossible to destroy it down here. So the molecule leaks out of an air conditioner, and it bounces off molecules in the air, it bounces off telephone poles and buildings, does no damage to it at all. Eventually, they are carried to stratospheric altitude, and it's there that they meet ozone molecules, their match, and destroy them. But that circulation carries the CFC molecules all over the planet, including to the South Pole. And there is a vortex of polar air and a kind of cloud that is prevalent there. And it's that mix which makes the greatest destruction of ozone happening over the South Pole. However, there is evidence of the ozone layer thinning at many other latitudes. And Senator Gore reminds me that there is one not quite as thin yet over the North Pole. Other questions?
Why did carbon dioxide increase 10,000 years ago?
Here is a question rather similar to the previous one. Why did carbon dioxide increase 10,000 years ago? Surely there were no fuel inefficient automobiles then. The carbon dioxide content of the Earth's atmosphere has been oscillating, varying within certain limits over as far back into Earth history as we're able to determine. The important point, and the reasons obviously do not involve human beings or human technology, or probably not. 10,000 years ago was a special time for humans in which our numbers were growing very much. It was the end of the last ice age, and maybe we had some contribution there, but before that, surely not. There are a set of natural processes which increase or decrease the amount of carbon dioxide in the air. The more growing trees, for example, the more carbon dioxide, the less carbon dioxide in the air. And forests and plants are destroyed and grow for all sorts of reasons, including the motion of continents and the impact of objects from space. But the main point is that the variation of the carbon dioxide has been within limits and is now rising out of that range that it has in the past. And that rise out of the range is, without a doubt, due to human activity. Senator Gore, do we have time for another question or two, or has the hour come?
One more question.
I'll be glad to repeat the question.
I was very impressed by the example that you gave about power plant and the reforestation of Guatemala. But my question really is, instead of focusing on reforestation, should we not also focus on conserving whatever remaining tropical forests we already have but are fast diminishing? And it so happens that, by coincidence, the only remaining tropical forests on Earth happen to be in debt-ridden countries around Central Zaire, Western Amazonia, and Southeast Asia, including the Philippines. And our country, for example, have 15 million dwellers in the upland areas, putting pressure on the forest because there is no alternative livelihood. And if 46% of our GNP goes to debt service, there is no way we can help out these people. And the forest is going fast, It'll be gone by the year 2000. And I'm not sure if that situation is the same in other countries. Now, since the creditor countries, by coincidence as well, happen to be the CO2 producers, and we all live in one ecosystem, can we not have some kind of a burden sharing so that we would be able to conserve our forest? Number one. Number two, companies also, because of their preoccupation on the bottom line, do all sorts of stupid things. Our preoccupation on GNP without consideration of the cost of environmental degradation or destruction also lead us to do all sorts of stupid things. I understand there are countries in Europe that are now imputing in their GNP calculations the cost of environmental degradation and destruction. Is there a way this can be, on a worldwide global scale, also be a development in the future? Thank you.
Thank you. I clearly made a mistake by not asking you to come up here. That was a very eloquent statement. Thank you so much. Well, the question had several parts to it. One was the distinction between growing forests and conserving forests. And surely existing forests should be conserved, not so much because they take carbon dioxide out of the atmosphere, but because they are a unique repository of species diversity. We are destroying plants and animals. I don't mean individual animals. We are making species of plants and animals extinct so that they will never live again on Earth at an appalling rate. I don't think we have a right to do that in the first place, and in the second place, there are many practical uses that such plants and animals can have for the human species. So it's foolish, as you correctly said, to do that. Secondly, the question is said in places like the Philippines, where he comes from, the forests, the remaining stands of forests, old forests, are being destroyed because poor people need the trees for lumber, for firewood, and so on. And this is connected with the large fraction of the gross national product of such nations that goes to the retirement of debt. The questioner asks if, international debt, the questioner asks if we're all in this greenhouse together, and if the developing countries, the ones that have lent the money, are the biggest polluters on the planet, might there not be a reason for them to ease the debt retirement requirements? Or you didn't say this, but maybe you meant cancel them altogether. You want my personal opinion? Absolutely. The idea of a crushing debt burden prevents education, it prevents development, it prevents the demographic transition which is needed to control population growth. And this then brings me to the last point, which has to do with the distinction between short-term and long-term goals. If we always focus on the short term, we will lose. We have to simultaneously worry about short-term and long-term issues. Now, for politicians, there's a particular concern here. There is a temptation to take steps which will have benefits during the term of office of the politician. In the United States, this is 2 years for representatives, 4 years for presidents, and 6 years for senators. But the issues we're talking about are 10, 30, 50 years in the future. If politicians are only concerned about the shortest term turnaround, so that the benefits of their policies can be reaped while they are still in office, then the need to make long-term planning is going to be missed. But there's one way in which long-term and short-term objectives can be joined, and that is if politicians who are solely devoted to the short term are voted out of office. Then eventually there will only be politicians who worry about the long term. So you know what you have to do, and those of us who are not politicians know what we have to do. Thank you.
Carl, may I tell them that you'll be around after dinner? That's a burden on you. Carl Sagan has said that he will remain here in this room visiting with those who did not have a chance to ask a question, and will be glad to talk with you individually about the questions after we conclude our formal session here this evening. Let me make 2 points before we call it a night. First of all, anyone who wishes to speak during this interparliamentary conference will have an opportunity to speak. We want to hear from all the voices that are represented around the world here in this room. Please let us know when you would like to speak during the discussion of the working group reports or during the debate on Wednesday morning on the conference resolutions. And we will make certain that you will have an opportunity to speak. We heard in the last question an important message that those of us from the developed world must hear during this conference. Carl Sagan said during his address, the issue of the global environment is linked to the issue of poverty. Interdependence is one of the themes we will be discussing. The second point in closing is, we want to begin our sessions this week promptly at the hour indicated in the program. Tomorrow morning, for example, 8:30 a.m. means 8:30 a.m. Please be on time because we will begin at 8:30 a.m. Thank you all very much, and join me in thanking Carl Sagan again for a wonderful speech. Thank you, Carl.
We invite you to join us on Tuesday morning at 10 Eastern Time for live coverage of a Senate Appropriations Subcommittee on Foreign Operations hearing on the fiscal year 1991 budget. Secretary of State James Baker is scheduled to testify. Up next, more remarks from the Interparliamentary Conference on the Global Environment.
Get the opportunity to look at some recent White House photography. That's Sunday beginning at 10 p.m. Eastern Time, 7 p.m. on the West Coast.
Coming up next, we bring you remarks by William Riley, Administrator of the Environmental Protection Agency, and Professor Carl Sagan, who spoke this afternoon at a Caring for Creation conference sponsored by the North American Conference on Religion and Ecology.
Good afternoon, and I want to welcome you to this significant session of the Intercontinental Conference on Caring for Creation. From around the United States, north of us in Canada, and from other parts of the world, we have people who have come to look at their religious commitment in a new way, to care for creation, to save the earth. This afternoon we are particularly, I might say, blessed and honored to have three very significant people who will be with us to share their light and their insight and their commitment to saving the earth, saving the planet and the ecosystems of the planet. Our first speaker, and one who has an exceedingly busy schedule, just got in from the Bergen Conference and other things in Europe, I believe earlier today or last night. I didn't go. Oh, you didn't go to Bergen, okay. Rerouted, okay, that's all right. We're working on things, but has been going from, I might say, meeting to conference to Parliament to White House to major leaders around the world, bringing with him a vision and a commitment to conservation and environmental understanding and values in a way that is very significant in the 1990s. And for that reason, we are going to do something very special that I think, and the Board of Directors of the North American Conference on Religion and Ecology in a particular way, think is appropriate. And it's an award called the Eco3 Award, which I will presently explain. Through its Eco3 structure called the Eco3 Trialogue, the North American Conference on Religion and Ecology proposes to facilitate collaboration among ecumenists, ecologists, and economists. The meaning of the prefix eco comes from the Greek oikos, meaning household, family, community. All three collaborative partners share a common interest in the household of the earth. Ecumenists are those who come from the various faith communities, religious organizations, and spiritual traditions. They are working together from a shared faith or value perspective to renew the face of the earth and to care more responsibly for creation through their interfaith household. Ecologists are those who have an expertise or interest in the environmental or conservation movement. They also see scientifically that the household of nature, ecology, is in grave danger and now warrants a call for deeper ethical response to save the Earth's ecosystems. Economists, literally those who manage the household, are those managers and stewards who have the skills and responsibility to make the Earth community run in a just and sustainable fashion. These economists may be leaders from the public sector or the private one. They can be elected representatives or environmentally minded government people, business people, philanthropists, investors, executives, as well as trained economists. William Riley, administrator of the Environmental Protection Agency, is given this award by the North American Conference on Religion and Ecology in recognition of his work in three areas. First, for his record as a conservationist. In his public and private life, William T. Riley has devoted his professional life to environmental issues. Throughout his career at the World Wildlife Fund and now as administrator of the Environmental Protection Agency, Mr. Riley has inspired his colleagues, offered vision and clarity to legislative and private initiatives for improving life on this earth and creating a significant platform from which to involve everyone in the process of environmental renewal. Secondly, William Riley is being given this ECO3 award for his long-standing and continued dedication to the spiritual dimension of the environmental issues confronting us today. Mr. Riley recognizes that for today's citizen, to be religiously committed means to be deeply committed to environmental issues and personally involved with caring for creation. William Riley has not only preached this reality, but has practiced it as well in the exemplary model of his own personal commitment to caring for Mother Earth. And thirdly, Mr. Riley is receiving this ECO3 award for his early and continued support of the efforts behind this conference. At a time when most of the environmental community had not yet begun to grasp the importance of the religious dimension, the value dimension to the environmental crisis, William Riley not only understood this fundamental fact of reality, he acted upon it by becoming one of NACRE's initial supporters and funders through his position as president of the World Wildlife Fund. For these reasons, we award to William T. Riley this afternoon the ECO3 Award, and we give him something that will remind him of his history and of ecology and of the environment. And as I give him this Waterford crystal vase full of beautiful spring flowers, I want you to know that we wanted to have not just a plaque, or not something simply to hang on your wall, but you may be getting one of those too. But we're giving you this, Bill, with really sincere thanks and a heartfelt feeling within the community here that you are a genuine leader who combines the best of both a spiritual commitment to see that we must care for creation and a respect for science and economics that makes you realistic in this pursuit. Thank you.
Thank you.
Yeah, we'll put it on the...
Take it right over this.
I better just announce
Oh,
you
okay.
have to... Because of the very rapid nature of his work and the unbelievable amount of things to do, Bill Riley will have to leave us after his talk, but I believe his presence among us both honors us and connotes the very important decisions we are making here in responding to the bioregional plans and calling forth religious leadership to work with scientists, ecologists, and economists to make this a truly sustainable and regenerative Earth. Bill Riley.
Well, thank you very, very much, Don. That is a moving introduction and really a touching dedication and perfectly appropriate gift. These spring flowers, the early fruits of the spring creation. I am very honored to be the first presented with this ECO3 award, and I'm particularly touched to be recognized in the category of economist. I fear that you may do violence by that categorization both to the profession and perhaps to my reputation in some quarters in one fell swoop. But, and in other quarters, I guess I have to confess, you will simply astonish by suggesting that degree of sensitivity to economics on my part. But from my point of view, it is a very satisfying honor that you confer on me, and I really appreciate it. I'm here to discuss issues to which I attach great significance with many old friends and some colleagues. And I'm here, I should warn you at the outset, as is often true, I find, in my present position, to talk about a lot of things that I probably know much less about than most of you. That hasn't deterred me yet, and a lawyer, there are those who would say a lawyer talking about moral and spiritual values should be disqualified at the start. But I do feel strongly about some of these issues. I compliment the concerns and efforts that have brought you together, and I very much hope that they're successful. I think they're vitally important to the achievement of objectives that certainly as Administrator of EPA are very important to me in my public duties, and I think more fundamentally significant to the spiritual development and to the reconciliation of humans with nature, which I take to be our common concern. One of the most interesting and arresting phenomena in nature is the coming together of two great rivers, the Missouri and the Mississippi north of St. Louis, the Allegheny and the Monongahela, which join together at Pittsburgh, the Rio Negro and the Solimões that form the mighty Amazon at Manaus. From the air, as I remember, particularly in the case of that latter great confluence, it's possible to see how two great rivers flow together for a time without fully merging, each retaining its distinctive color, its mud, its minerals, or even its pollution. But finally, they flow into each other, and they become broader and far more powerful than either tributary. Such confluences occur not only in nature. When men and women of faith marched and suffered at the Selma Bridge, their message in word and deed was that racism is evil. They added a vital moral force to a movement to reform the law, a force that joined a demanding and irresistible moral current to the milder movement of our laws. Together, moral indignation and legal reform created a new reality, and as a result, civil rights received an enduring sanction. This conference of ecumenists, economists, and ecologists must aspire to create such a confluence. It is time to recognize, I think, both the achievements but also the limitations of the movement that has been called environmentalism. It is time to acknowledge the important spiritual dimension that the community of faith can bring to efforts to protect the environment. Fundamentally, environmentalism is about reconciling humanity more satisfactorily with the natural systems upon which human life and civilization depend. During the past 20 years, the United States has made great progress in protecting its environment. My friend, the writer Rice Odell, has identified three great achievements of environmentalism during this period. First and most obviously, the air is more healthful. Rivers and lakes are cleaner. Parks and wilderness preserves are larger and more numerous. Whales and bald eagles are coming back. Second, Americans have a genuinely new way of looking at things. We are somewhat more future-oriented and set quality of life concerns of health, safety, the experience of unspoiled nature, alongside economic growth and materialism. By no means have we abandoned our economic aspirations. Economic growth during these same 20 years was significant, and it generated the wealth necessary to pay for pollution control. But we have redefined our economic aspirations and have adjusted them and have imbued them with new concepts that represent more demanding expectations. We speak now of sustainable development and recognize
a wider web of life in which we see ourselves dependent on a natural order that embraces other species. To some of these species, humans have always shown affection. The furry animals come immediately to mind. But increasingly, while we may not love the swamp rat, we do exhibit a certain reverence for the distinctive life form he represents, and our laws provide some protection for the niche in nature he occupies. This reverence is a rationalist, not a religious sort of thing. It's based on a Darwinian insight that all life forms are related and ever-evolving in a mutually supportive progression. We may need the swamp rat, depend on him even in ways science has yet to discover. Maybe he thrives on a pest, regulates a natural system, has some still to be determined role in keeping it all going. We are not certain. That very humility in the face of natural phenomena is an environmentalist innovation. What we don't understand, we forbear to disturb, alter, or destroy. So often, humankind has gotten it wrong where nature was concerned, that there is wisdom in technological caution. A third great achievement of environmentalism has been its development of some key legal concepts and its advancement of their acceptance and effect. The need for public analysis of environmental impact of decisions, the reasonableness of demanding that alternatives be considered, the right to know about toxic emissions from plants, the right to sue the government without claiming an economic interest. These once novel ideas have been advocated, advanced, and codified in law. They're generally accepted by the society as reasonable and necessary to good government, and their influence is profound. In Odell's view, these reforms have contributed to a more refined democracy and have conspicuously advanced the democratization of society. Well, I have described some of the contributions and achievements of environmentalism. These reforms were conceived in 1960s protest, born in anger and outrage at pollution you could see, touch, and smell. Now they have become accepted, but they are not enough. The world today faces two kinds of threats that require more than mere laws to address. First, while we have confronted and tamed many of the most egregious sources of pollution, at least in the United States and Western Europe, we now must come to grips with pollution sources that are scattered, diffuse, and individual. We must come to grips with individual behavior and with the consequences of the way we lead our lives, with very high levels of waste per capita, with water pollution that does not come from the end of a pipe, but that runs off farms and city streets, and with air pollution that comes from cars idling in congestion. Our laws work less well at confronting problems of this scale, and so the Bush administration is seeking new ways to fashion laws to design economic incentives that reward behavior that is environmentally responsible. Government command and control approaches may well have taken us about as far as they can. The second kind of threat that we have only recently begun to understand and acknowledge is the danger posed to the global environment, the threat to the very stability of critical life support systems of the planet. Our discovery of the ozone hole over the Antarctic, more recently over the Arctic, have revealed how destructive human activity can be and how far advanced it can become before it's identified. Correcting for ozone depletion, and that ozone hole now is as large in size as the continental United States, will take many decades. Long after humans have ceased to manufacture the chlorofluorocarbons, these long-lived chemicals will still be migrating up to the stratosphere and destroying its protective layer of ozone, exposing us all to more cancers and more cataracts. I have frequently spoken to the need to foster economic incentives to address environmental problems. I believe very strongly that we must work to ensure that economic incentives line up with environmental goals for protecting the ozone layer, or reducing acid rain, or conserving tropical forests. But it also is increasingly clear that we must go beyond compulsion, laws, and incentives. We must engage the heart, which is not reached by appeals to law or science. In 1986, the Duke of Edinburgh, in his capacity as president of the Worldwide Fund for Nature, convened representatives of 5 major religions in Assisi to prepare statements about human responsibility for nature. Christians, Jews, Hindus, Muslims, and Buddhists all joined together in a beautiful and historic act of celebration, of prayer, in the historic Basilica of St. Francis, the church where the saint is buried. Each of the representatives of the religions in attendance, and later the Baha'is and the Sikhs, issued statements setting out their faith's theological basis for supporting the conservation of nature. Each of these faiths came together, reflected, and on the basis of their tradition and their history, their scripture, prepared thoughtful theological statements. And these statements are very powerful appeals to the faithful, to believers, to recognize the implications of their beliefs for their conduct regarding the environment. The reasoning behind initiatives such as the Assisi meeting, and I guess this conference as well, has been expressed in an insightful series of lectures by John D. Zizioulas, Eastern Orthodox Bishop of Pergamon. He's written of the great confidence Western societies place in ethics, whether enforced by legislation or taught by churches. However, he argues, by appealing to human reason, we do not necessarily make people better. While moral rules, especially after their dissociation from religious beliefs, prove to be more and more meaningless and unpleasant to modern man. There are, he writes, other forces, besides the human intellect, that decide the direction in which the fate of the world moves. Theology and the church ought to embrace areas other than the ethical, that is, the rational prescription of behavior, if they are to be of any use in this case. Well, as a government official, my concern is necessarily with laws. For you, as leaders of the community of faith, the focus is on values and fundamental beliefs. You, therefore, deal with the whole person, not merely with behavior, but with the well springs that feed a fuller worldview. Where I am concerned with pollution, you are concerned with creation and with the basic relationship faith should imply for conserving the natural order. I congratulate you on coming together, on uniting ecumenists, economists, and ecologists to reflect on the fate of the earth and on the full dimensions of individual personhood. President Bush spoke to the duty of the individual during a visit to Spokane, Washington last September. He said, through millions of individual decisions, simple, everyday personal choices, we are determining the fate of the earth. The new alliance inaugurated here today can make a powerful contribution to inculcating that sense of responsibility the President spoke to. This alliance will help us, as Don Conroy put it, to dream a new dream of the creation truly renewed, a dream of a creation in which we all care for the air, for the animals, and for the ecosystems. In his 1990 World Day of Peace message, Pope John Paul II added his voice to the growing number of religious leaders who have recognized the spiritual dimensions of environmental problems. Last January, I called upon the U.S. Catholic Conference to issue a pastoral letter on nature and the environment. I set out several specific issues such a letter might usefully address. And I call upon you to do the same thing within every North American faith tradition represented here today. In the next year, I would like to see each faith, each denomination represented here, formulate its own authoritative restatement of the moral and spiritual basis for the stewardship of nature. These statements could have a powerful influence for environmental betterment on individuals, on policymakers, on business leaders, on citizens of all faiths. Although I realize that one very powerful message of this conference is to go back to your home communities with action as opposed to words, I hope that one result of that action will be the statements for which I am calling, statements that I think could have a significant impact on parishes, on churches, on communities all across North America. Such statements, I would hope, would make a significant difference, not only in the making of laws, but also in the keeping of laws. There simply are limits to what laws can achieve. Among the burdens of modern life that chafe upon free and creative people are layers of requirements, rules and regulations administered by large bureaucracies. Surely one of the sources of alienation and discouragement in modern life is the daily encounter with large organizations to whom ordinary individuals just don't seem to matter very much. Try as we will to limit our laws to issues that really do matter to the well-being, health, and safety of society, we contribute sometimes to a deadening of the spirit. And the truth is that laws cannot ultimately do all that we ask of them. To that discovery, we must not respond by adding ever more restrictions and requirements. Instead, we must respond by recognizing the role of education, of non-governmental groups, and of belief. I would urge you not to direct your recommendations to government, but rather to individuals. Let me be clear. Whether in caring for the poor, or achieving racial justice, or protecting the environment, government has a large and vigorous responsibility. But it is not enough. When consumers buy green products, when drivers use clean fuels, when people opt to recycle or improve energy efficiency, these are decisions that, made on a large scale, can matter more than laws. And you are in a position to inform and inspire such choices, to give greater meaning and significance to everyday decisions, not as imposed requirements, but as willed and informed personal commitments. This society, I believe, is open to such values. We aspire to be more than a civilization of consumption and consumerism, a throwaway society that uses, discards, and then moves on, leaving its mess behind. We do not want to define success merely as having more, but also as being more. You in this audience and the institutions you represent are concerned as much, probably more than others, with defining what it means to be more. So I wish you well, and I thank you for listening to this lawyer bureaucrat go beyond his brief. Thank you very much.
Thank you.
To introduce our next speaker is a man who has shown the ability to touch the life of the church in the 20th century and of all religions by his both intellectual and ringmaster ability, I might say. He has the ability to convene all types of people, from the President Havel recently, the magnificent ceremony in St. John the Divine, to stand with Dr. Carl Sagan in Moscow, with Secretary Gorbachev in January, when they made the appeal to scientists and religious leaders to join hands to save the earth. So without further ado, I give you Dean James Parks Morton.
Well, my friends, I have the honor of introducing to you Carl Sagan, but it's really like introducing a scientist in the scientific realm who corresponds in the religious realm, say, to introducing the Dalai Lama or to Archbishop Tutu or to Mother Teresa. Because on the one hand, they're all household words. You know, when you sort of think religion, you say, well, yeah, like Mother Teresa. And when you think science, you sort of say, like Carl Sagan. But so much more, because those three religious folks are certainly amazing exemplars of their particular faith traditions, but you can't keep them in a box any more than you can keep Carl Sagan in a box, because he's all over the place, and that's what's so fantastic. But before introducing him, I do want to say something not about the august folks who are up here, but about the august folks who are out there. Because I think what makes this Washington meeting really very interesting is the fact that bringing together sort of religious folks who are involved in the environment is really new. At the Cathedral, we've been involved in environmental programs since 1972, and we really could count on perhaps one hand other religious organizations in America, because we were really looked upon as strange ducks. You know, I mean, you're religious people, well, why are you concerned about rivers? You know, why are you concerned about green things? And all you have to do is read a certain cardinal who happens to live in New York's sermon on Earth Day to find out where religion still has to go to get the message. But you folks, who by and large are lay people, have been the people in the trenches in the environmental movement. And you've been doing that out of your synagogues or out of your churches or just out of your own convictions in your own backyards and in your own city lots. And that, to me, is what's so extraordinary about finding an occasion when you, who are really the fighters in this peaceful war, are in one room. And so, with all due respect to those on the platform, I think the real credit is to those who were in the round tables, and I salute you. Now, into introducing Carl. We go back about a decade. We started a series of free concerts at the Cathedral on New Year's Eve, and he and Leonard Bernstein sort of took the cake, and they were that was the first one. And Carl spoke about, on New Year's Eve, nuclear winter. That was how many years ago? When did you? 84, okay, 6 years ago. And part of our loneliness at St. John the Divine has been that our buddies in this have really all been scientists and some anthropologists and some philosophers. René Dubose starting with us in 75, and Lovelock in 79, and Bucky Fuller in 80. And it's nice to see some of the people who are here, Brian Swim and Peter Berg, really we've been working with, but we haven't been working with, quote, religious folks because there weren't any that we could, you know, sort of reverse collar types, with the exception of perhaps Tom Berry, and we were saying up here, Professor Joe Sittler at the University of Chicago. There were very, very few professional, quote, quote, religious types in, on the environmental agenda. And so that's the great change. But Carl was one of those heroic scientists who dared to go into one of these hot religious places. We just emerged from a press conference, and you know, he was asked, was he an atheist or was he a theist? And you know, he'll give you an answer in a minute. But it was really wonderful. Now I'm going to do two things. I'm going to tell you all the stuff that Carl has done. And it's going to be very. I'm not going to tell you all the stuff he's done because there's 2 pages. You'll all go to sleep. But he is the David Duncan Professor of Astronomy and Space Sciences. He is the director of the Lab for Planetary Studies, and these are both at Cornell. And he played a leading role in the Mariner and the Viking and the Voyager expeditions to the planets, for which he got the NASA medal. He's published more than 600 scientific papers, but like Bishop Tutu, they're not just, you know, in-house stuff. He's written many, many popular books, and he got the Emmy and the Peabody Award for his television series, Cosmos, which I'm sure many of you saw. It was in 60 countries, and it was looked at by 300 million people. And then that, of course, had a book along with it. So his just extraordinary output and recognition in the scientific community, but in the larger humanistic community, is extraordinary. Well, that's one thing. But what I want to sort of leave you with in introducing Carl is this really amazing thing that comes out of his understanding of things, which is very political. And it's an effort that we've been involved together in, really starting in 1988, when together we were part of a remarkable conference in Oxford, along with Mother Teresa and the Dalai Lama and a great cast of characters, on trying to get the political community and the religious community joining forces. And after that, and in preparation for the Moscow conference that was just this past January, we thought, wouldn't it be really important, even more important than political and religious leaders, to get scientific and religious leaders making common cause for the saving of the environment. And Carl will describe this in detail, but starting a year ago, we put together, and he sent out an appeal to a number of distinguished scientists around the world, Nobel laureates, scientists in this country, in France, in Israel, in Russia, all over the place. And when their responses came back, and the request that he made was, we want to make common cause with religious leaders. Are you with that? Some 37 most distinguished men and women around the world said yes. And this appeal is on the table over there, so get a copy as you leave the session. And then I assume the responsibility for sending the appeal with the signatures of the 37 scientists to religious leaders around the world. We now have some 300 signatures of really top people in the world saying, yes, we religious people want to make common cause with the scientists so that together we can work to cherish the earth. Now that's going to take a long time, but what it does represent is really a new threshold. But new thresholds are what Carl Sagan's all about. So, Mr. Threshold.
Thank you, Jim, for that most generous introduction. I'm very happy to be here with you, and because we're about half an hour behind schedule and I had wanted to leave time for questions from the audience, I'll try to shorten what I had intended to say. This is a most peculiar issue, that humans have become, in this innocent manner, a danger to themselves. We're not here talking about nuclear war, where at least there is some intent to do harm. We're talking about the most innocent acts of burning a lump of coal or developing a harmless and inert material to act as the working fluid in refrigerators and air conditioners. Who would have figured that that would pose a danger? When we started out, we humans, a few 100,000 years ago, or if you take the genus Homo, maybe a few million years ago, there were, of course, very few of us. We lived in East Africa. Our technology was rudimentary, and we had no idea of posing a danger to the global environment. We didn't have an idea of there being a global environment. Nevertheless, if contemporary hunter-gatherer societies are any guide, we had a very profound sense of living in harmony with nature, as all the rest of the plants and animals do, because those who don't are dead. And so natural selection produces such a harmony, and there's no question that we were part of such a harmony. Now imagine the pages falling from the calendar. The advantage of the human species, selective advantage, is our intelligence, our ability to foresee the future consequences of present actions, and our hands, which permit us to build. And with those tools, we have gone to every part of the earth. Some of us live under the oceans. Some of us live in space. We have been astonishingly successful. Our numbers now are 5.3 billion, and our technology has reached formidable, if not awesome, proportions. If there was no concept of having stewardship of the earth a million years ago, today there is at least a very great need. If you stand back from the earth, as those Apollo astronauts did in the late 60s, and photograph the earth from a distance in space so you can see the whole earth, there's this blue aura that you can see surrounding the daylit hemisphere. And it's just the atmosphere seen edge on. And what is most impressive, what many astronauts have remarked upon, is how thin, how fragile, how vulnerable it seems. The thickness of the Earth's atmosphere compared to the size of the Earth is about the same as the thickness of a coat of shellac on a library globe of the Earth. There isn't much air. And so we now have the prospect of inadvertently endangering the life-supporting environment, the environment that supports the human species and many other species, of committing what religious people sometimes call crimes against creation. There's a wide range of these problems that I know you've talked about at this meeting. There are some local, some regional, and some global. Let me talk about the two of the global issues, in part because they are among the most serious, and in part because they force upon us a way of thinking which is novel to many, although it certainly has deep roots in the world's religious communities. Those two problem areas are ozone depletion and greenhouse warming. The ozone layer, if brought down to the pressure and temperature of this room, would be about that thick, about 3 millimeters thick. There isn't much ozone. It protects us against dangerous ultraviolet light from the sun, which, if not impeded, if it could reach the surface of the Earth, would produce a range of catastrophes. The one that's most discussed is skin cancer, especially in light-skinned people like me. Dark-skinned people are much better protected. And that certainly would be serious, but that's minor compared to the other longer-term consequences, which include a challenge to the human immune system, the ability to fight disease. If the ozone layer is breached and people have to spend some time out of doors, it's something like getting a global case of AIDS, except there's nothing special you have to do to get the AIDS, except keep voting for the same politicians. And then still more serious is the fact that increased ultraviolet light damages the microorganisms that are at the base of the food chain upon which the rest of us depend. So the simplest example of this is the oceanic food chain, where at the ocean surface there is a community of one-celled microscopic plants called phytoplankton. And they harvest sunlight. They're primary photosynthetic producers. But since they're at the surface of the oceans, if there's more ultraviolet light getting through the ozone layer, they are vulnerable to a depletion in the ozone layer. Well, these guys are eaten by little one-celled animals, which are eaten by little shrimp-like crustacea, which are eaten by little fish, which are eaten by bigger fish, which are eaten by, and so on. And then at the top of this ecological pyramid are dolphins, whales, and people. And on the land, there is a similar food chain in which, again, the primary photosynthetic producers are vulnerable. So if you eliminate the organisms at the base of the food chain, then the rest of the food chain collapses as well. That's the ultimate danger of ozone depletion. Greenhouse warming is the buildup of invisible gases. Their invisibility is precisely part of the problem, because you can't just by looking see that there's a danger, which keep the heat in and build up the temperature of the Earth, producing great regions of drought in continental interiors, including the American Midwest, and through the volume expansion of seawater and the melting of polar ice, sea level rising. And some of the projections for the end of the next century are extremely serious: drought, the destruction of croplands worldwide, an assault on natural ecosystems, and a rising of sea level sufficient to, for example, flood Bangladesh and produce tens of millions of environmental refugees. These problems are very serious. They are happening, however, slow enough that it's possible to do something about it. The slowness is an advantage in that respect, but a great disadvantage in another respect, in that the changes are occurring on timescales longer than the terms of office of politicians. If a politician can take a presumed unpopular action, which will, in his or her estimation, benefit the politician while still in office, then that's the kind of risk that politicians are willing to take. If the benefit, however, happens 10 or 30 or 50 years in the future to benefit some other office holder, then from the narrow perspective of getting reelected, it's not nearly so attractive. These long timescales represent one of the novel problems of these global environmental issues. Now, I want to stress that we are not absolutely certain what the configuration of danger will be. For the ozone layer, we can already clearly see it. There's no question of, is there an ozone depletion? There is this enormous hole over Antarctica, about which William Riley talked, a smaller one over the Arctic, and a clear thinning of the ozone layer at intermediate latitudes, including the latitude of Washington. And the telltale chlorine atoms of the CFCs have been found in association with the ozone depletion. So there it's very clear what's happening. You stop making CFCs and other sources of ozone depleting chemicals, and the ozone layer will, on a time scale of 100 years, heal itself. But note the time scale. Make heroic actions now, and the ultimate benefit is a century hence. Delay longer, the healing is also delayed longer. On greenhouse warming, there is not yet so clear a signature. There is a range of what in this business are called sophisticated computer models, but of course they're only as sophisticated as the people who write the computer programs. But there are 5 different such programs. They all give consonant answers. They predict correctly the very different climates of, say, Mars and Venus. Venus, by the way, having a surface temperature of 900 Fahrenheit, hotter than the hottest household oven, hot enough to melt tin and lead because of a massive carbon dioxide greenhouse effect there. I'm not suggesting that there were once a species of Venusians who drove fuel-inefficient automobiles, and that's why Venus is in trouble. But the idea of an Earth-like world gone to such hellish conditions is worthy of note. By the way, the surface, this is a theological aside, the surface conditions of Venus are remarkably similar to the classic religious view of hell, in case you have to confront a skeptic who wants to know where it is. I thought I'd provide a little help here and there on theological matters where I am able. Those same computer models correctly predict the past climate of the Earth. They correctly predict the present climate of the Earth. It is reasonable that they are correctly predicting the future climate of the Earth given the amount of CO2 and other greenhouse gases that we're pouring into the atmosphere. Maybe not. Maybe there's some undiscovered mistake that all of the scientists involved in these models are making. It's not impossible. We can't be 100% sure. But which is more prudent? Which is wiser? To do nothing and hope that a mistake has been made? Or to take these predictions seriously, even if there's a chance the precautions you will take will be unnecessary? I want now to come back to this issue by discussing what it is that has to be done. And then let's think about them in the context of, will we really be angry at ourselves for having taken these steps if the computer models are wrong? So what should you do? First thing you should do is stop producing CFCs, the chlorofluorocarbons. See, they do double duty. Not only do they destroy the ozone layer, they are an important greenhouse gas. They'll get us one way or another. So we should stop producing them. And indeed, in a remarkable and important agreement of most of the relevant nations, there is a so-called Montreal Protocol in which essentially all the CFC producing nations except for India and China, 2 important exceptions, have agreed to cut by 1/2 their production of these molecules by the turn of the century. It's important, by 1/2 their production of these molecules by the turn of the century. It's important, its precedent is important, but it's not nearly enough. Those gases should be reduced to 0. That's the first thing we ought to do. Secondly,
to mitigate greenhouse warming, we should use fossil fuels more efficiently. By that I mean, if I had a car that went 70 miles a gallon instead of one that went 25 miles a gallon, I would not be putting as much carbon dioxide into the atmosphere for each mile that I go in driving my car. This is a kind of technological solution or mitigation of the problem. On the other hand, there's not something that we can do as individuals. I cannot go and drive a 75 mile per gallon automobile because they are not commercially available. So it's no good to tell me, as my friend Mr. Riley did, that we shouldn't complain to the government or the industry, we should just do it ourselves. How shall I go about by myself driving a 75 mile per gallon automobile? I'll be glad to take instruction on this issue. I'm ready. But seems to me this requires some activity in Washington and Detroit. Ultimately, we're going to want to phase out fossil fuels. We're going to want to convert to an alternative energy economy. And what that is, we can still discuss, but in my view, it is unlikely to be nuclear power for all the obvious pollution concerns, and much more promising is solar power, which produces no greenhouse gases and does not involve radioactivity and is already economically competitive with fossil fuels if we take account of the environmental cost of the burning of those fossil fuels. That's the kind of technology we should be after. And incidentally, because developing countries tend to be located in equatorial latitudes where there's more sunlight, this is also an ideal kind of technology and could be, for them, and could be much more indigenous, that is, the technology homegrown, than big fission or fusion reactors. Then we should grow trees. Trees take carbon dioxide out of the atmosphere. We need massive reforestation on a global scale. Instead, what we are doing right now is destroying an acre of forest every second. Think about that for just a second. There goes an acre. Whole acre of forest every second, day after day, year after year. We're being extremely stupid. And then the final thing, in my view, which has to happen, has to do with world population growth. Because even if we took the most heroic measures about stopping the production of CFCs and making much greater fossil fuel efficiency, and then on a longer time scale converting to alternatives to fossil fuels, and grow enormous amounts of new forests, even then we would be not out of the woods at all if the number of new humans overwhelms the steps we're taking. We're taking. Every human being has a right to live, and what's more, even in exceptionally poor countries, in your everyday life, you produce carbon dioxide. So if we look at who are the biggest polluters on the planet in terms of greenhouse gases, number one by far is the United States, something we should take just pride in. Number two is the Soviet Union. Number three is the developing countries put together. So it's not an issue of high technology versus low technology, although that per capita, of course, Americans do much more than people in Equatorial Guinea. But even people without elaborate industrial economies make significant contributions to the burning of wood to the greenhouse problem. And by the way, I can talk about it in the question period at greater length, but in my opinion, the only appropriate way of approaching the solution of world population growth is by helping to raise the per capita income of the poorest billion people on the planet. It's a thing called the demographic transition, and it happens in capitalist countries, in communist countries, in Catholic countries, in Buddhist countries, East and West. It's fabulously ecumenical. And what it is poor people have lots of children not because they're stupid and not because they don't know about birth control, although those things, having birth control access helps, of course, but because they make a kind of desperate cost-benefit analysis that if their children are dying at an enormous rate, if they have lots of children, then there might be some to survive to help with whatever the domestic economy is, and maybe even survive to such a time when the parents are too old and would help the parent. It's the only available social security for 1 billion poor people on the planet. When the per capita income rises and there are alternative sources of help for the meager plot of land and help for the old age of the parents, then without the government ever saying a word, the population growth rate turns around. And I find this is true of many Americans. Think back 3 generations in your own family. How many children did your great-great-grandmother have? How many children do you or your siblings have? And you will see a substantial drop in almost every case in the birth rate. And that has happened because the economy has improved, the per capita income has gone up in this most affluent nation. Those are the steps which need to be taken. How many of them can be done by individual effort? It seems to me that this is a case where the main driver has to be government and industry. And there is, of course, a role for individuals. And that is one of the blessings of democracies. And that is, individuals can play their part by voting out of office recalcitrant politicians. It's very straightforward. I can't improve the greenhouse effect much on my own, by my own energy economy at home. I can make some contribution, but I can make a bigger contribution by voting against politicians who say that they can't do anything about this problem. There was 2 or 3 weeks ago in Washington a international conference on the greenhouse effect hosted by the White House. This is the one where the White House was accused of urging study rather than doing anything, of going slow, of stressing uncertainties, to the enormous annoyance of delegates from all over the world, especially from Western Europe. There's almost nobody who supported the United States position on this. And at the end, U.S. delegates were reduced to saying, oh, we're not just for studying, we want to do things too, but didn't specify anything in particular. There was a very telling diagram in the White House handouts. It was stressing the complex issues involved here, and each issue that was stressed had a little cartoon to make it clear to people who had difficulty reading what the issue was. And there was one issue called balance. And what it showed was a traditional pen scales, 2 trays. In one tray was the planet Earth. And then balancing it on the other tray were 4 bars of gold. A balance. 4 bars of gold, the Earth. Well, don't want to fix the Earth because it might cost money. I think that is a very revealing as well as a very bad example for the White House to be telling us. Yes, economic growth is important. Yes, it's even conceivable that poor people benefit if rich people make more money. But if the environment that sustains all of us is significantly deteriorating, I suggest that even the people who are making money are going to be in trouble. Industry is going to be in trouble. The national economy is going to be even in more trouble. And this is the classic battle between short-term and long-term, which is central to the issue that we're fighting. Well, in an attempt to try to deal in a practical sense with these issues, as Jim Morton mentioned to you, it occurred to us that this was a time for science and religion to see if they could work together on this most important question. So I wrote an appeal, was able to get a number of very distinguished scientists from many nations, men and women, to sign it. And then, through the good offices of Dean Morton, this appeal was distributed to the world religious community, or some representative sample of it, with very striking success. The letter that was sent to religious leaders was signed, besides Dean Morton, by Theodore Hesburgh, former president of the University of Notre Dame, the Reverend Leonid Kishkovsky, the president of the National Council of Churches, Sheikh Ahmad Kuftaro, the Grand Mufti of Syria, and Elie Wiesel, Nobel Peace Laureate. And in the brochure put out by the Cathedral of St. John the Divine, there's a list of the categories of signatories: 37 heads of national and international religious bodies, 50 cardinals, lamas, archbishops, head rabbis, patriarchs, mullahs, and bishops, 17 indigenous religious leaders, 55 professors of theology, seminary presidents, cathedral deans, heads of religious orders, and so on. It's breathtakingly ecumenical, who the signatories are, and I think shows a very great promise that religious people worldwide recognize that this is a serious issue and are willing to work to solve it. I'd like to read to you the last part of this appeal. We first describe some of the issues, as I have done here, and then go on to say, by their very nature, these assaults on the environment were not caused by any one political group or any one generation. Intrinsically, they are transnational, transgenerational, and trans-ideological. So are all conceivable solutions. To escape these traps requires a perspective that embraces the peoples of the planet and all the generations yet to come. Problems of such magnitude and solutions demanding so broad a perspective must be recognized from the outset as having a religious as well as a scientific dimension. Mindful of our common responsibility, we scientists, many of us long engaged in combating the environmental crisis, urgently appeal to the world religious community to commit in word and in deed, and as boldly as is required, to preserve the environment of the earth. Some of the short-term mitigations of these dangers, such as greater energy efficiency, rapid banning of chlorofluorocarbons, or modest reductions in the nuclear arsenals, are comparatively easy and, at least at some level, are already underway. But other, more far-reaching, more long-term, more effective approaches will encounter widespread inertia, denial, and resistance. In this category are conversion from fossil fuels to a non-polluting energy economy, a continuing swift reversal of the nuclear arms race, and a voluntary halt to world population growth, without which many of the other approaches to preserve the environment will be nullified. As on issues of peace, human rights, and social justice, religious institutions can here too be a strong force encouraging national and international initiatives in both the private and public sectors, and in the diverse worlds of commerce, education, culture, and mass communication. The environmental crisis requires radical changes, not only in public policy, but also in individual behavior. The historical record makes clear that religious teaching, example, and leadership are powerfully able to influence personal conduct and commitment. As scientists, many of us have had profound experiences of awe and reverence before the universe. We understand that what is regarded as sacred is more likely to be treated with care and respect. Our planetary home should so be regarded. Efforts to safeguard and cherish the environment need to be infused with a vision of the sacred. At the same time, a much wider and deeper understanding of science and technology is needed. If we do not understand the problem, it is unlikely we will be able to fix it. Thus, there is a vital role for both religion and science. And then the last paragraph reads, "We know that the well-being of our planetary environment is already a source of profound concern in your councils and congregations. We hope this appeal will encourage a spirit of common cause and joint action to help preserve the earth." So I'm very encouraged that this document, which I consider to be not pulling a lot of punches, has received such strong and ecumenical support. I'd like to conclude with just a couple of other remarks. There is a passage in the book of Proverbs that haunts me in this context, although of course it wasn't written in this context. It goes, "They set an ambush for their own lives." And it seems to me that through the unthinking development of our enormously powerful technology, we are in danger of doing just that. But it is certainly not too late. We have caught the problems early enough, and all it takes is a deep, committed dedication to solve these issues. And it seems to me that there is a peculiar silver lining. And it goes like this. Molecules don't have passports. They're exceptionally stupid. They don't understand the profound importance of the idea of national sovereignty. So you strike a match or burn a lump of coal or drive your car, and the carbon dioxide is wafted up and carried by the general circulation of the Earth's atmosphere everywhere. No one nation can solve the greenhouse or ozone depletion problem. It has to be done by everybody on Earth. It requires a global effort. So these problems, as I said in the appeal, have an intrinsic trans-ideological, transnational, and transgenerational aspect to them. It doesn't matter what your ideology is. If you want to resolve these problems, you're going to have to work closely with other nations. And if you truly want to understand what this issue is about, you must be concerned about generations as yet unborn. It seems to me that binding up of the earth and of the generations is something that many religious traditions have talked about, and here is a case in which if we do not embrace these broad and grand perspectives, we are in the deepest of trouble. I believe we are an intelligent species, we are equal to this task, and we are about to see a transformation of human society. Thank you.
Superb. Is Dr. Malone? We have the chairman of our board, Dr. Thomas Malone, to introduce the next speaker, who is a theologian who has, over the years, done some rather remarkable and penetrating studies that probe into faith and reason, in naming the whirlwind, and in other things. I'm going to ask for Dr. Malone, where are you? There, oh, there he is. He's going to come and yes, we're going to have the questions after Dr. Gilkey. And so the chairman of our board, Dr. Tom Malone, is widely known in the halls of science and in other realms as one of the chief atmospheric scientists and one of those who deal with global realities. I won't go into all his pedigree and all his works, but as immediate past president of Sigma Psi, the scientific society, and international secretary for the National Academy of Sciences, he has done much to advance the cause of science at this crucial time. And in facing the global crisis, he has challenged and encouraged us in the faith communities of the world to take up a new challenge. Tom Malone.
Thank you, Don. The deliberations of the past several days, it seems to me, have confirmed the conviction that an increasingly interdependent world society is at a crossroad. Three options lie before us: to snuff out civilization with a nuclear exchange. That's one. Second, to strangle civilization by exceeding the carrying capacity of planet Earth. And there's a third option, is to use our innate reason and intrinsic creativity to see a probable future and to envision a possible future consistent with the dignity of individual human beings. And what is required, and it says so in the book of Proverbs, where there is no vision, the people perish. We've just heard an example of a man with great vision from the scientific field. And now we're going to hear someone who has a corresponding vision from the field of fundamental moral values and beliefs. A noted author, a consummately profound thinker. We're privileged to hear him. And out of the creative and dynamic interaction with the grassroots and speakers like we have here before us, I think we can rest assured that there is a future for humankind. Dr.
This platform with Professor Carl Sagan. To me, two quite unexpected events surprised us this winter. One was the collapse of communist regimes in Eastern Europe. The other, to those of us who are observers, the thawing, if I may put it that way, of Professor Sagan's well-known attitude towards religion. And his willingness, which I welcome, to join with representatives of religion in caring for the earth. My delight to be here with him more than equals my surprise. Our present relations to nature are mostly indirect, utilitarian, and contrived. Nature is, for our practical existence day to day, primarily the supply house of raw materials for the industrial goods and the varied services we need in modern urban life, and the dumping ground for our refuse. Through scientific technology, we have come thoroughly to dominate nature, to remove most of her threats to us, so as to use nature for the purposes of our own well-being. Only our sporadic need for leisure promotes a different relation to nature. That's symbolized by the weekend or the summer vacation. This is hardly mutuality, interdependence. It remains dominion of a sort, but were it not for the political weight of this role of nature for our leisure, crying out for an unspoiled nature, the practical relation of technological production would log, strip mine, develop, and then pollute the whole thing bare. It is strangely appropriate that both Professor Sagan and I be here as representatives, perhaps, of science and of religion. For science and religion alike are deeply involved in the burning issue of nature. Each, both as part of the problem and potentially, as we've heard, as part of the answer. Science has provided our main and now our sole cognitive relation to nature. It is through science, physics, chemistry, astronomy, geology, and biology that in our age we feel we know what nature is, that is, what its reality is. It is further a dogma of our time that our only way to know is through science. And so nature is for us what the relevant sciences define nature to be. The heavy, not to say tragic, consequence of this for our subject comes from the fact that scientific method objectifies whatever it seeks to know. Thus, as known by science, nature becomes a system of objects, entities with external relations, with no inwardness, no for-itselfness, a system made up of homogeneous, quantitative, and quite purposeless parts. And because it is not for itself and has no value of its own, is not a reality, so to speak, in itself, nature becomes a fit realm to be used by our technologies for our purposes. Science knows officially only quantity, homogeneity, and causeness. An inert, vacuous, to use Whitehead's scornful term, purposeless, valueless, material nature. Nature as mere object becomes fit to be nature as raw material. No wonder Herbert Marcuse said the picture of the world modern science provides, if taken as all there is to nature, is the ideological justification for the industrial exploitation of the world. The scientific understanding of the world as a system of objects and the scientific development and underpinning of technological industry have prepared first our minds and then our instruments for our fatal exploitation of nature. Yet, it's recognized, I say this as I see my colleagues taking notes, yet let us recognize, unofficially if not officially, science portrays a much more mysterious nature than it can scientifically describe. A cosmic development strangely ruled by telos, as Brian pointed out the other night. A wondrously fecund creative nature capable of life, of ideals, of even the scientific observer. A nature full of new and unexpected, random yet meaningful turns of wondrous novelty and diversity. This mystery of nature, yes, one may say the divine mystery, is intimated in every cosmology, even if it is scorned by scientific positivism. Another factor, however, must share the blame. Our religious tradition, the so-called biblical tradition. This is not simply a matter of dominion. To countless generations, that divine command to dominate the earth meant hunting, herding, fishing, clearing, and farming, precisely the cooperative relation of mutuality that preceded modern life. It did not, because it could not, imply the absolute control and use that make exploitation and desecration possible. Whatever they did to their own towns, medieval men and women hardly polluted Europe's rivers, made toxic its soil, killed its forests, fouled its air, or created the warming effect. Dominion has become destructive, and hence one can say demonic, only when it became a total and unchallenged dominance. When the theoretical know-how and the right instruments were there for our absolute human control. And that has only been in the last 3 modern centuries. The fault of the so-called biblical religions, Christianity and Judaism, lies deeper. Ironically, precisely in that which is most creative in these traditions. The first element is familiar, the desacralizing of nature. In these traditions, God is one and transcendent to nature. Nature's forces, therefore, cease directly either to be or to manifest the divine. Nature is thereby stripped of both divine and demonic powers. This is surely a gain in understanding God. However, it is more ambiguous for our understanding of nature. This desacralization prepared the way for the strictly reductionist, mechanical, and inert understanding of nature that appeared with the development of modern science and modern technology. The desacralization of nature stripped nature of its sacred creative power and its inherent value. More importantly, our religious traditions failed to replace that sacred status with the apprehension of nature as a sign and instrument of the divine glory and the divine creativity. Secondly, for the common Jewish and Christian traditions, insofar as there is a common element, it is not nature that holds center stage, but people, with them community, and also history. The religious relations of God to men and women, and the moral relations of men and women to one another, represent the major concerns of true biblical religion. In none of this does nature figure in any really significant way. It is, in effect, merely the temporary stage on which the drama in present history of the relations of God to human beings and of the latter to one another are played out. Thus, in both traditions, nature is radically subordinated to history, as in earlier Christianity, history was subordinated to eternity. Nature has thus, in effect, been religiously ignored or demoted, creating a religious vacuum, so to speak, into which other interests could and did rush. The creative, religious, and moral command to honor, love, and serve human beings to recognize human dignity and to protect and increase human value, immensely creative for our subsequent cultural life, did not apply to nature. Nature had no soul. It is there only as an object among objects for our use, a means and not an end to which we were unconditionally obligated. In all of this that I've described, as if staged by a providential demon, we note how our scientific knowledge on the one hand, our technical and industrial power, our religious traditions, and our present sociological locus, most of us live in a human world, a world of human constructs, towns, cities, highways, colleges, factories, office buildings, not in nature, have worked together to lure us in the West into forgetting nature, while nonetheless, with the other hand, looking, one may say, the other way, we have pillaged, robbed, and exploited nature. As Senator Gore so eloquently said yesterday, neglect, indifference, even ignorance, are in no way innocent when they cooperate with, in fact, make possible exploitation. As dominant over nature, we threaten nature. As dependent on nature, we are thereby ourselves threatened. Because we are, as humans, in some strange ways more than nature, we can and do threaten her. Through all that makes us more, our intelligence, our practical ingenuity, our infinity of will, through the human in us. That same more, incidentally, which makes science and the scientific observer possible. We are also, however, part of nature. In fact, nature's child, a dependent and mortal creature among natural creatures, and thus we are threatened. The ecological crisis with nature reveals the paradoxes of our human being and our ambiguity, especially our moral ambiguity. Through the very wonder of our science and technology, wonders whose praises Professor Sagan has so persuasively sung, the terrible vulnerability of our contingency and mortality, as well as our ruling greed, have become manifest. Of course, if we were rational, we would at once control ourselves and cease to exploit and destroy. But we are not rational. Such self-control seems, for the moment, beyond us with regard to exploitation. We are also will, infinite desire, a seemingly unlimited greed, as well as objective observers. We seem not to want to save ourselves by saving nature, a kind of modern writing of St. Paul. Not if it requires real self-control and real sacrifice. Yet even more paradoxically, it is our very rationality, as modern culture has defined rationality, scientific inquiry, technological innovation, industrial practicality, and organizing genius, that together threaten nature, and with nature, that same rationality. The paradoxes of human being portrayed by every profound religious tradition, but often ignored in a secular culture. Humans as infinite and finite, self-transcendent and creaturely, willing the ideal and yet enacting the destructive, image of God and yet fallen, to put it in the terms of my own faith, are evident here. The ambiguity of human beings vis-a-vis nature is as vividly portrayed in our modern scientific and industrial encounter with nature as in the most primordial of fertility myths and ritual sacrifices. Modern scientific culture has not matured itself out of our ancient historical dilemmas and self-contradictions. Rather, it exquisitely illustrates them. And dominant now over the fate of both history and nature, as in many an ancient myth, is an old enemy, in fact, the oldest one, the final one, our own waywardness. For ruling over science, over technology, over industry, over our own politics, and so over our common history is what the Buddhists have termed desire, and our own tradition concupiscence, an infinite greed for goods, driving us where we don't want to go. The rescue of nature is necessary, and I agree, nothing in history is without hope. This is a fundamental religious apprehension. Its grounds are different in every religious faith, but we all share it. This is, first of all, of course, an issue for science. It has been morally concerned, and amazingly idealistic scientists like Professor Sagan, who have first understood and first warned us about these dangers, and who know, if any do, how we might deal with them. It is secondly an issue for public policy, and so for politics. And I suppose that's one reason we are in Washington. At bottom, however, these are spiritual matters, matters on the one hand of attitude, and on the other of moral choice. By attitude in this case, I mean our sense of kinship with nature, our sense of respect and of moral obligation to nature, and so the drive, deeper even than thought, to act in harmony with nature. But note, such spiritual attitudes depend on what we think the reality of nature to be, how, therefore, we also know nature. Spiritual attitudes lie back of all fundamental political movements and changes, as changes in Eastern Europe now witness. It is because of changes in such attitudes of respect for the other, of commitment to justice, and the discipline necessary for self-control that our tragic racial situation has eased a little bit. The new roles for women have also appeared. When spiritual attitudes change, laws can change, not before. Ecology is thus in part a religious issue and our responsibility. At the basis of political action lie spiritual attitudes to oneself, to others, to nature, to God. How we use our scientific knowledge, how we control or do not control our industrial and our commercial development, these depend also on our common moral choices as communities. And I agree thoroughly with Professor Sagan, these cash out into political action. And these depend, in turn, on our sense of obligation, the depth of our commitments, and above all, on our openness to some measure of self-sacrifice. Interestingly, in the most ancient religions, sacrifice, even self-sacrifice, realities that horrify the modern soul, was always necessary if men and women were to restore their abused or broken relation to nature. There is hardly a primordial myth that doesn't tell this story of the broken relation to nature and the need of some sacrifice to restore it. This gives me the creeps in relation to our present problem. The same now applies to us. Only if we have the moral self-discipline to be prudent, and prudence requires moral self-discipline. It requires control on ourselves. Can nature be saved? As we are learning, in order to enact, in this case, our clear self-interest, namely the rescue of nature on which we depend, immense self-discipline is necessary. Who would have thought these so-called primitive themes in relation to nature, the themes not only of the sacred creativity of nature of which I've spoken, but also of discipline and sacrifice, would return as relevant, even essential, to modern technological civilization? And let us recall this: such inward changes in us, the dominators, are in this case especially important. Here there are no exploited voices to cry aloud, no oppressed persons to march in our streets, to protest, to act in political rebellion. We can, if we will, continue to ignore all of this, continue to pursue our glut of consumers' goods, and die. Our rationality, our ideals, our good intentions being ruled by our greed. How then do fundamental spiritual attitudes change? For on them, we have suggested, depends the possibility of new moral obligations, commitments, and choices. And on these latter depend the possibilities of new public or practical policies towards nature. Both religion and science are part of the problem, as I've tried to note. Let us see how they might help in these changes of attitude. Attitudes and moral obligations represent, needless to say, especially the area for which religion feels responsible. We will therefore begin there. I wish to suggest an obvious but slightly heretical notion. Perhaps most creative notions are heretical. I don't know. History of theology seems to hint that, if not say it. We should proclaim and teach that nature is an image of God, imago Dei, a creature that is also a sign or symbol of God, as are we. Hence, nature has value in and for itself, as do we, an inherent integrity, order, and worth that we must respect as we do in the case of another person. Nature is a thou, as the great Martin Buber said, an image of its creator, and thus not merely our instrument or material, but a genuine other to us. Nature shows forth, mirrors as an image, the glory, the power, the wisdom, the infinity of its creator and preserver. In fact, the God of the Hebrew and the Christian scriptures is one imaged continually and conceived through the signs and traces provided by the grandeur, the power, the immensity, the order, and the beauty of nature. It is through analogies from nature, as well as from persons, community, and history, that God becomes God. Nature is not only a sign of God, it is also of ultimate concern to us. For the nature is the source of all life, and so of the future of life. Nature is, as nothing else is, our mother and creator. We not only tower over nature as observers and users, as scientists and technologists and vacationers, As creaturely humans, we all are also absolutely dependent on nature. Thanks to evolutionary science, we now know this in a quite new way, namely, that it is through nature that God has brought us into being and preserves us there. Interestingly and ironically, we have returned through scientific inquiry in our own age to this knowledge possessed and celebrated by all primordial religion. Let me reiterate this. Our changed scientific understanding of our origins has transformed, or should do so, our sense of our dependence on nature. Heretofore, most Western men and women have recognized their dependence in the present on nature for air, for food, for rain, and so on and on. But traditionally, in our minds, the creation of men and women by God was seen as a quite separate event from the creation of nature by God, as, so to speak, independent or separate creation. But now, believing Jews and Christians, who also accept, as do most of us in this room, the evolutionary account of our origins in nature, we now understand God's creative work in a quite different way, and this can be emphasized in all of our religious groups. God has created us as humans through nature, through the long, slow processes of development in nature, the long cosmic, geological, and finally biological processes that have produced first our cosmos, then our world, then life, and finally ourselves. A process of creation, though without its theological frills, elegantly described by Professor Sagan. In this sense, as for the earliest religions, nature is in fact our mother, the instrument God has used to produce us, much as God produces each one of us through our own mother and father. Our dependence on the divine for our existence in life is directly expressed in our dependence on nature. As primordial religion knew, in nature lie the sacred powers of life, of fertility, of community, of health, and of security, as well as the powers and order of existence. Both our scientific and our religious inheritance have heretofore been quite blind to this. One final word then about science, reality, and nature. As we have seen, as the creative source of our existence or being in all its facets, nature as infinite, as power, as order, life, and beauty, the reality of nature far transcends the inert, determined, external, vacuous system of objects pictured by empirical science. Although that scientific description is itself alive with deeper implications of mystery, implications of spontaneity, of novelty, of random changes evolving into life, with its self-direction, its purposes, its feelings, reactions, and finally consciousness and self-consciousness. Nature reveals itself in us as living subjects. It reveals itself in us as being, as power, and as life. And it reveals itself around us as strange, magnificent power and order. It is not only an object of our inquiries, it is also the living source of our being, including the being of the objective scientific inquirer who looks at and defines nature. Nature thus manifests itself to us as more than all we can know or ever could know of it. It manifests itself in ourselves as subjects as well as studied objects. as a mystery in part only fathomed by our empirical investigation. Science represents a wonderfully accurate, but nonetheless limited perspective on this wondrous mystery of the universe and the cosmos. The reality of nature creates us, supports us, lures us. It offers itself to our inquiries and to our use, but it eludes our final understanding as it will elude our final domination. This sense of nature's mystery, of its sacred mystery, and of its depth, integrity, and richness, and inherent value, can well supplement our attempts to objectify and so to use nature. Thus can a renewed, chastened, and humbled science, like a renewed and humbled religion, become a participant in the homage to nature rather than the cognitive basis for its exploitation. And only thus, in chastened partnership, can we begin to control that exploitation so as to rescue nature from ourselves, her children. Thank you.